we have solutions that are refrigerated by air, as well as air cooling, water and air cooling, and configurations that can supply needs of every application, such as pulse, 12 pulses, 20, 24 pulses, what the goal of meeting needs of our harmonics distortion, ability to customize, such as container solutions, optimize space, 131 programming for IEC 61131, bus protocols, and anything else you can think about. We have 6 examples of rectifiers. There's a high potency rectifier. Second one is our star, which is Unirec. And here, a piece of equipment which my other colleague, Rafael Farak, will speak about a bit more later, a smaller rectifier. Speaking more about this portfolio, we will be dealing with the rectifier. We'll be splitting this into 3 capacities, basically. A rectifier with 1 voltage up to 1500 volts, 4 kiloamperes will be within the presentation for the afternoon. I'm already having an ad for Rafael Farak, a plug for Rafael. He will be talking about this technology where we can deal with full waves or few GBT, and he will explore a little bit more regarding the advantages, the pros and cons of each technology. We have Unirec. It covers a pretty interesting range, especially looking towards electrolyzers nowadays. We can get to 4K to 24K and get to 3500 volts for electrolyzers. And there's another ABB product which we'll not be speaking about here, but it is available as well, which are high potency rectifiers for voltages above 24K. So what are the most critical challenges which OEMs are facing today? Well, guaranteeing performance of a unit when it comes to availability and efficiency and maintenance costs. This is a key point, to have the availability, to have trust, constancy. Maybe being constant is an exaggerated word. Be able to trust the equipment that you're purchasing so that when you need to generate this hydrogen, you will absolutely be able to. This equipment will be available to generate it. Otherwise, the sun's shining and you're generating energy, but you can't turn it into hydrogen. So it ends up being kind of a useless thing. Committing to the performance of the system without knowing the terrain. ABB has the capacity to commit to performance. Why? How does ABB do this? Well, ABB has been around for 65 years with knowledge in electrolyzer, experience within this sector, so they are capable of doing this, which eventually other suppliers do not have this ability, this history. Conformity to the network code, this is important because it avoids penalties, it avoids transients, and it avoids cases of energy blackouts, as we had one recently, maybe due to a lack of coordination in the network and the grid. This is relating to grid codes. ONS is actually researching, or they are actually researching the causes. So ABB is a partner that will guarantee you that you will not put something in the system that may compromise or may cause a chain reaction within the system that will cause a problem for you. Selecting suppliers, minimizing capex, tourniquet solutions. What do we have here? Basically, we have the closed hydrogen cycle. We have the energy generation goes through the rectifier. The electrolyzer converts the energy, electrical energy, into hydrogen, and we have the available hydrogen for transportation. But Unirec H2 is a solution you can see for our hydrogen process. Now we're aiming more towards our little animation here, where we will be speaking about the transformers and Unirec rectifiers. We'll be speaking about this specifically inside the electrolysis plant. As I said, ABB has a long history, a lot of rectifiers. That's an important differential that we have within Unirec. It's the modular conception. It's scalable. So you have bridges here that you will be adding like parts of a puzzle so that you can reach higher and lower voltages. So this allows us to have a project flexibility as we're able to meet the needs of several configurations of electrolyzers for voltages that are demands that now they come from the market with a minimum amount of interference from the product. We managed to adapt the product quite easily without an engineering effort that will demand a lot of time and will be very costly for our clients as well. Electrolyzers today, well, why is this scalable solution so important? Typical electrolyzers of 1 megawatt, they are still in the market, be they membrane electrolyzers or catalyst electrolyzers, they're still in the market. And you have these electrolyzers, they are in a row so that you can reach higher voltage plants. So if you have a 5 megawatt, but you have 5 electrolyzers for 1 megawatt, you put them as a series, as a battery. This will increase voltage. If for every project of one of these, a 2 megawatt hydrogen plant or 5 megawatts or 10 or 15 megawatts, you need to project a different rectifier. The engineering effort, dynamic effort of the business itself will be affected. So our solution, our modular solution, has this advantage because we add modules in a parallel. No, no big mystery. Reaching these voltage indicators. So air-cooled indicators. Air-cooled modules, I can get to 4,500 amps. They can be scaled to 18,000 amps. So it's a compact solution. One of the advantages that this one has regarding other technologies on top of trustworthiness and the capacity to generate higher voltages, higher tensions. It's just a low space usage. So I'm going to use a solution that is sort of a keto or maybe LGBT, maybe the space, the physical space used will be larger. So the rectifiers can also be extracted. As the air-cooled ones, we have this Unirec solution. Due to the fact that they are air-cooled, we can reach higher voltage levels. They are scalable up to 2400 amps. Sorry, 24,000 amps, and have a higher potency regarding the space used. So I can get more voltage out of the air water-cooled one in a smaller space, and space is a pretty big deal. And cooling is done in closed water circuits. Showing a bit more of what Unirec is, of the way it is here, and the scalable solutions. We have a setup that, and well, the number of pulses can be undefined or defined here by 6, 12, 18, or 24 pulses to optimize the harmonic distortion. Rectifiers can be extracted, redundant cooling, and a completely scalable design. You can see that when we have an increase, when I have an increase in voltage, I'll have a lowering of the current, which is what this graph shows. Our solution, or standard solution, goes up to 1000 volts. So with 1000 volts in the module, I can get 4500, can be scaled to 4, or slightly higher voltages, and I can reduce the current a little bit. Same deal. I have a water-cooled. The difference is the water-cooled one has an exchanger. I go in with raw industrial water, and I perform this heat exchange towards a deionized water circuit, which goes through semiconductors. Also, in a setup can be 6, 12, 18, or 24 pulses. Scalable design as well. The difference is that the heat exchanger, I can reach higher voltages, higher current levels. So we have a photograph in the upper left side for you. That's a photograph, an image of what our module looks like, our water-cooled module. Very nice. So we have another differential here. Our product is the controller. The control board is dedicated for the so their energy system, which is the one we use. We use this in our Unirec H2 as well. On top of this, we have the IHM, tactile IHM. You can be operated rectifier as well as you can monitor the cooling unit, and you have the option of having the arc detection system, arc guard system, in case you have an internal arc in the rectifier or the installation, you can immediately turn it off if electricity arcs. So here's a little bit of what is the topology. This image is showing the transformer, which is a key item to adapt the voltage to the needs of the electrolyzer, diminished harmonics. So in this solution, this is an optional solution. We have an OLTC, which is a subcharge commutator to be able to reduce the harmonic distortion factor. And I focus on this. It's a control. We can control the HTC, which is not obligatory. We can work with it without it. And you have a fiber optic connection with the controllers with the voltage. So this guarantees a total isolation between the control side and the potency side. When we need to, we can apply on the exit reactors to be able to reduce the effects, the ripple, the wave effects, and we can minimize the rectifier area as well. Other topologies are shown here, for instance, examples of application where we have Unirec being applied to a potency of 7,180 amperes with 2 rectifiers where we have 15,000 amps, 900 volts with 4 rectifiers in parallel, configuration for 12 pulses. And the other one, I have a higher voltage, so I have 0 rectifiers. And this third side here, you have 0 rectifiers to be able to reach 9100 amperes and 900 volts, and I have this condition here, rectifiers in parallel to electrolyzers, 9000 amperes. So the big idea here is flexibility and scalability of our product. Here you have examples. They're just 12 pulses, but for instance, I could feed this pair with one transformer and relating to the other, 12 pulses, and I can also have a 24 pulse system. You don't need to have a harmonic filter anymore or an active filter to be able to compensate. So with the scalability of Unirec, we can get several solutions depending on the needs of the client. On top of this, we have the digital service part. We have digital twins that we can simulate, which would be the behavior of the system, because from the moment where you introduce electrolyzers and rectifiers, you must have a common the coupling points, studying the coupling point to understand what is the impact in terms of THD, in terms of voltage on that bar, and what is the mitigating action you must take. This is something that's very important before we start the project, maybe before we even specify the rectifier, because ABB really wants to be able to collaborate with the studies, with the input, so that we can discuss with our client, we can speak to our partner, what is the optimized solution in this scenario. So it's a pretty important part. On top of this, on the maintenance side, we can have a guided maintenance through augmented reality. So I have a Unirec, and I can just maintain it with 3D VR glasses. Another important thing to focus on is ABB's global presence. We have the Excellence Center for this product in Switzerland. And we also have regional centers in Canada, China, India. On a great pride, I say we have an excellent center in Brazil, in Sorocaba, and ABB with the capacity to produce this product, with the capacity to meet your needs, to support you, back you up in this market, which is positioned strategically for this green hydrogen boom, which we expect will happen. Well, a few references here. So I can finish presentation. Recently, we provided to PERIC, which is an electrolyzer factory in China, a rectifier will be installed in Infinium in Texas. This was done this was connected to a wind energy source and solar energy source to produce hydrogen, and the hydrogen production combined with CO2 there, this green hydrogen produced through these renewable sources in a process with Infinium has there combined with industrial CO2 results in a low carbon fuel. So ABB is part of this project. Already delivered the Unirec there, and it will be commissioned at the end of the year. Here we have a photograph of a small Unirec, just one module. This photograph of the container was a pretty interesting solution as well. You can see the image of the container of the Peric itself. ABB provided this for the project which I talked about to you. What is the advantage of the container solution? Well, it's an in-house solution. You just go to the client, you got this solution ready, it's been tested, it's essentially integrated. On top of the Unirec, here you have the average cubicles, you have a filter if you need it, you have an automation part, you even have a fire safety system. It's all set up already. So this is ready for the client. You just need to show up, plug it in, and make it work. It's plug and play. So you have the container once again from another point of view. Well, that's it from me. Once again, thank you for your attention. If you have any questions or doubts, well, here I am, and my contacts are here as well. Sorry. My contacts with them. We can please go back to Antonio's contacts, please. And that QR code right there. There's there's your slide, and there we go. Here you can see. You can have my contact. There's my LinkedIn. There's the ABB contact, and also there's my virtual card. You can scan the QR code. Feel free to speak to me. No, go back. I'll be back up. Okay. Look, there's a question here from Antonio. Despite the capacity to adapt of the Unirec equipment, there are several factors. In your opinion, which is the main challenge today of ABB when in this market, Antonio? If you kindly answer that. I would say that we are very well positioned with solutions. ABB has solutions. The big challenge is to integrate solutions through partners, through companies which are willing to cooperate with us, with ABB, cooperate together and build solutions for the hydrogen market. I'd say that the big challenge today is consolidation, in my view, of the market. This natural organizing, let's say, that we're still sort of in that, we're like a ice block sort of bouncing and sort of falling apart a little bit. And things need to sort of set themselves up because looking for partners and the way you fit these solutions in a viable manner so that you can reach the chain and you'll be able to close this chain. That's a big challenge, not just for ABB, but for all of us. And that's why we're here to interact, to be able to understand, and to be able to get past this challenge together. Great. Ladies and gentlemen, Antonio Cruz, round of applause, please. Manager for Engineering, Antonio, wait for your presence. It's great to have you here in FIEC Summit 2023. Welcome, as always. I ask that you go back to your audience.
I'm seeing new faces here from the beginning of our program. Welcome, everyone. Welcome to the Technical Auditorium of FIEC Summit 2023. Do you all see the QR code? I cordially ask you to take a picture of the QR code because this is what you're going to use to interact with us and participate in this schedule, this program. And we value your participation with us, with the panelists throughout the day. So access the QR code, prepare your question, and participate. Immediately, we are now going to follow up with our second theme of the day, with ArcelorMittal, innovation strategy with the production of green steel it's a theme that is extremely connected to FIEC Summit 2023. And we have Rinaldo Pedrini, who is an industrial strategy manager for decarbonization and operational excellence. Good morning, everyone. Can you hear me loud and clear? First of all, I'd like to present myself. My name is Rinaldo Pedrini, and I'd like to open a parenthesis and say that I have a twin brother, so if you find him walking around in an airport, an event, or wherever you are, I have a twin brother called Reinaldo Pedrini. I I have a little bit more hair, so if you bump into him, it might be him. So I'm sorry for that. It might be a strange encounter for that reason. First of all, I'd like to thank FIEC for the opportunity. It's an important time to discuss this theme, and green hydrogen is something that has been discussed for years now, but we really need to advance in some aspects in order to apply and scale and make this happen. Today, we have the responsibility of managing industrial strategy for decarbonization. It's something new at Bissing. You can forward the slide, please. Skip this one. Oh, I'm the one that does that. Sorry. Here we are. So we are everywhere around the world, ArcelorMittal, in more than 60 countries. The purpose of ArcelorMittal is smart steel for people around the world. And what does that mean? What do you mean by that? The values of ArcelorMittal have four pillars. Leadership, where we are focused 100% on taking care of people and respecting people, security, quality of our products and processes, and sustainability and environment. So in our next uh, panel, we're going to talk a little bit more about environmental aspects. I might be giving a spoiler, but we're going to focus specifically on renewable energies and sustainability. So talking about ArcelorMittal, we're in more than 60 countries. We're over 159,000 employees. And we have clients in 155 countries. We have several distribution points in these countries. We are PMD leaders. We have 11 research centers. In Brazil, we have one unit. In Espírito Santo, the Tubarão unit, and we're also bringing that here to improve our processes. We are 1,300 researchers around the world. We lead steel production not only in Latin America but around the world, and we have 30 units in Latin America. In Brazil, we have 16,000 employees, and our production capacity in long and plain steel is about 16 million tons per year. We also have a mining division where our productive capacity is around 7 million tons per year. Remind me if I forget something. So steel, what can we say about that? It's present everywhere, in everything, in all spaces, whether it's automobiles or construction or our electric appliances, energy, the chair that we sit on, naval industry, agriculture. So we understand that steel is important and will remain important for years to come. So we need to make decarbonization happen throughout all of these processes. And we understand that Ceará in the northeastern region is a area that is very favorable for this. And now talking a little bit about our plant here in Ceará. In March of this year, we consolidated the purchase of our plant here. And it is a plant with a productive capacity of 3 million tons per year. Our plant is integrated. It's the first integrated plant in the Northeast. Our entire productive process, everything is integrated. And our products are plates, steel plates. Talking about the numbers of ArcelorMittal in Pesing, we have 98.5% of the water consumed at that plant is reused. 99% of the residue generated and the products that are generated are reused. The 1% that isn't, we are working with the academia, with the industry. We are developing our processes, applying our researchers, and many are focused so that we can reuse the solid waste that isn't yet reused. 45% of the 3 million ton production are high added value steel. And what does that mean? It's steel with high quality, with specific applications. So, for example, for oil and gas applications, automotive applications, specific applications within those segments, naval applications. We also work heavily. Let's go to the next slide. Now, talking about our future, what do we envision for us and for ArcelorMittal in Pesing? It was acquired very strategically. It's present, as I said, in more than 60 countries, and Brazil has a very strategic production. We have two specific plants in terms of planes. We have one in Santa Catarina, and we incremented our production capacity. The group understood that it would be very opportune to have this plant as a group strategy due to the logistics and the renewable energy. And they understood it would be an opportunity to expand this production and its productive capacity involving the strong theme that we have here, which is renewable energy and green hydrogen. And that is seen by the group as an opportunity. So the idea is to strengthen the group in Brazil and the world. And this is seen as an opportunity to provide steel or a finished product to the market. So we are seeking to capture all of these opportunities. One of our strategies for ArcelorMittal Pesing, when we acquired this plant and we consolidated this purchase, we discussed a lot about the strategy surrounding this plant. It's a high technology plant, very specific technology for some kinds of steel with high added value, and to further develop that for the market for Brazil and the world to enhance these products to produce semi-finished products, and that is a very strong strategy of the group. It was an ongoing strategy already, and then we saw the opportunity of acquiring this plant here in Pesing. And when we talk about expanding production and how much of this, since the market is very volatile, we are now at a low, but the market is cyclical. Despite that, we understand that with these ups and downs, we still have great opportunities because we have a great position here. We're close to Europe, we're close to the US. We have great logistics for raw materials, which either come from Carajás or from the steel center. So we have a very competitive cost when compared to others. ArcelorMittal's strategy in itself is to have projects connected to raw materials, renewable energy, and bring all of these things into our products. I'm here in front of the screen. Let me get down from the stage so you guys can see better. Our main solutions. What have we been developing in terms of products? We're talking a lot about renewable energy and green hydrogen, high added value steel, expansion, production, but translating that into products, what do I mean? I'm going to exemplify with three products. Magnesium, manganese. It's a product developed by our research center, and it has a alloy cover with high resistance to corrosion. So there's a lot of opportunity to apply this in our region, both in solar and others, to support solar panels and wind turbines. So it's a very noble product. Uzibo is a product applied especially to automobile industry because they are high resistance steels. They are protections for sidebars and others. So it has a very high resistance. Steligence is a high resistance, low weight product for construction. And these three products permeate several segments, and all three of them were developed by ArcelorMittal. And Pecém will now produce very high added value products such as these three. So it's important for us to know that this plant is extremely strategic to the group. And then let's talk about the responsible steel. We have two plants, Tubarão and Vega. They are two plants that are already responsible. They already produce responsible steel. And in terms of social responsibility, sustainability, ArcelorMittal Pecém, as we will talk about further on, they are about to be. Our intention is to certify it as well. So our theme of decarbonization for the group, and now I'm talking about 5% of the plants. Our commitment is net zero until 2050. That's our commitment as a group. I don't know if you saw Eric's panel yesterday, but that is our commitment until 2050. So what to do, how to do it, what's the strategy? That's what we need to know. And now we're going on to our main theme. So the strategy for decarbonization of ArcelorMittal, especially in Pecém, which is very aligned to the group, we have 5 main levers. 5 that focus on the group's strategy. Green hydrogen is one of them. But I would like to emphasize the efficiency of processes. It's not a lever per se. I will talk about those levers further on, but we are already performing this year in the last few months at a rhythm of 10% lower than the entire prior year. So that means that in the last months we have strongly been developing efficiency in our processes, especially the reduction process. One theme that we've been discussing intensely and working on is that we have a plant in Texas. Let me get back up on the stage. A theme that we've been discussing intensely is the use of HBI. We have a plant in Texas. And in terms of logistics and strategy, it's very interesting because we have this Texas plant and we have the possibility of bringing this product. And I'm going to explain what it is. And now we're going to talk about the levers themselves. Until 2030, we have the commitment of reducing 25% of our emissions, and until 2050, net zero. So the first lever to reach 2030 at 25% reduction is scrap. We are going to implement a directive scrap plan. And what does that mean? incrementing our processes to decrease carbon emission, because when you use scrap and you decrease the scrap in the oven, you can stabilize the process. And another important point that we've been focusing on is energetic transformation. And that means stopping our consumption totally or in part of solid fuels in our ovens especially, and using other raw materials with low carbon prints like natural gas, biogas, and even green hydrogen. And then the third lever, transformation of steel production, means transforming in full. A lot of technologies have been discussed and worked on. Our researchers are intensely working on this, especially to assess the advancement of technology or new technology in this sense. And we have a schematic diagram here. So we have coal as a source of carbon. This coal is transformed into. So we have the steel ore, and then we use
I'm gonna try to explain. How is the ore added on the upper side? This is symbolized by several layers. The dark side and the orange side, these are metallic load layers, and this material goes down. You have a blowing fluid vents, and you have darts that will be percolating through the metallic charge as well as the fuel. This will reduce the metallic load, which basically is FO2O3 metallic ore. So, and this comes out it comes out in a liquid state. Iron is in a liquid state with a carbon percentage of 4% and so forth. And then it goes to this side, goes to this processing side where you produce these steels, the different sorts of steels for different applications. And this is the integrated steel mill, conventional steel mill process. What I wanted to point out in this slide here is that 70% of emissions, they come from the top chimneys, so the ovens. So this is where we need to strike at decarbonization very strongly, in a very strong manner, especially on the upper ovens. So that's what we've been discussing. What do we do on the upper ovens so that we can reduce the solid fuel? We're discussing natural gas and biogas, biomass, and green hydrogen. So green hydrogen is a big opportunity. We're plugging the consumption of the upper ovens, so that's a challenge. You have a very focused team. Our researchers are specialists for decarbonization. We have a group in Europe, the group that has been discussing a lot how to inject hydrogen in the upper ovens. So that's a strategy. We don't know when, but we want to reach till 2030, 25%. That's our commitment. Another strategy we discussed quite a bit in the group. We're already planning to apply in 2025 in Europe. Direct reduction. Direct reduction that does not use solid fuel during the process. We only input the metallic load on top, and we have the gas dust reduction. Usually, you will use natural gas for this process, but here we're assessing plants. Already saying we're already working on the process of the blowing process with hydrogen. So it's a good strategy. It's an opportunity for us to connect. Speaking of what we spoke about regarding growth, the production of green steel, to use a direct hydrogen reduction plant. That's the group's strategy. It's a strategy that we are assessing, including as a future opportunity for our plant. And so, the fourth and second last push forward is clean energy. This is really related to what I'm talking about. Hydrogen needs to come from clean, renewable energy. That's the group's strategy. The group, it really focuses strongly on Ceará, our Bacen plant with mill as an opportunity to create this green steel, which we desire so much. We're connecting with our roadmap this renewable energy. And the last one is that we understand, even with all these actions, even with all the projects that we are developing, we will have residual emissions. That's a fact. If you're saying we're going to have zero emissions, that is not true. This will not happen. So we're working very strongly. Our compensation, we're discussing the subject of, we were talking about that in Espírito Santo and the Tubarão plant. We've started these discussions for our plant in Peseng as well. For this, we are doing a lot of studies with all the players in the region of Peseng that are involved around our plant, set out the Northeast.
We've been discussing a lot about this theme and seeking to advance and involve because our commitment for 2030 is to reach 25% and 2050 complete neutrality. So our group is completely focused in decarbonization. There are several challenges, we know that. We know the challenge of feasibility of natural gas, the economic feasibility, the technical feasibility of hydrogen. We know the challenge. It's a very sensitive theme, which is the incentive policy around all of this, to enable it. We know we've advanced a lot in some things. We're not just waiting for it to happen. You can't just sit back and watch. You have to go and make it happen. Advance, take on risks, and we really need to advance in that. It's a huge challenge, but we believe in it, in this. We've already reached 10%, and we need to reach another 15 or 20 for our goal of 2030. We understand that these first 8 months of operations that we will be completing now on the 9th, we understand that this is an important path and a very dynamic one at that. There are several scenarios. This is one of them, a macro scenario. We have several. The scenario of hydrogen coming towards us or leaving, the growth of the plants. How are we going to verticalize? So there are several variables. Some depend on us, others don't. What depends on us, we're doing. And I think it's important for everyone to be in the same boat and going towards the same goal. I'd like to thank for this opportunity, and reinforce how we arrived here. We arrived here on March 9th. Actually, I arrived a little bit before that. And what we say is that we arrived at Bissing to care and to grow. And that is our idea. Smart steel for everyone. A round of applause for Rinaldo Pedrini. Let's go up to the stage, Rinaldo. I was almost falling off over there. Once more, thank you so much for your presentation. And I'd like to welcome you once more. I saw this transformation since the time it was SSP until you arrived as ArcelorMittal, so welcome. In your opinion, is it challenging to launch decarbonization initiatives? What would the first step be for companies? We have several representatives. Isn't it great to see a full auditorium? What would the first step be for companies that want to decarbonize their processes? It's very challenging, and it really is. Innovating is challenging yourself. We challenge ourselves by leaving fuel fossils and moving on to renewable and clean energy. That's a challenge. When we talk about Aerogenerators, we talked about that years ago, as a paradigm. It was a dream. It was unfeasible. And today it's reality. So we believe that to consolidate this strategy or any other, the consolidation of strategy, we need to make this feasible. And for that, we need to establish partnerships, interact, build projects, roadmaps jointly with the same objective. And we've been doing that. Yesterday, if I'm not mistaken, we've had 33 MOUs and other contracts that are signed by the government. We have a few already that are signed, and NDAs focused on this strategy, so we believe we're on the right path. The second and last question: what is your opinion about sequestration of carbon? What are the objectives and the risks associated? I do believe in that. We have been discussing this theme intensely, and we've held at least 2 meetings about this theme per week. Just so you have an idea, here in Brazil, we have 13 specialists focused on decarbonization. We have them here and in Espírito Santo, 13 people across those cities, and that theme is in our agenda. There is a challenge, just like with hydrogen, and like before we talked about direct reduction, and that was something from out of this world, but there is a challenge. There are risks involved. Petrobras is a leader in that segment, and we have been discussing a lot with Petrobras and other companies about this. It's a sensitive theme. I confess I don't have mastery over the subject. We hear a lot about it, but when working with it, we have to understand so we can apply it to our plant. But I believe it's a great opportunity. Ladies and gentlemen, a round of applause for Rinaldo Pedrini, Operational Excellence and Decarbonization Industrial Strategy Manager. I'll let you go back to the audience. And before we call the next panelist, I'm going to remind everyone, especially those arriving right now, for you to use the QR code that is here on our screen. And that way you will be able to participate and interact with us in all panels, in all lectures. That's why this space is called the Technical Auditorium. It has a high degree of discussion with especially chosen themes. And you are honoring us here with your presence at FIEC Summit 2023. And now we're going to have another ArcelorMittal.
Sustainability in ArcelorMittal, a newest unit in Brazil. So that's why I have the pleasure of inviting the environmental manager, Marcelo Baltazar, for ArcelorMittal. Ladies and gentlemen, Marcelo Baltazar. Morning, everybody. You can hear me okay? Yeah? Okay. So, first off, I'd like to thank you. I'd like to thank you for the opportunity. I think that the event that FIEC is hosting very, is very good, as much as that can say, because as ArcelorMittal is saying, employee, I'm here been in this plant since 2008, and being at the House of Industry has always been a very important part to our development as an industry that wants to be part of something. And there's no way for us to be part of something nowadays without having a very focused look towards sustainability. So Pedro made a very complete presentation regarding what ArcelorMittal is. I also have some slides, and I will let you have them soon. trying to add to Pedrinho's presentation itself. So starting with our purpose, which is to have smart steel for people and the planet. That's a simple phrase, but in a recent meeting of our board, I said, well, I can talk about this for a minute and a day. Because having smart steel at the same time as, well, it's easy to understand, it's also an abstract idea. But this abstraction is, when we look at our daily life, it's easy to understand because, okay, take a look at here. I was loving this structure above us. Steel on our head. Why, and how smart it is. And why the sense of adopting every element and physical phenomena that is applicable as a structure, but inside it as well, because as Pedrinho said here, the purpose of today's purpose, I understand it's a big purpose for the ArcelorMittal group to create steel that will be in 2050 or maybe before already decarbonized, working towards carbon neutrality because the company wants to be a leader when it comes to caring for the planet. As it was said, we are leaders on a number of subjects regarding steel production and mining. 159,000 employees, the whole world ever. There's a lot of cities in Brazil. We put together everybody in a single place. We'd have a mid-sized city of our country. In Brazil itself, it's 16,000 employees. The city where my dad lives in the countryside of Minas has 6,000 inhabitants. So it's almost 3 cities where my dad lives, only have employees in Brazil, on top of the indirect jobs that are generated when it comes to steel production. It's not a mature industry yet. It generates from 3 to 5 jobs per internal job, but more mature industries such as Tubarão's plant, they can reach up to 20 indirect jobs. As Pedro showed in his slide, steel, I wanted to have you to look at this in a different manner because on top of it being present in every stage of our life, every element, everything that we do needs steel. Steel is a product that is 100% recyclable. It even is one of the materials produced that has the highest rate of recycling. It only loses to aluminum, but the rate of scrap production the world over is very, very large number. So that's important, especially when we look towards the future when it comes to circular economies. ArcelorMittal, it has a complete portfolio of solutions. Before we entered the group, we produced high quality steel plates, but these plates, they went towards other units to be sold for the production of these materials. And now the group itself, we are part of a group that produces all these products. In Brazil, having an outlook of what ArcelorMittal is in the country, we have two large segments, which is the long and flat segment. And on top of this, the mining, bioforest, information technology, with the ArcelorMittal Sistemas group. It's important to also understand that today in the northeast region, the first integrated plant in north and northeast Brazil is part of the ArcelorMittal group, which is the Beseng mill. Also, we can't not mention our foundation. We have a foundation where more than 47 municipalities have the acting of this ArcelorMittal group, where it programs with communities around that society as a whole, promoting the integration of the company with society the best way they can. Our values, as Pedro mentioned, safety is something that cannot be discussed. It's number one because life is number one. We have, as we've been recently in a training process during the start of the week regarding leadership, we have tolerance. We tolerate mistakes. We know that mistakes are part of things, but when it comes to safety, we need to have a very low tolerance to errors so that we can guarantee that all of our people can go home at the end of the day to their families safely. Regarding sustainability, beyond today's matters, it's very much related to decarbonization. It's very important to mention that on our day-to-day lives, a company has a very close relation to society, to the community. It's important that a company has an outlook towards its impacts down to the very detailed level. We'll be seeing very superficial manner, so to speak, because we're not here to become environmental engineers. We have the best control available when it comes to steel mills, but I wanted to make clear that performance isn't just because of equipment. Equipment must be maintained and needs to have people that are trained, that are qualified to guarantee good operation. Quality, well, we can't sell and become great, become big if there's no quality materials. Become services. The steel product is no different, so we need to have quality when it comes to providing it and the role of leadership, as I said. A company is not made up of equipment and facilities, it's made up by people. If you get rid of all the people, then you don't have a company. It doesn't work. So it's important to be very careful, and leaders are the people that, by their example, their experience, they manage to transfer to the company their model of behavior. So, how are things in Pasing? What is our environmental sustainability like? Like, as I said, I'm here. I've been in this land since 2008. In the case of Ricardo Parente, Miguel Vendes, as well, Cirelio's there. They're a team that's been here from the start. They started with the project when it comes to conceiving the project. So, this project, this company was, imagine the one word, the blueprint with great care. So we tried to bring here what we had best in terms of quality. This slide that Pedro presented, this number that he presented regarding 99% waste, is in fact is a search for zero waste, and it can be done. Today we have only two materials that are placed in the landfills. Among 50 materials, we only have, we'll see at the end the number of actions when it comes to looking for solutions that add value to the materials that we do not call these waste anymore. We call it repo products. We have co-products because good part of the materials that we generate, they actually have value, added value, and they are sold in the market. So for instance, we only have two materials, which are two types of mud. That is basically clay, a sort of clay. We're looking towards a solution for this. And one is mud for more biological treatment. Everything else, it's reused. It's better than cattle. So, as I said, I'm bringing in my structure. I work with these folks, I'm the environmental manager. I have two specialists. They support me, two macro processes, one process management and licensing, and another one of support for the operational process with control and monitoring. Why do I bring this here? Because I would not be able to be your representative of the environmental side without these folks. So our team has experts in each of the larger environmental management areas. I have Ramiro here as a specialist analyst or water and biodiversity. We have a specialized analyst in co-products, another specialist when it comes to atmospheric emissions, so greenhouse gases and air quality. Ronaldo, he takes care of transportation, of supply chains, transporting between the port and our factory. Also emergency support, and on their side, Raquel, Juliana, and Tiago, they deal with environmental management system. Why environmental management system? Well, we are certified in ISO 14001. We received yesterday our certification from, we re-emitted the certification. We had, if I'm not mistaken, September, we had the external audit. We passed that audit with no problem, no nonconformities, actually indicated as a company that was a model company. The ArcelorMittal Group today has a environmental policy where they make clear every single role that must be done by every leader, every employee, when it comes to meeting the requirements demanded by environmental management system. Especially today, we have in our environmental policy, what is the company's message? How will they behave? How do they want the employee to behave? And we have a number of guidelines called the golden rules. I'm not going to tell you all of them, but I wanted to point out that these golden rules, what are they? Well, they are elements under which we cannot err. We cannot make mistakes here. We cannot fail. What is the expected behavior? These are rules that start in the first person. I know, I do this. I have the controls, the environmental controls of my activity. When I go into a company like ArcelorMittal, I will perform my activity. I must know my activities, so I cannot perform any activity without being correctly trained. I use water rationally. I do not waste. I do not have leaks. So there is a process where people are informed. There is need to have awareness regarding use of resources, and that's why we have these golden rules. Regarding environmental controls, has anybody gone to a ArcelorMittal thing? Has anybody been in a steel mill before? There's some folks here. Very cool. Well, I'm bringing this. As I always speak with the team, for those that are in the environmental sector, steel mills is Disneyland for environmental controls. We have fun. Not in the sense of, well, having fun, but in the sense that everything you see in college, usually when you go to a small size company, consultants agency, you don't see it. Over there, you see everything. Why? Because the company, they don't just invest, but they need these controls. These are essential for good environmental management. So when we set up a project, we brought in a few innovations. For instance, the gas treatment in other steel mills, the gas unit, in one of our units, it produces a gas and it comes in through a liquid method. Now we have a dry cleaning process. This makes us not waste water in the process, one less process where there's water involved and it can use dry. So not every steel mill in the country today has 100% of its gas being desulfured. We already appeared. We were 100% sulfur free. So what does it mean? The low sulfur concentration in gas, for example, when I'm gonna generate energy for burning, it has a low concentration of sulfuric gases. These do not generate acid rain. We also have a system for better usage of mixing plant, which is a mixing plant, which is a plant where we send our, our dust and on our mud to our analysis for its material so it can go back in the best way to the process. So this increases our rate of recycling by quite a bit. I'm not going to go into further detail here. This is just sort of an overview of our unit so you have an idea of what it's like. The first time I went into a steel mill, worked for the first time in Volta Redonda, an international steel mill company. I was actually, my jaw dropped because of how huge the place is. But for instance, today we have patios where, well, this patio is 800 meters of length. Everyone is does more than 800 meters of length patio. When we get the plant from one end to the other, from the patio to our and after plate production, it's almost 5 kilometers of distance. So from where I live in Papicu. I go from Aldeota, I almost get downtown, and if I was not walk through the steel mill, I wouldn't have left my home neighborhood. But we're very careful with our units, our patios, for instance. All of them have water sprinkler systems, and on top of the sprinkler system, we apply polymers to improve the aggregation of the raw materials and to stop the wind from being pushed, the particles, stop the particles from being pushed from the wind outside. So the entire soil is made impermeable. They have a drainage system. Why? Because despite having the material that is not dangerous, it's not toxic, it's a natural material. It is part of the soil and water composition of the country, but it is essential that we have some sort of protection to avoid contact of the processed water with groundwater, so every single patio is not permeable. So once to the coke production, I'm not going to go into the process here for the half hour and a half, but right next to this we have the desulfuration plant right here, the gas cleaning plant. So all of our gases are clean, and this helps a lot in our environmental performance. The coke processing plant, this is a unit which generates effluents. It's an effluent that generally has a very high organic load. This actually happened in the past in other steel mills. At the point that we did not have a control standards that we have here in the country right now, this biological treatment is one of the most modern we have in the world. We actually managed to bring in something called a bioship. We can reduce the size of the plant, increase its efficiency through a German technology. So sleeve filters and other systems are essential when it comes to producing steel. We cannot maintain a region with the same air quality level without very robust equipment. For instance, in our group, we have two setups. We have two setups when we have only one, and here we have an element which is the top recuperation turbine. This generates electrical energy only with the gas pressure from the ovens going through the piping system. So as I said here, we have our gas cooling system. It's dry, and our plant already has a capture system at the top of the processing plant. Is all the processing plants already has did not have this from the start. This one already had it from the start during the steel production process. And it's important to mention that an integrated plant, well, I'll tell you that you should go over there and see for yourself. We'll talk more there. It basically generates three types of gas. There's oven gas, there's processing gas, and the coke gas. These gases have a high energy potential. And for this, we implemented a thermal electric plant. It uses gas from the process. We can generate the energy from this gas. The energy is useful for our operation, and we actually export a bit of our energy to the interconnected national system, not depending from external energy for operations. We are interconnected because sometimes the mill needs to stop for maintenance, but it's just a sort of support measure. So, as I said, the company has its guidelines, it has its vision. For this, we have people to be able to implement this the right way. We have control systems that are the most modern and the best in the country, some of the best in the world, actually, I can say. And for this, I need to say that our performance is adequate. So we have a monitoring program. The monitoring process is one that starts from the licensing process. It starts what talks with the environmental body. So it's set up according to these characteristics. That's what we did. We sat down with Samasi. We discussed with Samasi what is the equipment that we have, what are characteristics, what it came to control, as well as pollution, and we went to present to them our monitoring model, where we have as a base, first off, traceability. This information must be available and must be useful to the entities and society. It must be transparent, that we have trustworthiness in the equipment being monitored as well as the monitoring itself, that is representative and accurate. For this, we, well, so you have an idea, all these points here, with a little blue dot, it's water, the yellow ones are monitoring posts, yellow one here, these are air quality monitoring stations, and just internally we have more than 50 internal monitoring points only for chimneys. 28 groundwater monitoring points. You have 6 monitoring points for the stations on top of the point where we are effluents, where they go to the sea. And today, 2023, we just passed 3 years of monitoring. We went to operation 2016 and we started to monitor our unit in 2013. 3 years before. So we could assess what the quality of the environment was like first in the region, and then we'll have a good background, a good database. Following that, we could monitor during operations to see if there's any changes. So here we have the monitoring. There's a collection from the monthly areas, weekly areas, every 15 days, monthly. Depending on the parameters and the type of element we want to control, we have a team that is extensively dedicated to our activities. You monitor air, atmospheric emissions, surface water, all environmental compartments are being monitored. It's important to mention, despite it not being demanded by the environmental body of the state, every analysis we do is certified in ISO 1725. It's ISO, which guarantees that we have the quality and traceability regarding environmental monitoring. Okay. As I said, 11 environmental matrices. We generate more than 40,000 in data per year out of 158 different points of collection between air, water, effluents, and currently it's 3.5 million in investments, but next year we're going to increase even further. And when it comes to our monitoring, it's important for us to understand that there is monitoring that's just internal, and there's external, which we have all of our chimneys we emit per year 100% within legal parameters the whole year over. Same thing goes for effluents and residues as well. All of our waste is assessed according to NBR 2000, 10,004 cataloged, and the air quality, soil and sediments is also 100%, and surface water and groundwater 90%. It's because water, groundwater, surface water has its own natural characteristics. So, in its presence, it has iron, manganese, aluminum. It's already naturally above legal standards, and according to the usage, we have a treatment for the right application. Finally, I have a outside vision look towards what we're living through as a company within the ArcelorMittal group, because today we have the possibility to converse and interact with mills the whole world over, but especially in Brazil to be able to exchange info. We already had that because we were inside the Aço Brasil Institute, but today you have a plant where you can mirror yourself, or actually with more experience than ours, we're able to exchange information. It's very important. But also a lot of practices that we execute today, they are being discussed to be implemented in Tubarão, and today Tubarão is providing for us a lot of support to be able to make improvements in Pecém. For instance, implementing the clean clean trails system. We establish here for each operational area a management of exclusive management for environmental controls. Before, environmental controls were managed within general maintenance, the right attention. But today there is a area manager. They only deal with environmental controls for the operational unit. We got back guardrails. We implemented technical committees and synergy. When it comes to solutions, we've implemented the electronic monitoring system, going from a system that we had for a more modern one, integration between teams. As I said, for Brazil and the world, and access to the research center. As Pedro said, more than 1,000 researchers the whole world over. And here in Pecém today, we have a few actions we implemented. For instance, assessment of our aggregates tool for the agricultural aggregates. So we're having this assessment to be able to make a correction as well as a provider of micronutrients and new aggregate solutions for producing blocks and artifacts. This is quite advanced now. Already looking for partners for production of material that today is being applied for an even more added value and reaching new markets and new applications for dust and mud, so that we can not just have an application to market, but others that add value to the products. So I bring this message to you at the end. With ArcelorMittal, we build more than bridges, cars, and cities. We build opportunities and careers for the next generation. Round of applause, please. Very good. So now for the questions that we got. I can use the There's a bit more. Here it is, the stage a little bit more. Marcelo, ArcelorMittal, is it using any tools that is specific for the calculation of equivalent CO2 emissions? Today, we have a calculation according to the method of the WRC WSA Association. So we are calculating for the balance of CO2. You don't have any way to measure. There is no measurement for the particular materials. Measurement is balanced, so they work with the WRC Association. But we are assessing to calculate as well for GHG protocol. So maybe you could speak a bit more about the technology, the desulfurization, dry desulfurization. That's a question. Well, it's not a desulfurization, dry desulfurization. It's process. It's a desulfurization process. There's the dry glass cleaning. That's for particular materials. We have an electrostatic precipitator, which is a piece of equipment that performs the capture of the particles together with an electrical field, which is already established. So when a particle goes through this electrical field, it is attracted to one of the poles and the gas passes through clean. So the system retains the particles and the gas goes through clean. The sulfuring process, we have a system that through physical and chemical mediums, the in a very simple manner, the sulfur that is within the raw coke gas, this system is applied to the coke gas, which is one of the gases that is produced, and this gas comes from carbon, from coal, from the coal. So when this gas goes through the process where the coal stops being coked, it produces a gas, and you create a system which removes the sulfur, so it's reduced up to almost 98%, 99%. And its concentration, which it has the entry gas, which is least equivalent. So now for your third and last question, Marcelo, in these 15 years, ArcelorMittal has shown itself very positively when it comes to environmental sustainability due to the lack of tax. There's the behavioral adjustments. Everybody's heard about this tax term. So the one that asks questions, they say that maybe this will be the best result in Brazil, or maybe the whole in the world, this lack of tax. On the golden rules that you present to watch, which are the points of this project to propagate such results, such impressive results in this transition of the fossil energy fuels towards renewable energy? I don't have this information because, as we said, 15 years of history. But it's important to mention that our unit did not receive any fines. From the construction phase, we went through all the construction. There was no fines. We never stopped working. We didn't have to sign any sort of adjustment terms, any sort of behavioral adjustment term as well as during the operational phase. We didn't do that. A very important idea that I think is a key element is that there is no document that would give a social license to a company. A social license is something that is for the relation of a company with a society around it. So one of the elements that help us a lot to have this social license is our communication program with the community. We have a relations sector with the community. I believe it's 6 or 7 employees. They work every day relating to people. We don't have a phone number, just a phone number. We sure have a phone number where people can call and complain to us, but we believe first off in relations with people. So today, for instance, any deviation, anything that the community understands that happens, they have a human channel, direct channel to speak to us, and they'll present, and we will immediately go to our internal site to check out what's going on. So I think that this relation with the community, with society, is key so that we are, well, today we can continue, I hope so, without any fines. That's very cool to see the importance that you give to the community, which is a stakeholder that is very, very important, right? Right, guys? So I wanted a round of applause for Marcelo Baltasar, environmental manager for ArcelorMittal. Thank you so much for having here, Marcelo. I'd like to ask you to return to the audience so we can continue this wealth of knowledge of the second day of FIEC Summit 2023. So, folks, here's our QR code. For those of you that are here a few minutes, so you can connect to your cell phone so you can interact. So now we will continue. We have the honor of having a professor in the scenario. It's great to have professors around who have safety applied to storage and distribution of green hydrogen. I'll ask a professor in green hydrogen courses with GIZ with the H2 Brazil project, and also founder and director of H2 and technical analysis. I'd like to ask Nilton Menta, professor, welcome. Round of applause. Go ahead. Yep, it's
I developed my professional life as a Unicamp researcher, and it was a very fruitful time. It's my pleasure to be a consultant for GIZ for the green hydrogen courses and technologies. I would like to divide my presentation into three main topics. We're going to talk a little bit about the H2 Brazil, a little bit about the safety course that was established to develop human resources in green hydrogen, and a little bit about the legislation and norms applied to green hydrogen. The H2 Brazil project is an international cooperation between Brazil and Germany for renewable sustainable development. It was developed by the German International Cooperation Agency, the Ministry of Mining and Energy. As we know, green hydrogen is broadly discussed. It's one of the main resources for us to be able to decarbonize or defossilize the economy. I prefer to use the second word, and therefore reducing the CO2 gas. And this project was a great opportunity for Brazil to train people in a department in which we have a great need for professionals. And I'm sure that this will deeply contribute to green hydrogen in the country. The project, just so you have an idea, we have 1,170 people that were trained, 210 teachers at Sinai, 160 at federal institutions, and 80 university professors, 1,320 a workload of 1,320 hours in class. We've also had 8 master classes with 180 hours of classes, 20 specialized teachers, professors in Brazil, and 11 internationally. And in this item of cooperation, we have employed 2 million euros. And we hope that this will provide a ongoing training, and we expect to have new green hydrogen courses within this cooperation between Brazil and Germany. The course modules, I'll go through this quickly: energy transition, hydrogen production and routes, integration of green hydrogen, aspects on storage and transport that we're going to address today, basic principles of hydrogen safety. Sorry, that's the one that we're going to talk about. And module 6 talks about economy of green hydrogen and hydrogen PTX. Here I talk a little bit about the syllabus. It's basically, we're going to talk about the introduction, which is related to a safety course that we developed in the University of Campinas in the hydrogen lab to train our people. We had plenty of projects at a certain time, and these projects were going from a bench size to prototypes and larger scales, pilots even. So we had a concern. We had electrolyzers producing hydrogen with energy from the grid. We had a reform process of natural gas. We had gas purification. We had applications of fuel cells. vehicular applications. So we had lots of processes, lots of students in and out. So these are the concepts that we're going to present here, and they're all related to the safety of these people at the time. When we talk about accidents, we had to show everyone that they needed to have a safety culture, and that's not very common within the university. But we needed security and safety for our processes. In this pyramid of accidents, we have first the incidents at the base, then slight accidents, then average or medium accidents, and then serious accidents. So incidents are unsafe conditions. A plug that isn't duly connected and might short circuit. We have an extension that someone might trip on. We have a larger circulation of people that is wet when people are walking across it. So these are things that we can immediately act upon to decrease the chances of an accident. Light accidents are accidents without victims and not really many losses. Medium accidents are accidents without victims and a significant loss. And serious accidents are those with fatal victims and great loss. You may have the best way for us to prevent these accidents is to act on the nonconformities, non-compliances. Another more modern way of looking at this is the risk matrix based on IEC 61508, functional safety. On the left, we have frequencies or probabilities of failure or error. So a dangerous event, a frequent serious event, when it takes place, if you have it happening once, you have 1 in 1,000 chances, for example. So that is very frequent. And of course, it's undesirable. When we move to the right, we have the seriousness of the consequences. So we've seen that if we have a frequent accident and we have a light injury, it will be deemed undesirable, and we have to act to end the occurrence. If we have an occasional accident, we're talking about one accident within 10,000 or 100,000 actions, and that is tolerable with mild repercussions. But if you have the loss of a life, it's undesirable. So the general idea here is to always work within the desirable regime. But if you have a process that requires very serious safety requirements, you have to revisit your processes in order to decrease the risk. With gases, it's no different. There are some rules that can make the process, the work with gas, a lot more safe. Reminding everyone that some gases are asphyxiating. Below 10% of air, you already have most probably a fatality. When you have concentrations of oxygen concentrations below 10%, below 7%, you begin feeling symptoms like headaches and drowsiness. Some gases have no smell, no color, and that is the case of nitrogen in the air, hydrogen. So the presence of those gases is not perceived, and when you feel the symptoms, that can be too late. It's very important for people to notice that people have different tolerances for different gases. I might be feeling a symptom, and my colleagues may not. And what are the consequences of a possible leakage? If we have a non-inflammable and non-toxic gas, we have drowsiness, loss of senses, and if the person is not removed from the environment, there will be a death through asphyxia. For toxic gases, we have intoxication, and concentrations in this case are a lot lower for you to be intoxicated. Then you may have consequences that are temporary or permanent. And last, you will have death through poisoning. If you remember the Kiss nightclub, people were intoxicated and died days later because they breathed in toxic vapors. So these are the consequences of intoxication, and they're very serious. Finally, flammable gases. You might form explosive mixes that may detonate. You may be burnt. You may become deaf. You might die by shock. So depending on the type of gas, we can have fatal consequences if we are exposed to the gas. So preventive measures against asphyxia and the formation of explosive atmosphere. Sometimes it's not possible. You have to have that gas in the room to analyze or to perform a procedure. So in those cases, you must ventilate the environment appropriately. Any gas that is discarded should be done out to the outside of the room. Never work alone. Maybe those of you that are close to my age will remember Claudio Coutinho, who was a diver, and he went to dive alone, and he died. Why? Because he stayed too long in apnea, and if he were in a pair, he would not have died. So in the case of gas, whenever possible, don't work alone. You should work in pairs. Another good rule is open cylinder in use. Oh, but I'm using this gas to pressurize a pipeline. So this gas is being used, and the cylinder should remain open. If not, keep it closed. That is a great way of preventing leakage. Periodical leakage checks that should be performed, because usually the tubes are subject to differences in temperature and pressure, and that provokes movement, and you may have leakages arising from that movement. Use monitoring and gas alarm systems, gas warning systems. And here we're going to distinguish large industries, as we saw in Marcelo's panel. They are very careful about safety and security. And usually in universities, it's easier for you to buy devices that you need than maintain them. There's seldomly a budget for maintenance. So in industries, you will see that everything is calibrated, because it's no use if you have a sensor on the wall if it's not working, if it's not maintained appropriately, it will not protect you. It'll give you a false sensation of security. And a fundamental principle, if you have ventilation in the location, it can be natural or forced through exhaustion. If you don't have ventilation, no operation. I'm going to talk a little bit about the normative structure. We have here at the top of the pyramid, we have the laws that are mandatory. Then we have construction codes for construction and safety codes, and some agencies that have jurisdiction over those are firemen, for example. This book was edited. Chapter 6 talks about the regulatory structure and social security structures, social safety and structures, and the social acceptance of hydrogen technologies. It was launched in 2018, one of the largest conferences in hydrogen. And at this conference, in this book, I was able to take part in the preparation together with Sérgio Pinheiro from Imetro and AV Chovali. There are many considerations about hydrogen security or safety, and I built a diagram that is similar to that of the United States but applied to Brazil. In the larger ring, you have federal jurisdictions that issues the mandatory regulations for security and safety. We have Inmetro, who also produces ordinances that are also mandatory, and we have the Technical Norm Agency of Brazil and others. And in this ring, we have the Special Study Commission for Hydrogen Technologies, which is a mirror. I would like to invite you guys to these courses. We have plenty of students that have been taking part in this commission, and I would like to invite you if you're interested to see. We have the opportunity to translate these rules and norms and to improve them. One rule that we insisted upon is NR 33. We insisted on this in the course, and it deals with confined spaces, which are usually galleries, tanks, silos, tubes, places that were not projected for the continuous presence of people. We may have to go in there and do some maintenance, but we always have to have a gas monitor to see the oxygen concentration, see if there's toxic gases, and you have to promote the ventilation of that space. It's a regulating norm established by the Ministry of Work and Labor. It's mandatory, and it's very important to think about that subject of confined spaces because we have, especially in universities and even in companies, you have some rooms with very little ventilation, and sometimes you have furniture that is preventing circulation. And if you have a gas leakage, that space, which is not considered a confined space, may have the same characteristics of those that are considered confined. Another important rule is NR 13, which is about boilers for storage. And we can see here that the hydrogen is right here between flammable fluids, class 1. And here regarding the risk categories, we have electrolyzers today that work at about 40 bars of pressure, which mean megapascal. So for megapascal, if I have a reservoir of 1 cubic meter, I will be here in this category. And this category is, let's say we're here at class 2. In class 2, there is the need to have a training course, a practical and in-person course, and a supervised practice of 300 hours for those that operate the production unit. So we have some rules that are applicable today to green hydrogen and are used in the industry. That's very clear. Regarding licensing of developments from the point of view of safety, we have the firemen, and they have an environmental agency. In the case of São Paulo, it's CETESB. So here we have the firefighters. They have a state jurisdiction, and the main focus is to prevent fires within the walls of that edification. And at the São Paulo Firefighter Department, we have IT 28/2011 that deals with handling GLP, natural gas, and they have regulations surrounding hydrogen storage. In the case of CETESB, it also has state jurisdiction, and there is a risk manual, quantitative assessment of risk for toxic and inflammable materials. And what they worry about is the population surrounding that development. So it deals especially with social risk. And it also developed in 2011. It devised the technical rule P4261 of 2011, which includes a reference for distance, tables for toxic and inflammable substances, including hydrogen. We have projects involving buses that are run by cell fuels that run on hydrogen. Luckily, these buses that were deactivated will be activated once again, but that's another subject. So we also have, with the case of hydrogen mass of 10 kilos, we have a ray of 18 meters of distance between the hydrogen and any other construction. In a case of a hydrogen supply post, we would need a 65-meter radius surrounding it to ensure safety. I had the opportunity of collaborating on the hydrogen risk assessment in São Paulo State, Brazil, with the people from CETESB. I would like to talk about this rule right here that deals with explosive atmospheres. Over there on the bottom, you'll see a suggestion for a website, and I found that they summarized this very interestingly. There's also a reference over there from Bugarelli, who is an engineer. He's a national reference in terms of explosive atmospheres. And this rule is gigantic, but I wanted to mention mainly the part 10-1, which talks about area classification, explosive gas atmospheres. And here we have some references about diminishing these atmospheres through natural ventilation, and also the method for calculating the radius that you need between where you have these gases and the surrounding buildings. So another rule that is very important and is international. It's from the National Fire Protection Agency. It deals with hydrogen and nitrogen and others. It refers to many other norms and rules. So it's very complex and it's very complete. There are many attachments to it, and it should be studied. For those who want to devise smaller installations, we have this norm right here, issued by Canada. It's recent, from last year, and was updated last year. And it talks about several subjects that are very interesting. Responsibility of the installers, of the suppliers, training sessions. So it's an interesting norm. It's a little bit shorter. It's 108 pages. It's faster to be read and analyzed. And this norm right here, we have the set of technical committees from ISO and ISE. There are several subjects here that are addressed by these committees. And here in the work of, they synthesize this very well. They talk about electric grids and explosive atmospheres in vehicles, combustion engines. So we have several rules here that these technical committees, both from ICE and from ISO, they both have rules for all of these subjects. So now I'm going to make a few comments and recommendations. When we talk about safety, we should always be informed about the legislation, and we should do that constantly because updates on the themes are frequent. So there are a lot of norms and regulations, And we've seen that a lot of them have been updated just recently in the last year. So you have to be up to date. Safety and applications of hydrogen and gases present some aspects that go beyond intuition. So, in confined spaces, for example, it's not intuitive. You may have an environment. In some environments, you won't be able to see the dangers within those rooms or spaces. So, some aspects, security aspects, are not intuitive. Qualified suppliers are a good source of information. So when you have qualified suppliers, there are a series of rules that they have already complied with to be able to provide those services. So ask them, they're usually updated regarding the rules and norms. Licensing bodies are complying with their obligations. You have the firemen, CETESB, others, Ministry of Labor. They are all doing what they are supposed to. I've seen plenty of people try to convince the environmental body that this isn't needed, that the fireman doesn't have to place a fire extinguisher or any other item that is requested. What I suggest is a more collaborative posture that may provide better results. Reminding you that, let's remember that hydrogen developments are a little bit new to everyone, so for environmental agencies that applies as well. So let's sit down and talk. You may find that that brings better results than debating. Training should be periodic with the necessary and sufficient items. So in terms of time, in-person trainings, you should have a checklist with the rules, with the themes to be approached and addressed. Is Brazil prepared for green hydrogen in terms of safety and security? Although the optimization of the rules is constant, I believe that we are prepared in terms of regulatory regulations and others. After production, hydrogen in terms of safety, the form that it was produced doesn't really interest us much. So as a chemical raw material, we see hydrogen already in place. We see companies using hydrogen every day. For vehicle applications, for example, we may need some supplementation. I would like to thank the opportunity that was offered here by GIZ in these courses to train human resources around the theme of hydrogen, green hydrogen. I would also like to thank the support received by Klaus Peter, who provided us with the full conditions to develop the best material we could to train these professionals. We have a great experience with human resource training in renewable energy, both solar and wind. And he brought us all of this experience to help us develop our own course. So I would like to thank GIZ, and anyway, I believe I'm representing all the teachers that came together to produce these modules. So thank you so much for your presence. I'd like to thank FIEC as well for the opportunity and invitation to this panel. Round of applause, everyone, for the professor. Let's take the stage. I don't know about you, but I am feeling like I'm in the classroom because the level here is so high. You are honoring us with your presence here. Where can we find free training courses about hydrogen distribution and storage? Yes, the courses offered by GIZ, many of them were free. I believe that there are some other courses being prepared. Actually, I know this. And I believe that we're going to feel the effects of this training for many years to come. I hope that we have a new project like this one, that it is put into place shortly, because the results were fantastic. We can talk about this later on if you're interested. If anyone is interested, we can talk about these a little bit further. Ladies and gentlemen, Newton Pimenta, teacher and consultant in green hydrogen, founder and director of H2 Análises Técnicas. Thank you so much, Professor, for being here. Everyone, we're going to continue with our schedule. Here's our QR code. Thank you so much for following up on the internet through our Virtuali platform, and are following us remotely from anywhere in the world, and also from FIEC's channel on YouTube. We're honored by your presence here at FIEC Summit 2023. Thank you very much. Now we're going to continue. At this panel, we'll have the presence of two professionals, first one, then the other, and together they will complete the presentation that is coming next. The theme is Siemens, Infrastructure Industry 4.0 applied to hydrogen plants.
So I will ask Valderi Versailles, development leader in Siemens, and then we will have Paulo Cesar Silvia, specialist in sales and chemical company OIG, also from Siemens. Round of applause, please, for both of them. Go ahead. Well, good morning, everyone. First off, I'd like to thank the organization of the FIEC Summit. Congratulate you for this event. Truth is, this is a very well-organized event. Well, we all attend. Siemens is very glad to be part of this moment with you. Well, the subject of our presentation is Infrastructure and Industry 4.0 for green hydrogen industry. Up till 2019, the subject matter was to speak about Industry 4.0. You remember Industry 4.0? Does anyone remember that? Because after that, after 2019, going into 2020 pandemic, the whole time, the decarbonization subject, the energy transition, sort of took up everything. And we went on to concern ourselves with problems about decarbonization. We started to concern ourselves with technologies related to energy transition. And we have not spoken about how we can produce hydrogen more efficiently, how we make hydrogen production more transparent, and we have these gains in productivity. I think the slide is not working. Presenting a bit about Siemens. It is a company that was born in 1845, so this year we just turned 176 years old. As a company during this time, we've changed several times. Siemens is a company, a technology company. We always try to update ourselves. We are divided into a large sector for process automation and meeting needs of infrastructure, smart infrastructure, also industrial market, power utilities market, mobility, looking towards the entire infrastructure, railways, and our health arm, which is health, Siemens Health Years, which is health, hospitals, labs. Today, we have 311,000 people, employees, with an income of 72.0 billion euros. That's our position today. And who are we not? In 2020, Siemens had a spin-off for a few business sectors, creating a new company. This is called Siemens Energy. And within Siemens Energy, we have an item in the hydrogen chain, one of the most spoken about, which is the electrolyzer. As a completely independent operation. It was like a new company. It has a different stock, it has a different management. Speaking about the market and trends, what is the global trend today? We're looking at the needs of reduction of emissions. Up till 2030, the world had the commitment of reducing CO2 emissions up to 50%, with the mission of reaching 2050 being net zero. We will have an increase of renewable energy. We're speaking about green hydrogen. The main goal of green hydrogen is to have energy consumption that is renewable. So with that, we have a large increase in the density of solar panels, photovoltaic panels, and air generators as well. The demand for electrical cars, we have a very aggressive growth above 2 digits up till 2030. Technologies to capture CO2, so CO2 will be used a lot to synthesize hydrogen and create new subproducts, and to find alternatives so that we can decarbonize industry as a whole, cement industry, steel mill industry, among others. How is Siemens looking towards the market? Well, Siemens positions itself from the part of generation, looking towards the side of renewable generation, energy management, and energy storage, enacting the entire chain, electrolysis chain. We also act in blue hydrogen within the methane reform chain. On the transportation side of things, looking at conversion for ammonia and the markets we understand that will be the main consumers in the future are chemical industry with the consumption of ammonia for production of fertilizers, steel industry, look at the production of green steel, SAF or synthetic fluids as a whole, charging station for energy, for fuel cells, and re-electrification. So energy ends up being more expensive because of a lot of loss during the process, but this cost tends to reduce itself over time. So what is important for a H2 industry? First off, safety. We're talking about a gas with a high amount of energy. Safety for operators is key. Modularity and scalability. When we look at the larger projects being announced, 1 gig plant, 2 gigs, it's not going to appear as it is. It's going to be smaller with the potential of reaching this power level. So modularity is very important for us to guarantee that the project will be driven in an efficient manner. Digital twins. The plant today can be born with its virtual version. With that, you'll have a very forecastability of its efficiency. Integrated engineering, you look towards all the disciplines: mechanic, civil, electrical. These are important points. Training the operator. Today, Senai itself in Ceará has a challenge of training new courses. Professor Milton Pimenta just presented all the work when it comes to training professionals. So Siemens can and does contribute all its digital platforms where we virtualize a plant, and before it even exists, the operator can already start his training. So remote operations, cloud connection. When we talk about clouds, for us to be able to work with data, we also need to talk about cybersecurity. You can imagine we'll be producing hydrogen, and we have to produce hydrogen here because the world needs it, and these are critical markets that need this product. Which producers will be most seen by hackers and cyber criminals? So cybersecurity is key. It is very intimately connected to all of hydrogen production. Siemens is positioning itself in the entire chain, with the maker of the electrolyzer, the maker of or salt water, wood fabrication of decompressors, CO2 plant, SAF plant, ammonia, methanol. For each one of these boxes, we have a technology provider. We call these package providers. Managed an investor, when they build a hydrogen plant, they'll receive several packages. Within their investment, they're going to purchase several items by several OEMs. And who guarantees the integration of these packages? Who guarantees the communication of the electrolyzer to the saltwater plant or the Desmi plant? Who guarantees the stability of energy to the several packages, the several nuances of consumption? This is Siemens' role with several players that will arrive into the plant. Siemens can act, providing systems and solutions for electrification, automation, and digitalization to guarantee the integration of these packages. Having said that, we also support the entire EPC and EPCM chain, applying our solutions and guaranteeing the reduction of CapEx, and OpEx in the project. The one that wins at the end is the operator, the investor. Siemens can also monitor this moment and the whole cycle of operation of the plant. A large-scale plant basically has this format. The setup. The plant's installed into a high voltage network. Below this network will have the entire distribution and a middle voltage, which is going to be 34 kV, high current levels, high short circuit levels. And following that, we go towards rectification or the electrolyzer. The electrolyzer, it is a system where, what's going to be the main product here? You'll need water and electrical energy. The electrolyzer needs basically those things to work. It needs quality water and it needs quality energy, right? Well, with water in the electrolyzer, it will have two metals. These are noble metal, these are expensive metal, and the rectifier will provide a continuous electrical current for the system. Each metal will have two poles, positive and a negative one. In the positive pole, you'll get hydrogen, and negative, you get oxygen, and that's e-water electrolysis. That's basically the process. You need water and quality energy. Below that, we'll have several subsystems. What are these subsystems? They're subsystems that guarantee the performance of the whole group of electrolysis group. These are the compressors for cooling. This is the storage side, the transportation pipelines. Those are the surroundings, so that's where we'll be acting as well. And it's two automated systems, so we can have transparency and information. These are key. First off, energy automation, because we'll be looking at the connection with the substation as well as the integration of the packages as well as process automation. So you can imagine that we have several pipelines, several OEMs, several packages where we need safety, where we need measurement all the time to guarantee the plant's safety. Here you have a cleaner version that's more easy to see for those of you that aren't engineers or electricians. Those little boxes looking at the extension panel, low tension, transformers, rectifiers. Siemens has the opportunity to provide a modular solution. Put down the entire system of distribution in an electrical center, getting to the plant, a package where we install very quickly with a guarantee and an entirely commissioned system and factory, reducing the setup time on the field by quite a bit. And this package, we ended up providing it for an entire process chain. Another point of acting that we can help with investors and operators of these plants is the rectifier side. Our solution, you can act from a direct connection to the grid, looking at the inverter and solar generation, and also rectification to meet the needs of electrolysis. It's a same solution based on GBT technology where we already have replicated this in the market. When we spoke about optimizing the process, looking towards the EPC chain. A term that we like to use is digital substation. At the end of the day, what is the value of a digital substation for an investor? And this image, we have a conventional substation. A substation, this is the coupling box. It gets all the signals, comes substation, all the tools, the transformers, sensors, everything is here in this box. After this box, we will be taking it to the intelligence side of the substation. All the panels, the reduction panels, is the layout that normally where we work on. What is the Siemens proposal? Using the optimization of capex for the project, the substation remains as it is, but on the coupling, we already have visualization. Why? Because we get analog information and we transform this analog information into a digital piece of information. We do not send information to the systems in an analog way. We convert everything, the number of pipes from fiber optic, taking it to the control room. What is the benefit here? Our control room, which before we had here, had this dimension here, it has now this dimension. So it will be around 50% reduction of civil works, reduction of consumption of wiring of metal, making your project more sustainable and more efficient. And when we speak about consuming less materials, we're talking about emitting less CO2. With a smaller dimension, there are other benefits, which will be cooling. It's based on sector and heat dissipation. So, since we have a smaller physical space with the same equipment, heat dissipation won't change. We managed to bring this optimization of the cooling system and also consume less energy. The project becomes more efficient. Another layout here, which will be applied a lot in these large-scale plants, because a 1 gig plant needs to be connected to a voltage of 300 kV. After distinction, we need to have an internal distribution. This internal distribution will still be in a high voltage. It needs to be 138. 138, and we already have a compact solution for this distribution, internal distribution. It tends to be a GIZ distribution, can be internally or within an energy house. Looking towards the protection of this substation, we also remain with two options. Maybe an analog solution, or it can be a digital solution also, making use of all the gains that I mentioned when it comes to space, as well as making the process more clean and transparent. Another need for multi-source management. Today, when we talk about digital twins, Siemens has two proposals. Digital twin is all connected to process and visualization of information, but also the digital twin is connected to energy. Here we have a scenario where we have renewable energy generation, wind or solar energy, a project also simulating cogeneration, can be through biomass or another sub-product, the connection to the grid, a scenario with a storage. So we have several energy sources that can be utilized. And at the end, we have a process here. That's electrolysis. Which of these sources will I be using to have the electrolysis process? What's going to tell me this information is the budget and quality. And once I define that, well, it's our digital twin. There's an algorithm within this energy management. It'll do the whole management of with several sources, and with that, apply lower cost energy at that point, sort of quality within the electrolysis process. That's the benefit of having transparency and integration between packages. So, when we talk about Industry 4.0, we're always talking about connecting the digital world to the real world. all of that which we've spoken about regarding caring with caring for suppliers and integrating packages, we can bring all these benefits from Industry 4.0, which we stopped talking about in 2019 and 2020, to this point. That's where we'll have the real optimization of the project relating to efficient engineering, virtualization, and training operators in a virtual manner, integration of dynamic projects, taking out an operator that has it takes a certain amount of time to make a decision, and leaving the process more automated. Another important point is digitalization of assets. The more we reduce the interference and the more we increase the transparency of information, the less operational costs you will have. And here we have a tool where we can bring all the transparency of your energy assets to the inside of a control room or your cell phone even. So transparency in your assets, so the location of where your asset is installed or not, health status, you have info the whole time of what's going on. You have a pump stop, it was an alarm if some piece of equipment stopped working, monitoring the energy use. So our digitalization tool can calculate CO2 emission based on models that you insert the quality segment that you can apply to for us to bring this information in real time so that you may analyze how CO2 emissions are like in your plant, utilizing the entire manual information. If a pump stopped working on your library, you go and you'll hunt down that S-bill that was provided. This can all be made digital. Operational transparency, so generating dashboards so you can see all the key performance indicators and your assets. And the service side, with digital services where you can remote access to your plant, guiding the resident technician through their first procedures, and if necessary, we'll go to the field and we'll help you out. That's the goal. And all this technology, this is not restricted to just Siemens equipment. We can do this for any piece of equipment that is inside a plant. Here's the investor's concern then. When we talk about digitalization, digital substation, and transparency, so forth, that's all very nice, very pretty, but it looks kind of expensive, right? Because it's more equipment, more solutions that you're putting in. So how much is that going to cost you? Well, that's the first concern. Inside of a CAPEX scenario for a new investment, between 5 and 10% is related to all the electrical scope and automation. 5 to 10%. We look at all these solutions. We show it here. And it tends to give you a difference of 1% within this 10% of the package. So it's a very small difference. It's a very small difference. To have all these benefits, integrated engineering, virtualization, digitalization within the process, what does this guarantee you? You're starting a project within an integration concept and digital platforms concepts. The moment that you will commission a plant, there is a reduction of up to 30% in the engineering effort. That's a lot of time. That's 1/3 a reduction of time for you to commission a plant. You start your production weeks earlier. So you can imagine an investment. You're spending billions there. You got to produce. You got to send products to the market. And you manage to anticipate this production weeks before. Looking at all these integration of information. Up to 5% in optimization of production. How do we manage to do this? We're trying to say he will present a number of alternatives of solutions. Looking towards processes in the sense of of sensory detection, how you waste less when it comes to production. And for that, you need operational transparency and ROI of 2 months. When you look at the IoT, all that digitalization of the substation bringing info for you has a very quick ROI. It pays itself when you go to the field twice. That's those times that you avoid it because you had the information on hand prior. And at the end, when you look at all the savings that you get when you use these tools, you're going to have the best TCO. Your proprietor's cost tends to be lesser when applying further more technology. Here I'm going to show you a few cases. All of this what we commented on about regarding Industry 4.0. It's not the future stuff. This exists. It's already being applied. It exists. We have functioning plants with this idea in mind. This is our case from Denmark, where every plant came up after assimilation. So electrolyzers, process synthesis, interconnection operations. It already had been modeled priorly. And after all this modeling, it was built. Built using these benefits and reduction of engineering time with the Siemens platforms. Another case of a city of Germany, Rumsiedel, looking at a city that has the goal of having 100% renewable generation of energy. Within this city, they use wind farms, they use solar farms. And there's also now hydrogen working as a backup for several sources. With this project, Siemens acted as a supplier of technology for the number of packages that we showed up on now, but as a co-operator. Within our structure, we have a area connected to financial services, and in this project we also applied financing for the Siemens equipment within the project. So we monitor also the operation and the rentability of this plant. Final case is a global agreement that Siemens celebrated with Shell, looking at hydrogen plants. There is a 100 megawatt plant in the Rotterdam port being built, where Siemens is a provider and is the integrator of several electrical packages. And this MOU, this plant is being set up, as well as the next investments that Shell will have. Guys, that's it regarding the first part, looking at infrastructure 4.0. Now we will switch presenter per se. We'll be talking about automation and all the technology can Siemens contribute to hydrogen plants.
Good morning, everyone. It's a pleasure to be here with you at this presentation. Thank you so much for the organizers for all of their support and the FIEC team. Let's continue here. Our idea was to work jointly and bring this history, this background, Siemens background in 176 years working with innovation. So we wanted to bring a little bit of what we have here to you. Focusing on the hydrogen market, all of the operational efficiency along the value chain. So as Aldair presented, the power grid part and the power grid connection part, and all of this energy that is needed for us to control hydrogen production. In addition to hydrogen conversion, all of the processes that are connected, what to do with that hydrogen. So the conversion, transport and storage, the use at the end clients so that we can bring benefits to the final users, meaning that if you have ammonia or a fertilizer, that in the end will bring food to people's tables. It'll decrease carbon print for steel production, energy generation for glass. So Siemens offers this technology so you can plan, electrify, automate, and optimize plants using structures in a safe way, okay? Well, Siemens, as this technology company, has a view of the world today, of the digital world, but it remains with its feet on the ground. And we need to have field teams and sensors and activators that bring quality and information and intelligence so that this data reaches the cloud and can be used efficiently. To assure this, we have controllers, we have edge computing, we have systems, management systems that will interconnect with production orders. And we also have applications, cloud applications, and collaborative platforms like our Insight Hub, an open platform that for application development. And we also have a tool that generates. So this point of view, this way of seeing integration is fundamental for us to have the brains for working with everything that is being generated throughout the process. Just so you can see how Siemens is a great partner, and we are the #1 in industrial software. We are #2 in process automation and instrumentation, field instrumentation, and #1 provider in chemicals. According to ARC, we have a study in 2021 and 2022 that proves this. So beginning with electrification, all of our solutions, automation, control systems, DCS, SCADA, we have to integrate management and this manufacturing. We have to assure process orders and the entire industrial instrumentation. In addition to the digitization instruments that will allow you to optimize these processes. So we have a global way of seeing. We have a global portfolio that encompasses all of the aspects. Well, beginning with process instrumentation, our portfolio, it allows us to appropriately apply hydrogen applications. So thinking about green hydrogen, blue hydrogen, power to X, thinking about the entire, even mobility, like charging stations, controlling pressure, controlling outflow, reaching out to transportation and storage, energy, and decarbonization industries. These are all measurement technologies that take years. Pressure, temperature, continuous analysis of gases, which is very important in the hydrogen process. And I'd like to highlight two components, main components. For example, our pressure transmitters that are coated in gold. You have the option to coat them in gold in order to protect them and allow measurements because hydrogen is permeable to stainless steel. So you will have a greater resistance, greater precision in your measurements. And in addition to that, it's a critical process in terms of operational security. So we have instruments here with an integration level that's according to 61511 within what Professor Pimenta said. And a final control instrument, which is a smart positioner. And this positioner, this control valve positioner, it has a great efficiency in the reduction of energy use, and it just received the taxonomy criteria in Europe, which means that we are contributing to the carbon print in a highly efficient way. Speaking a little bit more about hydrogen production, we have a process. I brought an example of a process where this equipment is actually applied. So what are the main roles, functionalities? Measurement of leakage, tank levels, temperatures, purifiers, temperature monitoring, which is also very important. And within electrolyzers, you have everything that surrounds the electrolyzers. You saw the presentation. We do not manufacture the electrolyzer, but everything that it needs to assure its efficiency is Siemens products. So maintenance, gas measurement, online gas measurement, all of these come from Siemens. So exemplifying in transportation, the purity requirements of hydrogen in this aspect is fundamental in cell fuel performance. This way, we have outflow measures that meet the needs of several devices, like analytical instrumentation. Moving on to the power to X hydrogen. This part that deals with the concept of hydrogen, we have the concept that ammonia is synthesized through hydrogen and the separation of air. So in the schematics, you can see the entire chain. And we have here a scheme that provides for the separation of ammonia. And what do we have here? The raw impurities. We are able to monitor the quality and the final product. So we have products that analyze all of these gases, our entire instrumentation, pressure, level, temperature. These are all used, and our positioner as well. They are all used in this process with high precision and high performance. In the breakup of ammonia, we have our solutions, our analyzing solutions, and our applied instrumentation, or instrumentation applied to this entire process. And talking a little bit about the industry of decarbonization, we also have an entire portfolio to apply to this. I'm going to focus a little bit on this part that is emphasized right here, which is the direct reduction of iron. We have a great reduction in carbon emissions. And how do we help the steel industry in their decarbonization process? Corrosion, high temperatures, variables that need monitoring and need to be monitored continuously. We have applications for all of that. We have instruments for those processes that contribute efficiently to these processes and to these measurements. Looking at the green hydrogen plant, it's important that we meet all of these requirements, these safety requirements, and these control and measurement requirements based on control systems. So Siemens has a vision about the control of these processes, and we can perform this control in large scale, we can orchestrate these units. And we have in these package units, we have several systems that can and need to be integrated to the control system of these processes. So we have these possibilities. And the control schemes that are needed for us to ensure an efficient operation, we need to have these control schemes that apply to the system, to the electrolyzer. We need to control heat, control supply, and even control inertia. So we need to use libraries that will allow facilities in this control and that will bring transparency and visibility. Over there we have measurements and controls that will allow efficiency, operational efficiency. Another possibility is guaranteeing the start and stop of the plant in a safe way. That way a control system uses, and that's what we're seeing here to the left, it uses transition sequence, and this control of sequence and transition, it provides flexibility in this plant's operation and it also brings security and especially respects the process. Here's an example for an alkaline electrolyzer. So our objective is to bring technology that has purpose. The process requires a control system that is efficient, and we have this efficient control system. Modular plant concept. The idea is to begin small and to grow from there. The package units that were exemplified here, they're within this idea. In demineralization, you may have a provider for this technology. In the energy conversion process, you have another supplier. The electrolyzer itself is another example. And what are the main issues you have? You have several types of automation. So having different systems will demand that you have a system that is hard to be maintained. It will require several replacement parts. It will demand a high curve of learning, a high learning curve. So bringing this uniformity is a concept that today, this has been said within the chemical industry, modulation is key. It allows you to have each one of those systems inside of your providers, but that you can integrate all of these systems and orchestrate all of this entire production based on information that is concise among them. And this will allow remote operation and will bring several benefits such as low learning curve. It will allow you to have the same preview of everything. You can see everything on a main dashboard. You will have concise information with the same characteristics. And especially, you will be able to access remotely because we're talking about plants that are distributed and being operated remotely. They're undergoing maintenance remotely. So it'll allow you this flexibility. And this brings a concept that is imposed nowadays. And this is a concept that we have as IMTP. It is the future of automation. It is already in place. We have very well-defined modules and ways of communication that are already established. You can access and pull all of this data. And within the Namur concept, we have several manufacturers today that work with this concept and allow for this integration. That considered, we're going to move forward with automation and talk about our concepts. And what is our concept? It's that during engineering, when we are designing this plant, we have tools that allow for a digitization. So from the beginning, you can use engineering tools and connect this to the simulation while you're actually building this plant. So we have the simulation of these processes. Uh, you'll be inserted in a VR where you can simulate scenarios of failures and errors, and you will have tests, and the logic that was developed will bring you lessons and will decrease the time for commissioning. And consequently, all of that information that was initially projected, it'll be available to maintenance, for maintenance. So imagine you have a tool where in maintenance you're going to use some VR glasses and you're going to access the database of that component in which you are in front of. So these are all tools that are going to bring the flexibility, operational flexibility. From the start to the end of the chain, we're bringing benefits to our clients. This is an example of how we address this. We have an object, a valve, a motor, an engine, an electrolyzer component or part. It's being documented in a very smart way. All the manuals that are connected to it, all of its functionalities and features, everything is documented in a single database. So you have maintenance throughout its life cycle, optimizations that are performed during operation and can be recorded and saved, which means that you're leaving the concept of as built to as is. So one object, all of the information surrounding it, basic engineering, design information, modernization, everything is within a single platform and integrated, which allows full integration of this information and especially in a bidirectional way. If it's operating and there have been changes, all of this information is updated. So the knowledge is there for you to access. So this is a little bit of what we have in terms of simulation. The simulation platform integrated to these design, engineering, and project execution devices, this is going to bring benefits to virtual commissioning and even the possibility of you during the life cycle of the plant. The operator can leave the control room and undergo recycling in a VR room. And they will come back even more trained. They're not going to commit any mistakes in an actual plant. They're going to do this in a simulated environment. Here we have a little bit more about our simulation. So this simulation tool, it has libraries and allows us to simulate the electrolyzer's behavior. And thinking about high fidelity or loyalty, the tool that brings the mathematical functions, it also holds the understanding of having the prospects of our hydrogen processes. Here we have some libraries. And I'd also like to talk to you about our monitoring systems. We connect to the cloud directly to ensure quality and efficiency of this equipment. we're almost finishing. I'm going to give an example here of remote operations. So we can have control rooms, fully remote control rooms that allow the operation of these plants throughout the country, for example. We're reaching the cases so that we can have some questions at the end. And here we have a case where this digital design was used for a hydrogen plant. And this is another case where we have several suppliers, those for conversion, for the process. And we have this integrated automation bringing benefits to the end client. So we're participating in a project in Saudi Arabia where the production, in this case, is green ammonia. It's the first large-scale project in the world where we're also partnering with other entities. Okay, guys? We're open to questions now. I'd like to thank Paulo César and Valdeir and like to invite you to the stage. There's a question here for you. What are the challenges to ensure data safety when you integrate the production process? You can share the question if you like, feel free. When we talk about cybersecurity, there are a number of situations with which we have to be careful. The company's culture regarding data security, but also the equipment that we're going to put inside this plant. The equipment needs to have certifications regarding confidentiality of this data and data protection. And there are also several connections, network connections. So Siemens has a consultancy that we act from the project in the support of the clients regarding cybersecurity. And we also act in favor of existing plants so that they can comply with an architecture that predicts all of the cybersecurity details. Paulo César, would you like to talk, please? It's important to say that security is applied in layers. So Siemens guides their clients based on the rules and regulations that impose these cybersecurity rules, and we guide our clients and develop our products according to all of these regulations. Perfect. Second and last question for the both of you. What is the contribution of solution systems, Siemens solution systems, that allow online monitoring of the energy balance, especially for the purpose of certification, green hydrogen certification? Well, with the arisal of smart instruments that are sending information to the control systems, the status, the conditions, and especially assuring that this measurement is being done appropriately, we have the possibility of connecting this information to the entire value chain. And we have tools that guarantee not only the measurements, but the processes that are being performed in our plants, that they can base themselves on the entire production chain to assure this certification, so that you have a result that is information that is appropriate according to what is developed. Just a little observation about green hydrogen certification specifically. We now have a series of discussions about how to classify this. Siemens has a series of technologies that bring transparency where this energy is coming from, what are the main consumers, and perform this balance, calculate this balance. We also have the power monitor looking at the management at several consumer substations, but it's also important to understand what the requirements are for certification, looking at each country and their demands. And we understand that each country has their own legislations and requirements for certification. Perfect. Valdair Ribeiro, Paulo César da Silva. A round of applause for our two Siemens professionals that were with us at FIEC Summit 2023. Thank you very much for being here. I'd like to ask you to return to your places so you can see our last panel for this morning. Thank you very much. It's a pleasure to have you here.
Everybody, I actually have some info for you. I'll let you know very quickly. I'd like to remind you that I'd like to remind those of you that just arrived, those of you that are arriving now for our final panel, about the QR code. You need to point your cell phone camera to interact with us to make your questions to be able to participate. But before we go to this last panel in the morning, we're going to pass you a piece of info that we just got. It's already here in the event center of Ceará. We already have our Baja H2V, the Mauá Institute, got second place in the second edition of Sai Brasil. It's a student competition. Pioneer for Baja. It's a green hydrogen powered vehicle. You can go and take a look at the vehicle during the break. You can take a look at this new piece of technology that FIEC Summit is showing. It's over in the Mauá stand, so feel free to drop by, and you can feel free to check out all our stands in FIEC Summit 2023. So now we'll have our final panel of the morning. And well, we'll have the pleasure of starting now, speaking about a very serious and well-respected institution in Ceará and Brazil as a whole. As our subject, we have Senai, Ceará, and energy transition. That's why I have the pleasure of inviting the regional director of Senai, superintendent of SESI Ceará. With great pleasure, I would like to ask Paulo André Holanda to the stage. Thank you, my friend. Can you hear me all right? It's cool, right? Thank you, Celcio, for your words. And I would like to quickly introduce myself. I had a request last week so that a friend of ours, a companion of ours, a partner of ours, he was trying to also have his presentation for the Sinai Institute for Innovation in Pernambuco, and really the program schedule was full. And I very kindly, together with our partner, our director Ozio, I wanted you to come here, Ozio, please. He's the innovation director for Sinai in Pernambuco. So my presentation, which would be 30 minutes, I'm going to divide it, share it with him, because I think that that's how we build partnerships, or it's a better place. That's how we do it. So we'll do it together, so we can build a better Brazil, better world. So I'll start, and you can go in. I'll summarize in 15 minutes. I also like to thank my whole team for Sezi and Senai here. I'd like to thank my guests, my great team from Siemens. They're a great partner of ours, or Senai and Sara. That for sure, there's other partnerships with other Senais, but this will be the biggest one, the strongest one, the most robust one. You can be sure of that. It'll be together with us, our Center for Excellence in Energy Transition. So, not to spend any more time on this, I'm going to start my presentation. Let's go. Well, I don't know if this, yeah. I'll just stand in the middle. I just stay here, right? You can just see the screen. This slide is just to show you very quickly the importance of CNI, the Federation of Industries, the system as a whole. You can see the size. I made a presentation in Germany just to show you that we have a very big potential. Brazil has great potential. So you can see, my good friend Julio, we have 27 states. In this case, we have 26 plus the federal district. It's 1,280 syndicates and more than 467,000 industries associated to CNI. The SESI, SESI in Brazil, current numbers are 526 schools all over the country, 514, 114 health units, and 514 mobile units. We created this in 46. So everybody knows what the higher mission is for SESI, which is managing good health for employees and workers, and mainly today, very strongly in our state, focusing on education, basic education, and also mainly the new high school education and working Sinai and SESI and with municipal schools. Sorry, with state schools. All right. So here, Sinai is very important as well in the country. I believe that public policies, any public policy from any government, be it federal, that involves education, technology, and innovation, will need SESI and Sinai. I have no doubt about that. So Sinai is a bit older than SESI. It comes from 42. Sinai in Ceará in November 27 will turn 80. And it has a very strong presence in professional education, professional qualification, and tech services, and also promotes innovation for industry. We act, as I said, in high school, and now next year will be a pole for higher education. And the UN report 2011, also renewed in 2016, that Tanai is the largest professional education entity in the southern hemisphere. In Brazil, there's 583 fixed units and 487 mobile units, and school boats and the Amazon. We have approximately 1.5 million in lab essays performed. All of them are certified. Here we have that story that I talked about at Sinai. It mirrored itself a lot with Germany, be it professional education, professionalizing, and industrial learning, as well as the institutions, which is the Fraunhofer Institute that got this whole thing started. So we have 62 technological institutes, and so now we have two. So Carlos Egberto is the manager of both institutions, Electrometalmecânica, Renewable Energy, and we have 26 innovation institutes for Sinai. There's the one in Pernambuco, which is for IT and communications, and Sinai Ceará. Next year, they'll have their own. President Ricardo will announce for sure next year. Sinai Ceará, then, we have 6 education units. One of them is in Sobral, northern sector, Cariri, southern sector. 4 of them are in the metropolitan region, Maracanã. 3 of them are Fortaleza. 5 mobile units in the SESI also replicates practically the same idea. We have 11 mobile units. So we act as much as in this north and south sector, and in Barra do Ceará, we have a very strong presence when it comes to renewable energy and also focusing on green hydrogen. In SESI, health, work quality and quality of work, safety, and quality of life. The main actions that we develop in SESI for the population, for industries, these are health doctors visits, long-distance medicine diagnosis and prevention campaigns. We also have legal programs, which are the regulatory ones, such as assessments, audits, health security audits, and work security, and continuous education, especially from grade school and middle school, and Sinai with the new middle school, new high school. So now we have approximately 25 industrial segments, different ones that we act upon. The ones that are marked here are the ones where we act because they are next to renewable energy. When we talk about management, we talk about logistics, about IT, about workplace security, chemistry, and electronics, automation. All this moves side by side with green hydrogen. So I'm going to speak about Barra do Ceará, the neighborhood is where the laser cell is working. Has been doing great work. Have our location, which is very near the Pressing port. We have expertise when it comes to offering training and energy mechanics, and the whole infrastructure with labs, classrooms. So it's our portfolio only in this area, of energy sector, generation, transmission, distribution, renewable energy, and of course when it comes to workplace security. So we also have here important partnerships like GWO, BST, and BTT with Mask Train. We have GIZ. We will now have, God willing, next year with Siemens. Strong partnership with Enel as well. Here we have the main labs where we have Barra do Ceará for that portfolio, which I spoke about: generation, distribution, transmission, renewable energy, workplace security. So we have a VR simulator, we have the substation lab, automation control. Basically, these are important laboratories which go through the whole chain. We have these noticeable partnerships when it comes to the automotive sector. All of us, all of our partners inside Barra do Ceará neighborhood. And here we're going to celebrate the opening of the Excellence Center in Energy Transition, Professor Juran G. Picans. And here we have our main partners that for sure. We will have a few others, Fraunhofer Institute. We will be closing a very important partnership, which will be here as well. Here we have our first practical training for green hydrogen. GIZ is our biggest partner in this H2 Brazil program. Very well structured as well. I'm speaking about it on a national level. If I'm not mistaken, Isabella is here. Sonia, I think just 6 states will manage to. In this project, it's 6 states. 6 Sinais in Brazil, or one of them. We also have a very good presence in female participation. This is the GIZ project, Students for Renewable Energy, and the one who are here was with Enel, which was electricians training for distribution centers for women. Here we have a project which I had the chance of representing Professor Ricardo with these teaching institutions. Centex here, Marco Antonio, he's here. I don't know if he's over there. The Centec folks, Federal University, basically FunCap, USA State University. These are, that one thing is that we will be among the first 1,000 multipliers. They'll all be trained in the Sinai lab. So Sinai, in the state of Ceará, has the chance to train these multipliers. Well, the state government acquires and purchases the labs. Okay, so you can see that our Sinai is strong. The state needed all the Sinai laboratories in Juazeiro, Sobral, and here in Barra do Ceará. I want to also thank everybody from corporate and the Federation that it wasn't for you, you wouldn't be able to do this. The Sinai Institute of Technology, Carlos Egberto, is our manager of the institute, both institutes as well as the Innovation Center of the SESI. So Main services that we perform are consulting, R&D, and innovation. We're pretty daring because R&D and innovation, it was supposed to be for the innovation institution. But regarding that, we got good people there that are making a difference. So you can see the meteorology service calibration, which is the strong point that we have in Sinai in development and patent registries, technology transfer. I don't know if Renara is here. Renara, she's our tech specialist. She deals with this labs and tests in the institute. It's electromechanical for energy. These are our main labs. Some of them already have their certification from Inmetro. Most of them, I mean, we have the CNC 5-axis high speed, one of the best in the northeastern region. Chemistry labs. This is where we fixed up the lung ventilators during the pandemic. So we have the innovation habitat. I think you have one as well, the innovation habitat. We have here 10 companies, resident companies, in this interaction of this connection with startups, with entrepreneurship, with vendors and students. Well, actually, we're missing a few companies here as well, but we have 10 of them. And here we have our innovation center for SESI. Once again, we have 9 in the country. I think there's 9. Sierra has one of them, and a real presence is health economy and safety. So it's really worth it. If you don't know it, to get to know this CIS structure in Maracanã. Just to finish my time, we launched yesterday. It was launched by President Ricardo yesterday. A theme call for CESIS and I for research projects, development, and innovation during energy transition. As soon as President Ricardo announced this, I got 8 messages. One of them was from Borges. Borges said, okay, I want to get to know this. Borges is from Siemens. He's the innovation director for Siemens. And others as well, it was going to have available, I believe, starting from today. Neto's here, Isabella's here, Carlos is here. The institute will be coordinating. It's going to be along these lines. Renewable energy, green hydrogen, electrical mobility, decarbonization of industry, work safety. The resource, 10 million reais, not 10,000, 10 million. It's a good thing that the planning folks for budgeting, they're not here because that's going to come out of here. But for sure, a lot of business is going to be coming for Sinai. This playback here, this ROI is going to be pretty quick. We're going to get this back because it's a significant investment for the state. So here we have the QR code for the questions. I think it's functioning right now, and I would once again like to thank you. I will let our friend Oziel, our buddy, our partner in the network, the Sinai Network for Technology and Innovation. And really, I'd like to thank you all. Sorry if I couldn't speak. Wallace, he's always keeping keeping up with me. I don't know if Manuela is here. She's over there. Manuela's there. Yeah, thanks. Basically, my manager is Betty, Sonia, Carlos, basically everybody. Charlie's over there doing some good work in the Industry Observer Telescope, which is a great observer, which is a great tool, not just for industry, but for management, SESI, Sinai, and IL. So congrats for your work. Sampaio, you too. So I'm forgetting a few people, but you'll forgive me, and I hope all of you keep walking shoulder to shoulder. Arrows, Clayton, thank you for your partnership, and I'll be seeing you. Okay, now let's let. I went over time a little bit, but you'll be fine. Yeah. So sell your fish because we want to buy some. Professor, I'd like to first off thank you for being so kind. In the name of the Federation of Ministries of Pernambuco, really, and congratulate everybody in your name. Everybody's part of the FIEC system. Congratulate you for your work. Great work that's being done. It's nice to see Brazil. It's nice to see the leadership that FIEC with the state government and the industry sector is developing to push forward with energy transition for Ceará and the country. I think that eventually, and in an old way of seeing things, there's a competition among states, but we've been working to cooperate. And for such a relevant subject matter, we're talking about a movement that is global, as has been said here by several folks. We're going to have an investment of capital that humanity has never seen before. We're talking about an agenda that will transform Brazil. Depends on the capacity of Brazil to be able to get this opportunity, to use this opportunity, turn this into business and to knowledge and to social and economic development. And you're a big example here in Ceará. So we in Pernambuco, in the same sense, have been developing some work together with Ceará. We've been finding ways to create this integration more strongly, and we're going to be speaking about this, how we're moving around in Pernambuco and how we can connect to SETA. And I'd like to congratulate you once again, our buddy Carlos Isabella, for the work that their networks have done. Well, transforming technology, knowledge, new research into industrial solutions and putting this into the industry and transforming this into new business. That's the role of the Institute, as Professor Paulo already mentioned. The network here, I'm focusing on the multidisciplinary network. It's a network that works in cooperation. So competent, competitive areas get together to solve complex issues, and soon we'll have an institute in Ceará. And they operate several resources of Embrapi, other sources available in the country for developing innovation. And we have tech institutes in Ceará. We have a big leadership when it comes to energy. In the Technology Institute in Pernambuco, we have two institutes, and these institutes focus on developing tech services. One of the big numbers over this network, we've already moved more than 2 billion when you look at the National Institute. So this is an example of strong work that CNI together with the Federation, with the SENAI, has developed in the country. And it's a powerful engine. It's a reason to be proud for every Brazilian to have a mechanism like these networks to help out with tech development and put Brazil at the forefront so that we can truly move forward in the sense of digital transformation, energy transition, and low carbon economy. In this sense, in Pernambuco, we've been working on a decarbonization strategy. The goal of the strategy is to, in fact, accelerate reindustrialization. We're being discussing ways to create a cooperation between the northeastern states to become stronger, specifically with Ceará, because here I'm going to show you a big challenge that we have in the world and in Brazil, and the need to complement things to a national chain. So, as it was said in several aspects here, the importance of the hydrogen market that the energy transition is out. I'm going to focus on one point in this slide. There's a huge agenda for exporting energy, transporting energy through hydrogen to Europe and our countries, and starting from hydrogen as well to develop a low carbon economy of hydrogen as an energy vector. And in this slide, we have information about the potential of the internal market. Brazil has a differential, and they have an internal demand that must be met. We import all of our aviation kerosene. There's local production, but for the most part, we have a global demand. Methanol in Brazil is entirely imported. Fertilizers, among other products. So here, we call attention to our internal demand in the country. So in this sense, all states have internal demands, and connecting to this internal demand, that's our opportunity to add value, leave behind knowledge, resources, and added value, add aggregated value to our country. When we just export and manage to increase commercial transactions, manage to position ourselves in a global market, we run the risk of very soon turning hydrogen into a commodity, just like petrol. So that's something that we're keeping an eye on. In that sense, I put up this image that shows the complexity and the interconnection of the hydrogen chain. So we have hydrogen as a central object, and we have the connections, the applications that other overflows from hydrogen. In this sense, we have hydrogen with a link to agriculture from a point of view of looking at biofuels, fertilizers, among others, maritime side, chemical industry, steel, metal, cement, transportation, energy as a whole. And here it's possible, starting from this image, the states, Ceará, for instance, for us to understand and look at the chains that already exist in the state that are well developed and the future chains that can develop. So, from the energy aspect, Ceará is great. They have the wind farm, sun farm, solar farms. The port side is very strong. Also, steel industry is strong. So this shows a complex chain that must be built in Brazil. We must transfer this knowledge. So when we look specifically at Pernambuco, we have these four main pillars that Pernambuco has a certain potential looking towards agricultural side of things, looking at the chemistry industry, refinery within the app complex, the ethanol side, and swap itself. So in this image, this shows the need to complement the chain. There are aspects that must develop themselves locally, and there are aspects that here in Ceará, they are very much more advanced. So in this sense, we need to connect the states of the Northeast so that we may add to this chain and we may be able to develop a production and a regional chain that may in fact cover and add all these values to Brazil. In this sense, in Pernambuco, working on these six pillars, we are building up an environment that has as a goal to promote intensive research and innovation, making technology more tropicalized that are available in Europe and the US and among other countries, adapting them and generating this local technology so we may develop industry. Ceará also has several initiatives in this sense, but we're speaking about a huge market. We need to add that the states of northeast Brazil as a whole, they accelerate this process because if not, we will never have the know-how here. And to add to that, a structure of pilot plants is what we've been setting up to support this tech development and transferring this technology. So, in what way can we bring in a long term to short term agenda starting from this environment? We are building an environment. I'm going to show you the goal of accelerating this development and this industrial chain. For this, we need to develop people, we need laboratories, we need to attract new industries, and in fact, we need to get push forward for this. We're building up a tech hub for energy transition within the swap complex. This environment is for business development and tropicalizing technologies, regionalizing technologies. So we have a space where we'll have training plants, they'll have R&D projects, they'll develop technologies, they'll adapt technology. After these technologies, they are expanded towards the business development business. So they put a smaller scale plant and then they'll get ready to get their entrepreneurship startup ready. So in this way, we need to build an exchange with the excellence sensor that Sarah is building up within the port. So this is a great movement, but we have several challenges that together in the Northeast we may accelerate upon. This environment has the capacity to receive up to 20 megs lots of production. At the central part, all solutions are contained. We have connectivity layers and data acquisition layers. Each plant that goes into this environment is an environment not just for hydrogen, it's an energy transition environment. So we're talking about energy production plants, SAF, methanol production, fuel production, synthetic fuels as a whole. Every plant that goes in has a connectivity chain, this connectivity layer, and this layer picks up data and generates extrapolations, digital models, digital twins that go together with the agenda that we've been setting up together with Siemens so that we may have an ability to forecast and generate future scenarios, understanding the advancement of these technologies. So all of this will be made available. We have been discussing so that we can exchange this information, exchange projects that are in Pernambuco, bring them over here so we can transfer technology here, other projects that we are already born in cooperation. So our environment has this goal. So we have training plants in the center of this environment where the main plants reduce the cost of development for businesses. So these plants will be plants that the companies can arrive at. They can run their service projects. They'll have hydrogen plants. They'll have plants where we perform the ethanol that work in plants that work in, with aviation kerosene, and starting from there, they test, validate, generate their business models, and then we'll be able to accelerate this process in a pragmatic way. The goal of this space is work on the entire chain, considering renewable energy, biomass energy. It's a characteristic of Pernambuco, hydrogen production and their applications, industry mobility, production of fuels, among others. So this chain as a whole has a lot of challenges, and we do not have all the know-how and all the capacity 100% installed in Pernambuco. In this sense, we need to add just to a knowledge level with Ceará. Ceará has aspects where they're not covered. We add to this Rio Grande do Norte, Bahia. We've worked in this setup. So there are several challenges here. I would like to point out a few benefits of the state of this space, which is reducing risk for companies. We need to be quite pragmatic. In fact, we need to be assertive. We need to transfer technology, we adapt it, and we need to insert it into our market and make it so that the hydrogen chain forms. So we need to bring the knowledge in together. These are a few of the aspects that are being worked on. Pillar number 6 is the tech hub. What the tech hub will be producing, training, and the rest of the state. There are several challenges here that are practiced upon a lot. Ceará, once again, have a big leadership role in the aspect of setting up the supply chain, bringing in companies. They have aspects of demand and production that must be answered. And generally speaking, that's it. I'm within my time zone, my time frame. Professor Paulo, final message, which is just so we can try to bring a bit of what is being worked on in Pernambuco for this development, this technological development, to accelerate this process of energy transition and adaptation of technologies so that we may, in fact, make it so that the Northeast is technologically prepared with experts and competence. So in that sense, we have a few projects that we're working on. We're working on a discussion with Senai Serra, with Pesing, with Port Swap, so that we may create this partnership, and a few projects will be able to develop it so that we may actually bring in knowledge, know-how to the Northeast, and we will make it so that the Northeast will have a strong position in the national industry, because we do know that there is a industrial density that is very strong in the southeast, and we must increase this capacity, this density in Pernambuco. Initiatives like this one, added to the ones that Serra has developed. These are initiatives that, in fact, must generate this connection. So, once again, thank you for the opportunity, and we are available to clear up any questions or doubts. Thank you. Thank you very much to Ozio. And I'll ask Paulo Andreolanda, please, on the stage so we can answer some questions. I have a question for the both of you, actually. Before we finish, well, a bit closer to the center, please. Feel free. It's your stage. So, which technical competencies and behavioral competencies do companies that will install themselves not just in Peseng but other points in Brazil, such as, like Ozio said, in Swap and other points of the country, especially with this arrival of green hydrogen, will be sought initially in the installment of their projects, maybe plants. And after the installment of these plants, you speak a lot about the arrival of these entrepreneurship. But how do you get better get ready in this sense? Feel free to answer that. I wanted to first off cite an example that occurred here in the state of Ceará with the arrival of the CSP, the steel mill of Peseng. They started the steel processing zone was a consortium of three large companies, Vale, Kongfuki, Aposco, two Korean companies, and Vale from Brazil. When they came here to set up shop in the Peseng port industrial sector, maybe they did not prepare their workforce. There were a lot of Korean folks, Yeah, we had a lot of folks from Korea. Those of you that were around during that time, do you remember wherever we went to? You worked from POSCO, Dunkuk. I think we had more than 4,000 folks. I remember that time. So imagine 4,000 Korean folks to work in installment, not just the operation, not yet the operation, but installment. So at a certain point, the CEO at the time of the CSP, who was Mr. Sergio Leite, he called me and said, Paulo, I'm gonna need Sinai a lot here because we're here. We're hiring for technical training and we're firing for behavior. So also it's a matter of a lack of a qualified workforce in the state. We're going to have war operation now. So we signed the biggest contract in 2015 with a private company with more than 5 million reais to train 1,400 people in less than 4 months. That's political. That's professional qualification. And so what happens? Because I believe in good partnerships. When we have good partners, we get good partnerships. At the time, we needed to because we did not have the expertise. Our steel mills in the state of Ceará was stronger in Rio de Janeiro, other places. So we had Professor Tarciso. He led things very well, and we had help from Senai, from Rio de Janeiro, and the Federal Institute as well here. They work in networks. What happened was that we managed to employ 1,000 folks at once, basically. They left the training, they got straight to the steel mill, and then inside the Sinai courses, we implanted a discipline which is educating for values, for to teach ethical, moral values, complementing technical side of things. So we need to concern ourselves a lot with these two situations. Not just technical competence, which is key and very important, but also how to treat people, how to be a leader, how to do things right. That's the example I wanted to explain. Successful, of course, and up till now, you have a contract which says in Sinai not just industrial learning, but also other contracts that we have. Well, now, ArcelorMittal. Yeah. Ozil, please. But just to add to what Professor Paulo Andre said, from a behavioral point of view, we're going from an age of knowledge and content. So it no longer makes any sense where you have to dive into a book and understand several aspects and have the knowledge to solve a specific problem in industry. Because the problem is constantly changing. In that sense, I believe that we need the ability to solve problems. So soft skills that you need to have, these aspects related to problem solving, to be able to connect tools, current situations, solutions from other sectors to be able to solve a specific issue. That's one thing. When we move towards a technical side, I believe that we have a chain to forge, and we're talking about the low carbon economy. For this, we need several correlations. Energy, then after energy, we have a hydrogen vector, then we have several derivatives, several products, there's several connections. To be able to have this integration of connections, to be able to understand the needs, the technical needs of creating new products, green products. We talk a lot about fertilizer and fuels, but the thing is that we will need to transform an entire chain, create new products, adapt an industrial sector which is sort of being on a backslide essentially. And the next few years, we're going to need a lot of training, the multidisciplinary skills of connecting chemistry to energy to engineering, so we have an ability to foresee new opportunities. So I think that first thing we got to do is to have a more technical operational outlook for operating plants and doing maintenance on plants. But after that, we need the knowledge to be able to feed the development of a new chain of new products and to be able to identify the connection between the products that now they are not green, but that may become so one day so we can have an added local value. That's a challenge. Because if not, we're going to set up an industry, we're going to produce a consumption good, and basically that's it. We need to figure out a way to make this come back to us, connect to the chain, so we can actually develop a green economy. Ladies and gentlemen, Jose Alves, Pedro, Andre Holanda, round of applause, please. Thank you so much for being here, gentlemen. And a picture, please. Picture of the communications team for Sezi Sinai so we can register this moment, please. Handshake. Very cool. Once again, round of applause. Once again, thank you very much. All right, we're a bit over time. So we'll have a break for lunch. At 2 p.m., I would like you once again to be here with us at the stage of the FIEC Summit 2023. We'll see you soon. 2 p.m. We'll be right here. Thank you very much.
Good afternoon to everyone. Within a few minutes, we will begin once again our schedule, our technical program here in the auditorium for FIEC Summit 2023. Please go get your headphones so we can begin. and gentlemen, we inform you that as of now we are initiating our program here at the Technical Auditorium of FIEC 2023. Please go get your headphones so that you can watch all of our entire program. Once again, we say hello to all of those that are here at FIEC 2023. Ladies and gentlemen, good afternoon to everyone here. We're back so that we can continue our schedule, our program in our second day of FIEC Summit. Our theme is green hydrogen. We are consolidated as an event in the calendar of the city of Fortaleza and the state of Ceará. We are bringing you diverse knowledge and knowledge that is provided by important names, reference names in politics, economy, and hydrogen. We are continuing our second day of this event, and during this afternoon, in our first panel, we are going to have the theme Fraunhofer ICT, Technological Solutions for Sustainable Energetic Transition. So it is my pleasure to invite the researcher of the Fraunhofer Chemical Institute, Ana Cláudia Nioaki de Sales. A round of applause. Hello. This is a lot better. How are you? Good afternoon to everyone. Thank you for your presence, for your interest. First of all, I'd like to thank the invitation by the President, Ricardo Cavalcanti, and by Paulo de Holanda for their trust in me, trying to establish partnerships with Ceará. So my message, my role here is to open this channel with you, those who are students, professors, companies, and take the opportunity of having a Brazilian. I'm sorry, I'm waiting for my slides. Where are my slides? I need my slides. Oh, here we go. I'm going to end up in front of you guys, blocking the view. Let me move over here. Fraunhofer ICT, the Chemical Institute of Germany. So I'm going to present. Is this okay for you guys? Am I in the middle? Oh my goodness. I'm sorry, everyone. I'm not used to this. Where do I have to be? Oh, okay. But if I'm on the stage, I'm going to be in front of the presentation. But okay. Thank you. So let's go. Let's present this. Let me present the Fraunhofer Institute. It has 30,000 employees, 76 institutes, research units in Germany. It is spread throughout the world. We have representatives here in an office in Brazil at Itaú. We also have a research center. And after World War II, that's when it began. The institute I work in is one of the pioneers in hydrogen mainly. So it's the largest research institute of Europe for applied research. I placed some highlights here. I showed it in my prior presentation, and if you weren't there, Here we have some important phases and focuses, strategies. For example, MP3 was developed within the Institute. We also have a lot of internal activity. We designed some strategies for society, and we take part in these dark blue activities, especially hydrogen technology. And it is connected to the entire chain, hydrogen chain. This isn't working, this pointer. We have renewable energies, production, storage. We act strongly in storage. Battery research, large scale, and operations, use, and safety, which is the great focus, our largest focus at ICT. These are our main competencies. I'm going to address chemical processes, polymer engineering, energy and drive systems, explosives, technology, safety. Regarding chemistry processes, we have biorefineries, electrochemicals, combustible cells, membranes, membrane development sensors as well, which are connected to the chemical process so that we can control the flow within the process. And what else? Let's keep going. I'm not going to be able to talk about everything. So we have the hydrogen production electrolysis. Right now, we're focusing on the development. Oh, thank you so much. The development of electrodes, catalyzers, stability, feasibility studies, both technical and economic, and sizing. Upscaling is also a strong point of our institute, especially the chemical process, but also mechanical and physical. Still within electrolysis, our more specialized knowledge, I listed. Our presentation will be available for those who want to seek more details. We work with electrolytes, electrochemicals, test bench, and a series of equipment and machinery in this field of electrolysis. Chemical product storage as well, continuous chemical processes, which is a great challenge, and applications. We have synthesis and processing of energy materials, fine and special chemical products, catalyzers for fuel cells, chemical storage, refinery, fuel refinery, dangerous and reactive procedures. We act strongly within that unit. Polymer engineering, I made a point of placing this on our slides and talking about it because we recently had a project that was really interesting, and we were to develop the solar panel frame using a polymer, PLA. And we recycled this material as well for the same use and the same application, which in this case was to build the solar panel frame. So we can't replace the materials used in 100%, but we reached a very high rate of substitution with this project. I'd like to show this polymer engineering because it's related to structure and materials that can also be used in technologies connected to hydrogen. All of the technologies that are indirectly linked to hydrogen economy and so forth. Here in energy and drive systems, this is where we're going to dive in a bit to batteries and fuel cells. And they also work a lot with thermo storage. This is something really neat. I placed a link down here if you're interested in seeing more later. At the Institute, we have an air generator, wind generator, and we have batteries, redox flow batteries. So this is another bet that we're placing and trying to bring to Brazil and cooperate for this because it's great for hot climates. So this is a good solution. And one of the greatest vanadium mines is in Bahia. So we're trying to bring this project to Brazil. It has great potential. It doesn't compete with lithium until 6 hours. But after 6 hours of operation, it goes into continuous mode, and it's worth it. So if there are any energy companies that are listening to me here, or anyone that works with this and wants to store energy that has been produced and energy that needs to be stored, this could be a potential technology for that end. In the use of energy converters, let's talk about fuel cells. For challenging common applications, we perform a lot of analysis and simulations for worst cases and how to deal with these situations. So we have membranes, again, cell membranes, fuel cell membranes, which is studied in depth, catalyzers, optimization of unit operations, upscaling, and most of our projects have a TRL between 2 and 4, ending at 6. So a lot of times we also have to scale these products to industrial size. And that reaches about a 7 or an 8 on the scale. Now we're going to talk about energy converter, fuel cells for special environments, subaquatic applications, air pollution. So our expertise within this unit, we make several stations so that we can size this in our scaling up process, upscaling process. We also develop the characterization of the stake or stack. As I said, I listed this for those who work in this technical field. Any mixes, pure oxygen as well. For those who work with measuring impurities of the air, we work with ammonia, hydrogen oxide, sulfur. And now in terms of hydrogen combustion and tests in that, the development of concepts, what is required, what is the law, regulations, what do we have to follow and comply with. We perform several tests at the Institute. And hydrogen, the Institute has been developing this since 1959, working with hydrogen, especially because we began with military technology, the National Military Agency, and to test explosions for rockets. So we have an isolated area it belongs to the government. It doesn't belong to our institute. We have an isolated area. We have to ask for authorization to enter so that we can test these explosions. Once in a while, we hear some noises and get some warnings. Infrastructure, test bench for engines, engines that have one cylinder to several cylinders. I talked to some of you that work with mechanics and that are interested in this area. We also use infrastructure for fuel measurement technology, gas measurement technology, and we have the monocylindrical engine for combustion development processes, and specific adaptations are performed internally. The infrastructure that we have that is available. This is our virtual environment. We've been working a lot with digitization and the 4.0 industry, blockchain, all of these operations so that we can interconnect all of this data. And I work with environmental impact, so we try to connect this digitization so that we can collect data, because that's the heart of optimization, process optimization, and allows us to analyze environmental impacts. So the first step is mapping the parameters of the vehicle and the intended use. Then we design a detailed model of the subsystems, and now we simulate the entire system. Development and optimization of components, because a lot of those components are also produced internally, such as fuel cells. We produce these internally and we vary the materials. There's a prototype there with VL6. And we perform validation tests, sometimes with industrial partners who are partners in the project or contractors of the project. And sizing, which is for large scale. As I mentioned, the Institute acts a lot within this risk assessment. There's a part that I find very interesting, that they hire very young people who know how to search for everything on the internet, and they try to hack the system, and they look and all of the youngsters that are really immersed into technology. This is a government project, and they take these people, and when they find a homemade bomb on the internet or something like that, what they do is they take this combination, they put it together in the lab, and they try to assemble it in the institute. And then they report on this homemade bomb to the military authorities. So they work jointly. And we're here talking about hydrogen, and it's very complicated to store and transport and work with. So we have that ability. Also, on the development of digital twins and security verifications. Here's an example of a plant, a photo of the labs in real time, in real scale, actual scale. And they work with component failure behavior and how to optimize the construction or operation. Here in this plant, they simulate critical states for gas leakages and how to detect that through sensors. They develop sensors as well. It's a challenge that regarding nitrogen. We're also trying to work with nitrogen, the emission of nitrogen from the soil. So we're trying to develop that in Brazil. It's a challenge. A sensor that can detect how much nitrogen is emitted. If anyone works with that, talk to us. We need help. Development and adaptation of special emission systems. I'm almost finishing here. So this is the digital platform to simulate artificial intelligence for turbine operations and combustion engine operations, carbon-free combustion for mobile and stationary operations. So this part of developing analysis is fully automated. The technical and complex infrastructure. In the morning, I presented a project where they do this. It's the hydrogen hub for northern Germany. They are connecting all of the industries and facilities that already exist and the future projects that they're going to connect everything digitally. I'm not going to repeat this, but I would like to tell you that we have these two projects, Hybit and H2 Mari. If you haven't seen it yet, they are connected, linked to the German national strategy for hydrogen. These are very ambitious projects. I'm just going to show one slide of each, just so you can see there's 30 million in this one. This is the hydrogen hub. And the other project is this H2 Mari, which is the offshore wind farm and the direct electrolyzer. The electrolyzer integrated with the offshore wind turbines. And for those who didn't see it, we have the challenges of doing vapor-based electrolyzation, and we're trying to overcome these challenges. Also, hydrogen storage of the hydrogen produced, and how that transport is going to happen from offshore to the continent. We have several projects in this area worth 150 million euros with a funding of 105. Thank you. So I think, oh, just one more thing. For those who didn't hear this, we also have a software. It looks like a game for those who like to play. And it's available for those who want to put together their own hydrogen hub in the Northern Sea. We also have this video if you want to see more details. It's on the Institute, and in this short time, I won't be able to show everything the Institute does. It's very broad and comprehensive. It's one of the largest institutes. There are two Brazilians that can talk with you, my partner, Emilia. We are partnering with Brazil. She is the Vice Director of the Energetic System Department, and I am a researcher of the Environmental Engineering Department. So all environmental impacts are with me, and she is more connected to explosives and energy systems. We also have the Material Department. So if you're interested for research, industry, or anything else, count on us. Was I good with my time? A round of applause for Ana Cláudia Salles. Now, Ana, let's get up on the stage. We have a few questions. Questions that have just arrived from our audience. Look at how cool it is to see everyone here following what you're saying in your presentation. And for those of you that are watching us remotely on the internet from anywhere around the world, how does AI and the Internet of Things being applied to optimize the management of energy in urban spaces, promoting energy? That's a great question because it's not yet answered. It will be answered, and the answer will be developed in the project that I just presented in H2 Mari. For those interested, contact me or Emilia. Her department is the one involved, and they're beginning exactly this process, so I don't have the answer yet. I don't know if they have it yet. It's a huge endeavor, 32 partners, and a lot of people are developing this right now. So my message is, in Germany, they don't know how to answer all of these questions. Come work together with us. Let's develop together. As the professor said, let's all fly together. And that's an excellent question to show the potential that Brazil has to partner with us. And go down the same path. If we stop to think about the associativism, the union of efforts, it's important. What are the technological innovations that are more promising and propelling sustainable energy, and how can they be applied in large scale to reduce carbon emissions? Oh my goodness, you got me there. Let's go one step at a time. Don't try, this is something we've been saying, don't try to copy what's being done in Germany here. We have to adapt or even inspire. There's a lot of things being done outside, and we have this tendency to copy, and we have to be really careful with that. These offshore farms that we see, Germany it's a totally different situation. There's a geopolitical issue in there too. Offshore may be interesting for Brazil as well, but it's going to have to be adapted. Different realities, right? Yes, most definitely. And answering the first question, what are the themes? The person asks, what are the technological innovations that are more promising? In Germany, it would be offshore. So you have to take a look at Brazil and see if they have any interest in that. Also, batteries, like I said in another presentation, energy storage through batteries. If it's over 6 hours of operation, I was talking to companies here in Brazil that want to store energy for long term and a high volume. And this technology can maybe be a lot more interesting. So for those who are researching and seeking alternatives, let's broaden our horizons. There are plenty of research out there. So we have safety, because Germany has been developing this since '59, but they're still developing because they have to update according to technology. Digital, there's a lot to run after to be up to date. And in environmental, I promised I wasn't going to be negative. This is your last question. How does environmental impact assessment work? Do I have 5 minutes? Feel free. Here we go. My first question when I see people saying, let's decarbonize, zero, net zero, decarbonizing culture. And I say, well, what is this? What is decarbonizing to you? And then what I have heard, I work with environmental impact. That's the only thing I work with. So just so you have an idea, that's my area, that's my field. I show trends, I research, I analyze. We look at carbon, we look at toxicity. We're very worried about toxicity. We calculate, we assess resource scarceness. So what we've observed is that the only thing we're looking at is operations. I have a factory, and my factory needs so much energy, so much electricity, and all of this is going to come from renewable energy, solar, air. Now we have hydrogen that uses water so that we can connect the electrolyzer with renewable energies from electricity. So we say, okay, I have all of this, and I have decarbonized. I have zero net. So let me ask you, what about all of this infrastructure? Everything you need to maintain this. Is there no environmental impact? Nothing? Zero? Zilts? Just a thought. Let's think. These solar panels, their production. I think all of you know where they're produced. And where do the raw materials and inputs come from? Chile, Brazil, Africa. Everything goes to China, it's assembled, it goes back to Europe, to Brazil. So we have so much to talk about, and unfortunately, I don't have time. I think this is very important and needs to be said. I was avoiding this because it is a little bit negative, and they're going to say, oh, here comes that eco boring girl. And we have to be careful. But it's something that if we really are worried about the environment, we have to be very careful with what we do. Because I don't know, I think I see hydrogen as a great opportunity. The crisis that Europe is undergoing, it's weird, and Brazil has everything in hand to take this opportunity and see the social part, economic part. I see a lot more than just environmental for Brazil. And I think we should seize the opportunity to generate jobs, train people. That's what we have to focus on. We have a gigantic potential. FIEC has incredible work. I'm a super fan. So my doors are open if you want to develop jointly. If we can help you over there in Germany, use this channel. But decarbonization, that's another deal. If you want to discuss, we need a lot of people. A round of applause, researcher of the Fraunhofer Institute. Anna, thank you for your presence. It was a pleasure. I'd like to invite you back to the audience.
So, so we can continue with this afternoon with a wealth of knowledge in this next panel. It's great to have you here with us, and you as well, who is following us on the web. So once again, reminding you that the QR code, you can aim with your cell phone camera. You can ask questions through the QR code. And so we will immediately move on to the second presentation of the afternoon. I'll be speaking now about the following subject matter: ABB, chemical processes, and production of green hydrogen. I have the pleasure to invite the sales engineer in applications of ABB, Mr. Rafael Farek. I'd ask you for a round of applause for him. All right. Well, first off, good afternoon. Can you all hear me? All right. Great. So, in the name of ABB, I would like to thank you all for your presence, the space we've been given, so we can present a bit about our company, our solutions, and in this half an hour we have, we're going to share some info with you, share what we have when it comes to cases, and a bit of our portfolio and how we can add to this decarbonization process of the environment. Consequently, green hydrogen is a standout component of this process. So here's my contact if anybody needs it. The QR code is here. Here's my training. It's quite technical. In the last 10 years, I've focused more on the market. So actually, two bases: technical is electrical engineering and also the business side of things. And hydrogen today is one of the standouts within ABB. And we have, together with my colleagues here, a large amount of experience in our portfolio to be able to collaborate with you as well. So, regarding from macro to micro levels, because I think that's the way our head works, right? Generating hydrogen, actually producing the hydrogen, is one of the standout points here. Everybody sort of focuses on this. I think this is where the magic happens. The heart of it is in the electrolyzer. That's where the molecule is actually obtained. We get the separation and electrolysis. A few types of electrolyzers we have in the market. Depends a lot on the type of, depends on the electrolytic material we have. Here in the middle we'll have processes, but all processes will demand in a certain way some form of electrical energy. I think that's where ABB comes in. Within this system, our capacity to provide all our technical know-how and expertise when it comes to generating energy. Consequently, how to work with this electrical energy to obtain the hydrogen molecule. Why, well, why hydrogen? Why not another gas? Why not another substance to obtain this form of energy. I think that hydrogen, a few of the positive factors that you can see here, is that it's the most common element in the atmosphere. It's most common in nature itself. Several sources of energy can be produced from electrical energy to obtain what we will classify here as green hydrogen. We do not have greenhouse gas effects when we generate this gas. It can be obtained in a clean manner using water, as we saw in the electrolysis process, at a higher energy density than batteries. We have our compression process. The capacity we have of the gas is much higher than what we have currently with batteries. It can be stored in several manners, but most commonly in liquid or gas form. It can be transported, it can be exported. That's a big talking point here in the seminar. We see very well the generation and the usage in the country, but the export of this gas to other destinations. We ask a lot about the safety of the hydrogen, but in a certain way, we have the same level of security regarding other fossil fuels, such as petrol, oil. So, the characteristics we know about working with oil, be it a area classifications, we already have the knowledge on how to work with hydrogen as well. It can be used by several sectors, be it a industrial, commercial, or transportation sectors. So I think all of this places hydrogen as a standout point so we can really get the most out of this chemical element. Well, we know about the element, and as the electrolyzer is the heart of it, what are the bigger challenges that we've run into when it comes to this type of process? The classification of hydrogen, I think that's known for everyone. Depending on how we generate the energy, for us to perform the separation process of hydrogen is classified in different colors. So this, of course, the focus of green hydrogen is on it because, well, we can obtain it through renewable energy sources. I think that's the big thinking point about how do we obtain the hydrogen that will contribute to the decarbonization or the neutralization of the processes using an entirely sustainable means to do so. Oops. But the challenges that we mentioned, the key points here, I think more than anything else, it needs to have a strong economical value. And there's no point of us thinking only about decarbonization if it's not economically viable for the sectors to do so. I think that's one thing that we need to concern ourselves with when it comes to generating energy. So to maximize the peaks of usage, and my colleague yesterday, ABB, has a management system that does this. What is the best moment for using hydrogen in the market? That is a concern for those that put this energy source industrial point. Well, to know if we are maximizing profits for the sector. Efficiency is a crucial point. We're going to be speaking about the ABB portfolio because these are processes that operate 365 days per year, 24 hours per day in use. So if you don't have equipment with an elevated efficiency level, if you for it to reach that economic level, it's harder. So not just basing yourself on acquisition values for materials, but also you have to think about the operational costs. That's very important in the whole chain to know whether these two challenges can be overcome. Of course, there's the investment costs. I think the appeal for the government that's going to favor a lot. Tax reductions as well to attract more investors to the sector. Really, profitability, that's very much connected to the economic side of things. If companies start to see that all these overcome challenges bring higher income, well, they will of course go towards hydrogen use. Network stability, grid stability, ABB can contribute quite a bit here. We've talked about this a lot in our stand. The big concern is which technology to use, which topology to go into, and the expertise that ABB has in other segments as well brings us a lot of trust about knowing how to act and why work in this grid stability. We know that we're working with electrolyzers and rectifiers. These are elements that generate a lot of harmonics and they have a high voltage level, but now through filters and other technologies, you manage to stabilize the grid, which is a concern that the government has, especially if we're going to introduce new power sources, they must be compatible to the current guidelines, current standards. So, as well as the environmental impact, that's not just a challenge. How do we introduce this? There's the reduction, obtaining hydrogen. It will have its impact sectors as well as the wind side of things. There are large fields to obtain wind energy, but environmental impact must also be assessed for the distribution of this hydrogen and so forth. Right, so speaking a bit regarding, I don't know if everybody knows this, ABB is a Swiss company. It's been in Brazil for more than 50 years now. It's 100 years old. We are divided in four divisions, more business divisions, starting from electrification. That's where we have most of our electronic components, so circuits, joiners, contacts, all of the electrical side of things and components. That's in our electricity division. And a part of inverters, electrical motors, low voltage as well as high voltage. This contributes a lot to the hydrogen part of things. Process automation is a lot of our colleagues work in this division, responsible not just for the introduction of the equipment, but the delivery of the whole solution. So when we talk about, okay, I want a hydrogen plant, we can create a project and deliver it with the whole system set up to the client. And the robotics system, that's a standout point for ABB. I think that in the past few years there's been a growth in the country, starting with the introduction of more robots in industry. Robotics is a standout point, and for ABB being a world leader when it comes to producing robots. When it comes to motion, our big motto is to write the future of movement. So in the past 5 years, the decarbonization side had a lot of bias in our division, not just with hydrogen, but other sources, reduction, circularity. The ESG subject became very frequent when our debates. So more and more, ABB observes its processes where it can collaborate, not just because of its technology, but also with the reduction of environmental impacts and helping communities where they are. All throughout history, I come to the last 5 years, I think that this motto became more proportional in our company. We spent we sent wind systems, wind farm systems, and we didn't talk about this a lot 10 years ago. Now they're very common wind energy production. Here in the Northeast region, we see a lot of wind farms. ABB has all the knowledge to have generators and converters here to capture this movement energy and turn it into electrical energy. It comes to the stability and redistribution. So this also goes back to ABB's history and Itaipu generating energy. Generators to catch or hydropower for electric energy is also that part of our history. The new tech applications. ABB also develops a lot of its projects and technology in their excellence centers. So depending on the product, there are several centers the whole world over. The main HQ is in Switzerland, where we have a large part of the development of technology, and then industry decarbonization. The main point, we already start to see heavy industries, metal industry, mining industry. There's a big discussion regarding decarbonization, and also not just for a reduction in emissions, but also when it comes to compensation. Since the products cannot be immediately substituted, there is an interest in compensating the emission of CO2 through a collaboration with the generation of clean energy. Speaking about solutions, then, what can we do to provide in terms of the electrolyzer? Here's an example of production of 1 gigawatt. ABB can participate from the generation of the energy, be it from whatever source it may be, wind energy, water energy, hydropower, other sources of generation, energy generation, well, the cyclic compensator, where we stabilize the grid for 60 hertz. Sometimes we use synchronized converters, where this movement can also be used to generate energy. On the transformer side, mid-sized cubicles, transformers, and then we reach the heart of it, where we act on the electrolyzers, a few rectifiers from several different sources, a few different topologies, which we worked on, up till 1000 volts DC. These are possibilities that we can work on with the electrolyzers in our applications. Right, so two solutions. I will not go into much detail. We can talk at the stand, or you can send me an email afterwards, that's fine too. To be quick about this, has two solutions. The most common one that we have on electrolyzers are the C880. They, at the end, 80 is what we call an ABB. It's a well-known one, and 10 years ago, if we start to have some synergy between mid and low voltage, getting rid of that dilemma where low voltage would be something complex. We had a lot of paradigms on middle voltage of how to act. So ABB started to have a very high synergy with their low and middle voltage products. So anything that ended with an 80 in terms of converters or inverters, they belong to the all-compet family. So they exchange identical interface, so control boards, firing systems, communication options. What changes? Well, what changes is the employed power technology. So with the DCS, what we use as a base, what is most common in terms of rectifiers, especially for electrolysis, is a technology that is quite old, that is well known, highly trustworthy. Once the power system with high power system, they use this system quite a bit, up to 20 megawatts. We can meet the need with this incorporated solution, air-cooled solution. So what starts to happen here, the discussion point, is that this technology injects a lot of harmonics. So if I injected at least 6 pulses, it will be around 30%. So then I go to 12 pulses, 24 pulses, trying to limit the amount of harmonics. So that's one point. That's a collateral effect of these systems. Is the distortion point that it has as well. Potency matter is something that, well, since the systems will be connected to distribution systems, the stores will worry a lot about harmonic potency as well. Since there's no modulated potency, but it is measured and it is fine. So very low potency, they have a reactor in the line. So there are fines regarding this. So the introduction of this is also a concern. What is the voltage that we can work with in the network? A big advantage of the thyristor system is that it is compact. The dissipation compared to other systems is lower. And the way to mitigate this type of harmonics is increasing the rectifier, working with more pulses so we can leave it at a better level. When we go to a GBT family, the question is how trustworthy it can be in a thyristor, and ABB has the knowledge that semiconductor creation was made by ABB itself, so we trust a lot. The heart of it is, which is the semiconductor, based on the applications we have in the market. So high credibility applications, generating energy, mining, metals, laminators have a high load. They use GBT systems already. That's why we say we are very comfortable in the GBT technology also here at the rectifier side. So we have a few cases in Europe where we have a migration of the thyristor system to transistor system and also keeping the trustworthiness of the system that we know we need it. We have the possibility up to 10 megs automatically since working with rectifiers that are active bridge rectifiers. I mitigate the harmonics at the entrance. So I have a lot less concerns when it comes to emitting harmonics, meeting the guidelines of the Ordinance 19 for the employed typology. So this favors a lot when we look at the connectivity with the grid to this type of technology. Another important point is that I bring the potency values, the power value, to it's a very far level from being fine. It compensates for other elements that are going to be connected in the same line. So if I have some sort of engine, a motor, another element that knock down, the system will allow us to increase the potency and allow us to avoid a fine. That's a solution that we have seen, seeing as there is a good acceptance and the electrolysis market due to the direct connectivity to the network. Where does this generate a collateral side effect? That's one thing. Its dissipation is much higher. It's a lot more frequent than the thyristor. Due to the frequency, the thermal dissipation is much higher, so it brings a need to better cool the system. And there's a likelihood of working not just with air, but also with water. Another market paradigm is to mix electrical energy with water. When we see this setup system, it gives you a lot of trustworthiness to use a water-cooled system due to the efficiency in cooling. But also when it comes to the area it will occupy. So if I consider an air-cooled system, it occupies a much higher amount of room, much more room than a water-cooled system, which is more compact. Another important component, which is not directly connected to the electrolyzer, but will be in processes around the system, a lot of pumping systems, a lot of compression systems, all of this will require motors. So what moves the industry today is here in electrical motors, electrical engines. So if we don't look at this very well, it can sort of turn into a problem. 40% of the energy consumed in the electrical network today, globally speaking, comes from electrical motors. So if we don't concern ourselves about this being an issue in consumption, so that's why efficiency is very important. Sometimes we compare things, okay, this motor is 0.1% more efficient, doesn't seem like a lot, but when you put it on paper over the years and the investment of the energy cost, 0.1% is a huge deal. So that's what we talk about when acquiring a motor. Not just the price is important, but its technical specs, which will make its operational cost a good thing during its life. So that's why that's something you need to pay attention to. ABB notifies this. So and also its acceptance. Today we managed to get to M3GP motors or Cinerem, which is the one that we have, with a classification up to IE5 in efficiency. That's more than 98%, reaches almost 99% of efficiency on a rotating machine. Just so you have an idea, on IE3, it was about 96 to 97%. I'm talking about 2% more. And its whole life of the product, if we do the math, depending on the energy cost that is being applied here, or the amount of years of usage, you get that back in 2 years. So I could get a new motor, much more up-to-date technology, and it will pay for itself in 2 years. And these last for 10 to 15 years. So you get an ROI very strongly. It's very, very quick ROI. Generally speaking, the ABB's features that we reinforce a lot in the market, our systems are very modular, easy to integrate. This integration with existing systems, more and more electrical systems, input networks. It's been a modular system. This favors a lot. In case of failures, you can have quicker replacements. So ABB systems tend to be very much more efficient when it comes to its modularity. High efficiency, as I said. Clients always, sometimes they compare the cost of the acquisition and they forget the efficiency. This is something that will bring you to a lower operational cost. Robust systems and low maintenance systems, that's another factor. How much does it cost for you to turn off a machine like this? You have electrolysis, you sold that energy. How much will it cost you to stop production for a while? That's an important factor. How robust the system is key. High trustworthiness in systems, safety. Yesterday, my friend presented energy management systems. How important is this for you to be ensured of the safety of your process as a whole? Low electrode impact, especially when it comes to GBT. As I said, we have continuous current peaks with the grade, the electrodes less than 1%. That's another feature. Have low peaks, increasing the lifespan of the machine. When we talk about the lines we're presenting, these are production lines that are serial production lines. This is very favorable to logistics, pricing, availability, and support networks. So these are ABB line products. There's nothing specific dedicated to this. It's very favorable to logistics and commerce. More and more connectivity has been part of our equipment. So automatically remote monitoring systems are already integrated. We know nowadays that we'll have systems that are difficult to access remotely, so consequently, ABB possesses technology to coordinate them and to monitor them at a distance. What is the concern here? That we will look to a lower impact when we stop the machine. So now we possess tools. One of them is called ABB Ability, where the ABB assets go up to the cloud. They're uploaded to the cloud, and then there's an AI there to map out what is the current condition of the piece of equipment. And there's any variable that is outside the control zone, it is automatically informed so that we will set up a time so we can perform the maintenance on the device. Another important thing that we point out here is the IP classification. So we're going to have, these are processes that require adequate classification, especially due to the explosion issue. So the standards, the guidelines ABB has knowledge of it. So these products are certified for application and explosion risk zones or classified zones. And certification approval as well. Up to date when it comes to rectifiers and components as well as others, which will be specific to the segment. ABB is also has a global certification council that will emit the needed certificates for commerce. So finally, not just the side of products being important, but the local presence. And when it comes to services, it's been, I believe, a important factor when it comes to deciding on a new component or a new system in the market. As I said, more than 50 years in Brazil, we've lived through several development waves in the country. Because of this, I believe hydrogen will be one more of them, another one. And we want to count with our whole team and manage to bring in all the needed support to the market, not just in sales, but commissions, parts, maintenance, training, substitution. All of this is in loco. So we have a technical team in the country to be able to, after the sale, we'll be able to operate these new systems with our clients. Oops. Well, it's more than 180 years serving, speaking globally for ABB. And we can count up more than 1,200 hours helping our clients, speaking globally. 600 partners, not just ABB itself, but also developing partners that can provide further assistance to us, services in more than 70 countries, including Brazil. So, this whole global chain, thank God our clients can make use of all this technology and this communications network where information and technology can flow and also being present in our country. Next slide, please. I think that's it. Thank you for your attention. Thank you for your attention, for your space. I'm available to answer any questions. Thank you. Thank you so much, Rafael. Rafael, let's head into the stage, please. We have one question. Is that okay? Yes? Okay. Is there a lot of difference in cost between 12 and 24 pulse technology? No, no difference. When it comes to pulses, no. When we get the same technology for thyristors, and we look at it within its actual features, what's going to change a little bit is the transformer, which is going to have more components in the rectifier. Well, that's not, especially in the thyristor, the cost is not that noticeable. When we change technology for GBT, then we have a bigger difference in cost. And the big advantage of going to GBT is, of course, there's a higher upfront cost, but you'll avoid active filters and passive filters, which will mitigate harmonics and potency factors. If we do the math, you're gonna get it back if you go to GBT. So when we look at the components, it seems like it's way higher. When you look at the whole thing, integrating into the network, of course, GBT gives you a lot of advantages. Yeah. Great. I would like to ask you to a round of applause to our guest, Rafael Farak, sales engineer and AEB. Thank you so much, Rafael, for being here. Feel free to sit down during the whole afternoon and we have to watch what's going on here. I hope you're always welcome at FIEC Summit 2023. Remind you once again that for our QR code, I see a few new faces on the stage, just got here, to watch our presentations.
Right now, we're going to talk about a theme that perhaps many of you have been following up in the local press, in the regional press here in Ceará, but perhaps you've seen it in the national press as well. Our theme is now EDP, the same pilot project, which is a project that it is a pilot of the Energias Company of Portugal, and it is with great pleasure that I invite the specialist from EDP, Diego Rebouças. Good afternoon, everyone. Let me stand here in front, over here to the side a bit so that I can present this. Thank you so much for the opportunity. EDP thanks you for your presence. For this moment when we present the pilot project for green hydrogen, I hope to contribute and to foster this very important theme. Before we beginning, we have baptized the project as Pesing H2V. This is the name since its inception. It began in the middle of May 2022, and we baptized it as Pesing H2V. I'm going to talk a little bit about EDP. It's a world player in terms of energy generation. It's a company that specializes in generation of energy, solar, renewable or not, transmission, distribution. You can find it in all of the Americas, in Europe. Its origin, EDP, is Portugal Energies. And as we say, it works with all of the areas involved in generation. As our goal, we want to be free of coal, and this is an understanding of the company. We want to be coal free, and in 2030, we want to be completely carbon neutral. And along the presentation, you're going to understand the insertion of the technology, the pilot plant, our technological deliveries that pertaining to this project. Just so you can understand this, we're already a company that masters renewable energy, but we also sought to understand hydrogen and to know hydrogen and all of its characteristics, the characteristics of the technology from water treatment to electricity specifications, control, with a view to scaling this knowledge from small plants to large scale plants, focusing on the client and being able to provide this knowledge to the client within this context. Just so you can have an idea, there's a group of 20 professionals, from managers to technicians, within this column here that speaks about learning. All involved in the pilot project. We understand that hydrogen is a molecule that has a huge capacity of converting into other products and other added values. We understand that in a not so distant future, this reality, when we talk about a carbon line based on Fisher Tropics, and we emphasize diesel, methanol. We understand the context of green energy and nitro fertilizers. Like in the summit that we've been following and monitoring, we see people talking about the importance of nitrogenized chains. So we see that as well. Let me just move forward a little bit. So as I said, we understand this theme. We understand that this is a technology that is 150 to 180 years old, and hydrogen is brand new. Hydrogen is not yet financially equal or equitable. We believe that in 15 years, we at EDP believe that they will be equal. And the first steps in knowledge and training and understanding we are taking right now. The justification of the project, we see a series of characteristics. We see hydrogen as an international commodity. The H2 bid, H2 Global, is taking place now. The geographical position of Ceará and of the thermoelectric plants. I'm going to be commenting in the next slides that there's a symbiosis of processes of thermodynamics and the characteristics of the endeavor itself. And this H2, we use it internally, a great part of it anyway. And the domestic market, local market, companies that become partners and use this H2 within their processes. We could talk about ArcelorMittal. He's a huge H2 consumer, so this synergy, this exchange of information between technicians and engineers and EDP and other companies who are partnering is very important. Let me just move forward here. Oh, here we go. So in the general goals, we have a scenario roadmap. We simulate scenarios with 1, 10, 100, and 1,000 megawatts. Now we're going to use a scenario with 1 gigawatt. We have an institution called Giselle, and with its researchers and technicians, they simulate these systems, and then they understand what we need in terms of infrastructure, appropriateness, and adaptations for these systems. This pilot plant, as I said, We stress its operations. We see upper limits, lower limits. We exchange parameters for electricity grid so that we can verify the behavior of this equipment, and that's exactly what we intend. The project, as I said, Giselle is part of its structure and market and financial feasibility. We have EDP Smart. We built a solar plant with 3 megawatts. EDP Smart built it. The electrolyzer that we specified and acquired is from Hytrin. It's a 1.25 megawatt electrolyzer. We issued a notice, and then in the middle of May 2021, Hytrin took part in this notice. And Siemens, who is German, also took part, but Hytrin won the bid. They have excellent professionals. Daniel Lopes, Antonio Marinho, they are wonderful. And we exchange a lot of information. And IACHI, the institute, it's part of the storage technology. There are a series of characteristics pertaining to hydrogen, its transport as well. So IACHI supports us technically in these solutions, and especially one of the utilities that we have with H2, which is a converter. Well, remember I mentioned hydrogen technology, its deliveries, H2 in other words, the thermoelectric plant, its operations consume energy. It converts raw materials to energy. With this characteristic, we proposed in one of the thermoelectric burners, we proposed a diesel burner with H2 at a proportion of 98% diesel and 2% H2. And we did this through a tube and with the purpose of having H2 placed within the diesel within the thermoelectric plant. That was our proposal. We've practically finished with these tests, and now we're going to do field tests and operational tests. Here we have the first symbiosis in the use of H2 within the Bessane thermoelectric plant. The second use that we have within the thermoelectric plant is in generators. The thermoelectric generates 720 megawatts. We have 2 units of 360 that comprise it. What you see here, this first part, is where we have the high pressure, medium, and low pressure turbine. This is the generator. This generator, it is already refrigerator with hydrogen. So what did we do? We substituted, replaced. We used to buy this from the Camaçari pole. It came in trucks. It's gray hydrogen and comes through the natural gas chain. White Martins is our partner. It used to provide us with this hydrogen, and then we performed the process of refrigerating the generator. So what we did was replace it. We exchanged the matrix from gray hydrogen to green hydrogen, and it's in perfect operation. Hydrogen is actually a great means for refrigeration. It has a series of particularities, low density. The molecule has a small atomic ray, and it's a great refrigerator. So much so that we use it in our operations. Let me move forward. This is a photo, in a perspective photo of the thermoelectric plant. We are installed along 7.2 hectares. This is our solar plant. We have 10 inverters. It follows the sun, so we have an increase in efficiency. They are two-faced, 550 watts at peak in a 7.2 hectare area for these solar panels. This is the unit, the hydrogen generating unit itself. It's a Hytrin model, the first container. There are 2. The first is the energy rectifying container, and the other contains the electrolyzer and the electrolysis process. Over there to the right, you will see the tank. That is a storage tank. We keep 5 cubic meters, its hydraulic volume. In overall lines, that is our energy generation system. The general characteristics of the pilot plant, just reviewing this: 1.25 electrolysis. This was the first system to rupture 1 megawatt in the Americas. If we consider Central America and South America, it was the first to go beyond 1 megawatt, a production of 2.23 of hydrogen, highly pure, we call it 4.1, 99.999 of purity, and at 40 bar. So those are the characteristics of our pilot project at Pecém. It's open to visitation. Come get to know the technology, the processes, and the ways of operating. We have 2 videos here. I'll show them in a bit. But the first one focuses on the thermal chamber, and it verifies the heat spectrum. Highly pure hydrogen is invisible, so in a combustion, you can't see it. You won't be able to differentiate what's combusting and what's not. This is the heart of the electrolyzer. This equipment is where we generate hydrogen and oxygen. Let's begin the video. Watch this. In a little bit, the camera is going to move to the right a little bit of the flame, and you will not be able to see the flame. See that? Completely invisible, exactly as literature postulates. So what you saw going up here is hydrogen formed in the cathodic chain. The entire project cost 41.9 million reais, 14.7 are resources from CAPEX, 26.6 are from PDML. We also had a counterpart of 0.5. I brought this issue here of the visits that we receive from researchers and engineers and technicians and professors. This is one of the questions that we get most frequently. How does EDP treat the water? What does the thermoelectric plant make available for water treatment? What is available for and make this water available for electrolysis? There are other questions, but due to our time limitations, I won't be able to focus on. But storage and explosivity are other issues. And this one we chose to bring here, and we are going to try to attempt to answer it and share this information with everyone here, and tell you a little bit about how EDP does this. To understand a little bit about the process of being installed in Pecém, we have to understand where the water that reaches the thermoelectric comes from. The water that reaches us comes from Castanhão. It's a reservoir, the largest in Ceará, one of the largest in the world. It's located in Jaguaribe, a central area of Ceará. And the characteristic of this water is very important. The geology of the place: the water is going to precipitate through rain. It will enter into contact with the soil, and carry several minerals. And these are physical chemical characteristics that our team is going to size and calculate for its use. So the origin of this water is very important. This is very characteristic of Ceará. You may not find the same characteristics around the country, so it changes according to where you are. So our geology is rich in magnesium. So this water has a lot of calcium to be treated at the treatment stations. Here we have a basic table that summarizes the physical and chemical characteristics. I took the main elements so that we can talk about the water that's going into the electrolyzer. Conductivity, all of these parameters, within these parameters, conductivity is one of the main ones. It will arrive at 0.5 microsims. Depending on the period of the year, this might be below that level due to the level of rains. These salts are diffused within this water depending on how much rain is received. So this water will go down from 550 to 0.68 microsims. This is a standard column. This is a standard characteristic of the water that is provided to the electrolyzers. We work with a minimum of mineral salts. We have a water that its pH is received at 8 and it is converted to 7. Temperature is atmosphere. Turbidity is 1.7 NTU. We reduce that to 0.13. Calcium goes from 40 to below 0.001. This is equipment error in the reading of the analysis. From 60 ppm, we bring this down to 0.001. These are the correct characteristics we see in general, and if you like technology, remember this conductivity right here. We had a colleague of ours, who asked, what if we use ocean water, seawater? Depending, you may find 56,000 microsims in this water. It's impossible to. Is it impossible to treat? No, it's not. But the robustness of the system will have to be huge in order to treat that water. Let me move forward. The processes at EDP. We start with a flocculation tank. Then we move on to decanting. In flocculation, we use aluminum-based products. It agglutinates, and then it decants, and then we go through ultra-filtering with the difference in pressure to remove organic materials, fish residue, shellfish residue, and others. Then we go through our first reverse osmosis process. Then we go to the cationic. We advance to the tower that removes the carbon. Then we go to the amniotic exchanger. We have a combination of the cationic and amniotic permuters. And that's how we reach the quality that we showed there. This is what we do to change this water from the conditions we receive it in to the conditions that the electrolyzer receives it in. This will all depend on the local characteristics. In the south of the country, you'll have other characteristics. In the Amazon, you'll have other characteristics. Seawater will have other characteristics, and so forth. We have some photos from our process, the process of osmosis. This is the macro process combinations of these processes with a lot of physical and chemical aspects to be able to fit this water into the profile that we need for the processing at EDP. That's it. I'm so sorry. I'm sorry if I rushed. I had a limited amount of time. The summit organizers asked me to keep it as short as possible. And that's it. A round of applause for Diego Rebouças, a specialist at EDP. I would like to thank you. I know Diego from Pessin already. It's always a pleasure to see you again and to have you here. I'd like to invite you to sit back down in the audience and follow our program. All of this very vast and rich content. Thank you so much for being here. We're going to have one more panel right now. I'd like to remind you of the importance of interacting and using this QR code to participate here with us so you can take part in everything that's happening in our technical auditorium. In FIEC Summit 2023, we have another global giant here on stage. Up next, it's my pleasure to tell you that our next theme is Deloitte Global Perspectives for Green Hydrogen, Energizing the Path to Decarbonization. We're going to have the head of Green Space Tech of Deloitte, a specialist in decarbonization. I'd like to invite Breno Medeiros.
Dora Neônico. Passa pra cá. Can you hear me? Okay. Great. Well, good afternoon, everybody. Thank you for letting me be here. I'd like to thank Constantino Fractio for the invitation, being once again in Fortaleza with you. I am presenting once again a global study, which is a scenario, a plausible scenario for 2050 in production of hydrogen, as well as hydrogen trading and its derivatives. This is a study done by colleagues from more than 3 countries: Deloitte, Germany, Deloitte, France, Deloitte, Australia, France, and Germany. So 3 countries which drove this research. It's not a forecast, but it is a plausible scenario of what is the maximum potential of green hydrogen up till 2050. This is over time, 30, 40, 50 its derivatives and its possible flow in the world's countries. What do I use this? Okay. So I'm gonna speed up here. Well, the reasonable scenario here, I don't know how long you've been here, but some info is repeating why hydrogen. I think the Paris Accord was iconic. Many countries signed a protocol where there was a consensus that we needed to take actions to increase decarbonization and production processes. And basically, if we could reduce part of this process, decarbonization would come through electricity. When it's not possible to electrify or reduce the efficient consumption, you would go towards carbon, reduce carbon. If it's not possible to electrify or store carbon, you could have hydrogen as a good solution. I still don't understand where I'm supposed to point. I think now it's fine. Well, different forms of hydrogen. I will focus out of all these forms. Of course, we're an event that is for green hydrogen. Let's see if the laser pointer works. What's that? Just click it. What about the pointer? Does it work? Laser pointer? No. The upper one, it's not working. Yeah, it's not showing up here, but it's fine. What's that? A laser. Well, anyway. Well, we don't have a laser. What? I mean, just hold on. Let's move forward. Where do I point this to? Where do I point this to? Excuse me. No, I just want to know where to point it to. Okay, good. Now it works. Now it's worked. I'll point it at TV. Sorry about that, folks. So we have different colors. Green hydrogen is renewable, basically. Wind and solar energy. In gray, we have mostly the energy produced worldwide, natural gas, and was the possibility for nuclear-based hydrogen as well. Well, 3 big factors that turned green hydrogen It's not just in Brazil, but different countries in the world, continents, they are studying green hydrogen. There are sectors, there are applications. Electrification is more complex. And when you speak about mining, large trucks or locomotives that work for mining, they have reduction in electricity of some international mining companies, Brazilian companies, have fired up to, admitted that up to 2030 it's not so trivial to electrify, make their transportation system electric. So due to the size of batteries, the charging time of batteries, it's difficult. Or because of the blast furnaces, if you make blast furnaces electric, there are limitations to that. So in these factors, hydrogen can be a good solution. Energy resilience. I think we're going through a energy crisis, geopolitical energy crisis, since the Ukraine war with Russia. The price of gas and oil has gone up. Also, the dependence of energy systems in the world of these fuels due to energy, lack of energy resilience, it is important and it becomes an important energy source in the world because we expect that the hydrogen itself, a good part of the production will come close to consumption itself and the political moment we are in. I believe that the countries that signed the protocol, the Paris Protocol, they've been working to reduce their emissions. But it's not just companies, but state governments and cities have worked to decarbonize. So there's a state in Brazil. They are concerned that eventually they must close their coal mines and thermal mines. They launched a bid recently for planning. So when the state closes their coal mines, what do you do with the cities? That's a concern for organizations and governments as a whole. That's a very favorable political moment for the production of clean hydrogen in the world. So, how did he make this scenario be plausible to the world? My colleagues that set up this model. One of the heads that worked for years on the IEA and modeling energy modeling on a global scale, the HYPE model from Deloitte. They work in a top-down manner, so we can reduce emissions or liquid emissions up to 2050, or the possibility of decarbonizing hydrogen. How much hydrogen the world should we be producing? And bottom up, right? Which are the consumption processes themselves? How much would it need to produce to get net zero at 2050? This modeling was done through pure hydrogen, their three main derivatives: ammonia for methanol, SAF, which is the renewable aviation fuel. So, for like any model, you need to set up a premises. So the premises of this model, they are have a limit for the sustainability of natural gas. You forecast it's foreseen that over time, the regulating structure that the government will put limits on the use of natural gas, also for blue hydrogen. They would not approve new projects, and the crucial role will be to but put forward hydrogen as a big factor for allowing for decarbonization of the production systems. Well, I'm going to, well, there's a model up to 2050. I'll sort of break down the analysis. So, what is the size of the market that this can reach? Because that's a big question to ask. What is the size of this market in 2050? So that my companies and my cities planning, I can set myself up, see if it's worth going into this or not. In our model, the forecast is that up to 2050, the yearly market will be of $1.4 trillion. When it comes to the capacity of reduction of emissions, the forecast is that we can reduce 85 gigatons of emissions in 2050. The volume of investments in our question that is made is what is the volume of investment that hydrogen can reach the world? It can require more than several trillions of 9 trillions so accumulated dollars, accumulated investments. It's a big operation when you authorize decarbonization, where you close coal plants or natural gas or diesel plants. This causes a lack of jobs, but there are green jobs that can be created through the production of hydrogen through equipment used with solar farms, as well as wind farms, as well as the production of the electrolyzers and the parks themselves will produce hydrogen. So there is a forecast of a generation of 1.5 million jobs between 2030 and 2050, only for developing countries, which are the ones that could be affected, especially where we are included. So why hydrogen regarding the how practical it is in its usage as well. It pushes itself so widely in the possibility of application that the hydrogen has. Different industries and different means that consume energy, we can eventually use hydrogen. This was talked about in several presentations these 2 days, but in industry, it's too bad I don't have the laser pointer, but on the heating part for furnaces, they have a harder time electrifying on steel, substituting coal, for instance, fertilizer with ammonia. Part of it is not just new usage of this. Part of the hydrogen is the substitution of the gray hydrogen. In the chemical side, transportation, we have transportation. Speak about navigation, aviation, heavy transportation, and you have to solve the intermittent renewable energy. I think more and more intermittent and renewable energy is becoming a less foreign term. You don't have sun the whole time. You don't have wind the whole time. You have peaks. So eventually, you solve the intermittency matter with the production of hydrogen. So to summarize, folks, we have applications in industry, in transportation, electrical generation itself, and build construction. It's lesser in Brazil, but those of you who had the chance to go to Europe and the U.S., the heating system, buildings, a lot of them are gas heated. I could live in England in 98. In 98, the heating system was gas based. Different from Brazil, where we turn on an AC to sleep, or during the summer, the heating system of colder countries is always on. So that's a possibility for you to replace the heating system in residences. So you spoke about 2050. So how does this evolution function over time? You have accumulated emissions, which is their emissions distributed by sectors over time. What do we realize? The evolution is that the transport system evolves after 2030. Why this evolution in transportation after 2030? Because a good chunk of these technologies are still being researched. If you look up in Google, mining companies, for instance, they're working with technological partnerships for producing large scale trucks or locomotives powered by hydrogen or derivatives of hydrogen. So, starting in 2030, the transportation system has more capacity to absorb this hydrogen, and because of that, reducing emissions the whole world over. Other sides is that due to this consumption, there's very little waste. It doesn't enter as a whole, but on a practical manner of speaking, it has low impact when compared to transportation and iron when it comes to decarbonizing the steel industry, for instance. So 1.4 trillions, for instance. How does this work over time? In 2030, a market estimate, 640 billion millions, and 2040 gets to a trillion, and 2050, 1.4 trillions. Okay, how to distribute in the world? Who's going to consume? One thing is to speak about possibilities. Which are the possible consumers? Naturally, there's China, South Asia, North America, and Europe, the big four consumers of this energy source in the world. Regarding commerce, at the start, until you turn the fuel a commodity, and it's also interesting to discuss this, for it to be a commodity, it needs to be certified, needs to be standardized, it needs to have a standard that is stipulated for all the production in the world, and you need to establish a transport infrastructure for storage. It's not that trivial, and at least 2030, this commerce will not be that developed. These are premises that we are foreseeing a plausible scenario for the future. What is the consequence of this? Commerce will happen more regionally and not in a globalized manner. Everybody can export and produce for everybody, no. But, geez, there's a little line here coming out. It's a possible export. That's another arrow is a possible import. So we're talking about, okay, for the latest another M, and I had to speak about a possible exporter of hydrogen. So how come there's a little line going in? Are we going to import hydrogen? Well, the reasoning behind the model is that it's very simple. Basically, you simulate the potential to produce and the potential to consume. Theoretically, you export and there's still some left over. So due to the possibility of usage, it has a high potential for consumption. So at the start, Brazil shows itself as a region in Brazil of South America as a possible importer. At the start in 2030, the big demand that exists, possible importing is for ammonia and a possible usage. We've been discussing this in the sector or fertilizing sector of agricultural business. You substitute transform, for instance, start to produce green ammonia, substitution of current day production, and for neighboring regions. When we go to 2050, the scenario changes. We can have an equation the of the parametrics doors, infrastructure, equations. So you have a much more liquid flow of exports and imports. You can see South America and Brazil already appear possible importers and exporters. There's a need for large size ships to be able to transport their derivatives around the world, and this commerce becomes more fluid. So you have an importance in 2030 as well as 2050. The Middle East and this potential, folks, I forgot to comment this at the start. It was done in two ways: the potential heat map of the world, and there's a wind map of the world. And going from there, what is the potential for each region of the world, and the available land as well. So last speaker spoke about water. If it's renewable for hydrogen, he also calculated in the model the availability of land that he have in regions to be able to set up wind or solar farms to generate the energy needed to electrolyze the hydrogen. Okay, so the market triplicates, and you have 500,000 tons of green hydrogen is equivalent. Methanol and SAF becomes more, they become more consolidated markets. If they have you're developing equipment in aviation, you have ships, you have large trucks. It's possible to move them with hydrogen or their derivatives. So these three derivatives, the big commerce, the expectation of ammonia, thinking about 2050, it develops itself more strongly with methanol and SAF as well. So in industry, who are the big consumers? We spoke about the potential and the market itself. So we have industry itself, a demand for hydrogen derivatives, 135 million tons of hydrogen for steel industry, for us to produce green steel. Or transportation, we break 80 million tons, and navigation. 7% of the global market moves by green hydrogen, and heavy load transportation systems. You can see in Brazil, companies like Ambev have the goal of having their trucks 100% being electric. So we're talking about delivery trucks. We talk about large-sized trucks. It's not that easy to do so. And energy and buildings themselves that you have in this chart. It's a shame that the laser doesn't work. But the idea for hydrogen as derivatives is that you'll be able to see production on the sidebar. You can see the commerce. So the commerce of the derivatives essentially is where we have the commercialization of hydrogen in the world. Hydrogen, pure hydrogen, it's expected that it will be consumed in the region where it's produced due to the difficulty of transporting. The cost is much higher. For few simulations of transforming this into ammonia or retransforming it or consume it as ammonia in other regions, it compensates of what you're going to have as hydrogen due to the volume, the transportation costs, etc. Ammonia leads the market commerce, represents around 70% of the global market in 2050. So for this, it's interesting that you missed the last leg of the slide, but sea transportation is the estimate of the amount of ships that are needed to transport the developed hydrogen in the world. If you have more than 300 ships in the world, it will be necessary to transport this hydrogen. Almost at the end, so we have some time for questions. So the main insights that the study brings in is very dense. It's available on the internet and the web. It's around 70 pages. There are footnotes, there's methodologies, there's calculation behind the numbers. Explains all the premises. So hydrogen has high potential of favoring climate neutrality because we need that a lot, and a green hydrogen it will lead, but blue hydrogen has an important role in the process. In case you haven't noticed in several presentations, blue hydrogen is gray hydrogen when you have to store carbon. Protectionism isn't worth it. For the market to become global and for this transaction to happen and become a commodity, it's important that countries do not close their markets. So companies must be able to use hydrogen that is imported or produced in Brazil. The concern we have from countries that they'll lose income from oil and royalties. Well, eventually, if you perform the energy transition for your export and your production, the income from hydrogen can compensate losses of export for fossil fuels like gas and oil itself. It's important that we learn these lessons. And errors will be made, mistakes will be made. Hydrogen is a new energy source, it's complex. And when it comes to the treatment of the water, production, storage, transportation, standards for all that, and make this happen in the world, it's important that we learn from our mistakes, we evolve with them, and become as reasonable as possible. And for investments, well, okay, all these investments are possible, sure, as long as you have a movement of fossil fuel investments towards renewable sources. Thinking or speaking about sun, wind, and green hydrogen. So the volume of investments for the simulation that trillion is reasonable. Yeah, just grab the amount of investment that goes towards oil and gas in the world. The volume of yearly investments for the production of hydrogen, it sure seems reasonable if you do so. The oil companies themselves have been doing so. They learn about renewable sources and the very famous IOC. Within this context, these companies, there's a forecast of that part of their investments will go towards green hydrogen, amongst other sources. Well, for on its own, it's difficult for this market to become liquid and develop itself. It's important that public agents intervene and create frameworks or stimulate the development of hydrogen. So this is aimed towards climate. So the regulation in Brazil is key. That it comes out at creating business cases. What are these business cases? Well, you don't shoot every single target possible. You pick a target, you select a sector to focus on and create a case, and you'll focus on that and you'll spread that to other sectors, and this guarantees long-term resilience. It's important that these policies are not short-term, they must be long-term. They must be long-lasting. This gives us security, this gives security to investors and consumers that this fuel or this new energy production system which is being developed, that it is constant, that it is stable. That's what I had to say. So, guys, we launched this study. It's too bad it's right in front of our sign language friend is looking at the QR code. When we launched this study in Brazil, it was produced globally. Several reports were published in Brazil from this study. These are the contacts of my bosses, my friends, bosses. They want to continue to speak, and we have open research will allow me to plug this. We are in a partnership with a Beloit, AB Eolica. We interviewed personally by surveys as well the biggest companies of the wind sector of the country to understand the effects and opportunities, increase efficiency when it comes to wind farms. So I'm gonna move out of the way so you can get the QR code. Okay, it's great because I didn't get the sign language interpreter. The QR code you can access the research. It's ongoing. It's been in the air for some days. Will be for a few days. So the ones that act upon this is no wind system. Please be part of our survey. That's it. Thank you. And I have 6 questions, 6 minutes for questions in case you have any. Round of applause for Breno Medeiros. Breno, thank you for your presentation. So please get closer to the middle of the stage. We have a few questions from our audience and also from our audience online. What are the strategies and technologies that are most promising that may allow global society to reach decarbonization in an effective and sustainable manner, looking to reduce carbon emissions and mitigation climate change, while we guarantee access to energy to all? Very well made question, I think. Well, is there a name of the person that asked? Actually, if you want to put down your name, just say your name, your surname, institution, or company you represent, okay? Thanks. Well, folks, there's a. I didn't present myself, right? Where I work. I didn't have the headset on. I work in Deloitte. It's a global consultancy company. One of the roles I have is I'm manager of a global hub focusing on analyzing, mapping out decarbonization tech in the world. So green space tech, Deloitte, you look that up, you'll find info. Okay, what's interesting, I think that connecting green space to that question is because IEA, it's in its 2050 scenario, IEA is the International Energy Agency, International Energy Agency, IEA. It's up till 2050, they give us to reach 2050 net zero, where the tech would come from. So a part of their matters is that the energy efficiency, most efficient production processes in companies, and other fuels such as biofuels. For instance, in this case, Brazil is the reference point. But near the last report, 141% of technologies to reach decarbonization, we still don't know where they're going to come from. But don't you know? Why don't you know? Where are they? It's because they're still in prototype or R&D stages. The idea, I said, when we went to the world market with British Space Tech is to map out this technology in the world, which are at a R&D stage. What is their level of maturity? But a lot of them will coming through making the economy more electrified, transportation system, the furnaces, as I said, the hydro energy. They are making their furnaces electric, so transportation systems and furnace systems, the renewable fuels, more efficient equipment. So Toyota's presentation a short time ago, it's not carbon itself the issue. It's the combustion. It's how much you generate. So more and more we're creating more efficient engines and having less emissions because of that. Next question is that in your presentation you spoke about the importance of giving stimuli to sectors to guarantee the development of the hydrogen chain. Which points should we look towards to include small and mid-sized companies in this equation? Because it's a good question, because a lot of the time we're only looking to the big guys, forget about the little guys. So please go ahead. Great, good question. I'm gonna end up. I'm gonna go to green space once again, but not wanted to plug too much. But remembering this data from IEA, about 140% of the tech that you need to decarbonize, we don't know. So that's where startups come in. Small and mid-size, the fintechs that we have in Brazil is a sort of an excellent silo for startups. I was having dinner in a restaurant. Saw a competing company in Better Swap, which is for cell phones. So the startups are a good way that you have mid-sized companies for PhD students that just come out of tech parks developing their own technologies. For instance, I was said in the last presentation for ADP, the water treatment plant. So there's a lot of options for small companies, or tech, deep techs. These are, they have a lot of knowledge applying to universities, tech studies, so they can develop this technology. There's still a lot of gaps to be filled out, but eventually you can have technologies that already exist, but more efficiently cost. So keeping in mind, this is not a cheap process, it's expensive. So yeah. Okay, actually, it's not even a third question, but it's a request. I'm gonna count with our organizers to show once again the research QR code uh, while they bring this QR code. Please explain a little bit more, go further into detail, maybe info, so that all of us can have access. Okay, great. So this is a partnership with Wind Energy. Sure, if you think about the matrix, the important thing is the regulating one. You made a good question. Merchandising of the research is not focusing on the hydrogen. It's on the implementing efficiency of the wind parks, wind farms. What is the difficulty we're having with wind farms eventually? For instance, wind farms in a very much into the inner country. There's a hard time getting the workforce to the country. So we sort of need to balance things out with the bits to the wind farms. Some of them won, some of them left. So you're going to have a new wind farm being built up. So the suppliers, supply chain, if there's difficulty, you have to import equipment. Eventually, customs gives us a hard time. So what are the big issues for efficiency? Of course, the more efficient you are, around 70% of the cost of hydrogen comes from energy. So the more efficient we are, with the parks, with the installation of our parks, the more competitive our hydrogen will be. I think open research at the presentation, there's one made available, continuing the discussion of green hydrogen. Final question, Breno. People are really liking your participation. How long do you think national companies will take to adapt to green energy? It's a generic question, but it should at least be on the radar. I think that should be the $1 million question. Not easy to answer, but one of the biggest, the global level, not just in Brazil, is on the offtake. Who's gonna buy this decarbonized product? The speed which we have, which are the segment which will absorb this higher initial cost that we can decarbonize. So eventually, we're covering a bit about this fertilizer, the creating of fertilizers. There can be maybe a path for this. This is a recent report. I think it's public, but ERA produced part of the hydrogen, part of the biomethane. Let's put that into the report itself. It's an initiative that we have to start to decarbonize our operations. So this will depend on the appetite, which which sector will be able to have some payback and our decarbonized process. So, and the fastest way will be sector which we can more quickly use and adapt hydrogen to their processes, or due to a mandatory process, the government chose a sector that will have a stronger enforcement. So actors will have to move to be able to decarbonize. So we have biodiesel in the country, and it's mandatory: biodiesel 2, 3, B5, B6. So you're going to adopt this now in this manner. You're going to do this for some segment that the government understands that will be a starting point. You like that, guys? All right, quite a bit. Thank you, Breno Medeiros, head of Deloitte, specialist in decarbonization, for your presence. Thank you very much. Really like this, and go ahead, join the audience, go back to your seat, and we can continue to listen and get more content at FIEC Summit 2023.
Everyone, let me remind you once again about our QR code. All you have to do is point your cameras this way. We are receiving your questions, and we are now going to follow on to our next theme. We're going to talk about Neo Energia, Industrial Green Solutions, and I'm going to invite the manager of Neo Energia Soluções Verdes, Industrial Green Solutions, Felipe Pinheiro Moraes. A round of applause. Can everyone hear me? Well, first of all, I'd like to wish you a great afternoon and say that it is a great satisfaction to take part in this event promoted by FIEC. So I'm going to talk with you a little bit this afternoon about Neo Energia business, which is called Industrial Green Solutions. And how we usually do, we are going to begin by talking a little bit about the institutional part of the company, how it's organized, its main controller, and from there on, we'll talk a little bit about decarbonization and this business that the company is working on. Well, if you've had the opportunity of being here yesterday at 5 o'clock, you were able to hear a little bit from our colleague specialist in green hydrogen. Her name's Victoria. She was talking about our company. And for those who were not present, weren't able to be, I'm going to talk a little bit about our company. Neo Energia is a company with over 25 years in the market here in Brazil. It acts throughout the entire energy chain from generation to transmission, distribution, and commercialization. And it also acts very strongly in the latest year in solutions, efficient solutions in the area of energy, either through decarbonization or the search for greater energy efficiency. So our company, in terms of number of clients, is the largest in the country. It has a huge market share, practically 20% of the market. It services more than 13 million clients. It's the pioneer in energy solutions and clean energy. So we have in our installed capacity for generating energy, it's for 5.3 gigawatts, so approximately 5 gigawatts come from clean energy, clean renewable energy, whether those are wind plants or solar plants. And not long ago, we had the launch of a plant that combines wind and solar energy. So about 90% of our energy generation comes from renewable energy. And our line of business within the company, it is very based on sustainable growth and sustainable economic growth. So I have some numbers here. We're not going to focus much on them, but we do focus a lot on ESG. And the company seeks to be very vigilant and is very critical in its investments and lines of business. And as its controlling partner, we have Iberdrola, which is a almost 200-year-old company. Today it is 170 something years old, and with that time and experience, acting in the energy chain, it's a worldwide energy leader. You can find it in over 30 countries, and we can see in this map, let me move over a little bit, its main businesses, among them Brazil, exactly through Neo Energia. It has strong business in the US as well through Vangrid, Australia, Japan, of course Spain, where its headquarters are. It is a Spanish group. And it has among its operations more than 100 million clients spread across the globe. And a permanent commitment to sustainable development. just like Neo Energio. Talking a little bit about emissions, this slide was also projected yesterday, created yesterday. We have a few sectors. We actually have a division of sectors that comprise emissions. So we have energy, agriculture and husbandry, and industrial processes, which is where I'm going to focus most here. In 2021, this is not an exact number, but recent numbers point to the growth of this percentage in industrial processes, a growth of approximately 6%. So what we imagine that can be decreasing is actually still growing. And that's how we provide solutions to the market to promote this energy transition sustainably, solidly, and also seeking to be the most efficient as possible economically and to promote cost reductions and not just emission reductions. Brazil is the seventh largest CO2 gas emitter, and this represents 3% of the world total. So there are a number of industrial processes within its matrix that contribute together with other sectors, and Brazil is ranked as the seventh largest emitter. Now diving into industrial details a bit historically, our industry is a high consumer of fossil fuels for all of its processes in several steps of those processes. So a lot of industrial units use fossil fuels to obtain, transform this energy into heat. So whether it's to produce vapor, to produce hot water, you burn a certain fuel to obtain this use. That is, and this byproduct is then used in the rest of the process. And of course, this generates emissions. Decarbonization, industrial decarbonization through electrification came exactly to promote a combat against climate change and to promote this transition from a process that emits to a zero emission process. And our emissions, we are coming forth to the product, promoting solutions that do not result in CO2 emissions. Therefore, transitioning in a clean way. The industry's electrification is going to promote an entire chain that is found in its surroundings. It'll provide energy efficiency, revitalization of the industry because new systems will now be applied, and this will favor the industrial scenario. It will also favor continuity of the implementation of generation assets for clean energy. It will contribute to decreasing prices of this energy because it promotes a cleaner and lower cost energy and therefore reduces emissions as well. And it will also promote a greater digitization of the economy as a whole. All of this will result in the elimination of emissions and will also mitigate the impact of the industrial players in terms of being susceptible to the high volatility of these fuel prices. We don't have a metric, a linear metric for correcting these prices. But today, those prices are fully susceptible to very sharp ups and downs. So we'll be able to promote a more ideal financial planning. I'm sure that everyone here has been following this. There is a path that is being taken today regarding we're not dealing simply with let's transition our energy so that we can reduce emissions. Yes, we are, but there's more to that. The competition will certainly and is certainly already has its eye on the benefits. So the companies uh, that are ahead in this transition will be more competitive and more prepared as of now for this environment. The European market today, it already applies fees to the emissions of its industries. So this is a natural, something natural that I see that will happen in Brazil sooner or later. It's already being discussed by the government. We have some bills of law that are being discussed, talking about carbon markets, a way of regulating that market here in Brazil. So that industrial player that anticipates this, they will be able to avoid a future cost simply for existing, simply for maintaining its operations as they are today, and will certainly be more competitive compared to other players. So what would green industrial solutions be? Before we actually talk about that business and about what Neo Energia is bringing to the market, I would like to take a minute to reflect about crisis. So from time to time, society as a whole goes through moments of crisis, whether it's a drought, floods, hunger. Recently, we went through, we have the conflict of Ukraine and Russia. 2023, and we still have countries in conflict and at war. But especially this conflict, not just due to its negative consequences, it also brought it also called the attention of the market in the sense of the dependence we have on on fossil fuels. So what we see is that the crisis is also a reason for new ideas to arise, for innovation, for development, to create a more sustainable environment. And thinking about that, industrial decarbonization was put under the magnifying glass. And as I said in the beginning, one of the companies where this business is in place is Brazil. And we're bringing to the Brazilian market the notion of green heat. And this is exactly to promote the energy transition and the increase of decarbonization in industrial processes. So when we address the industrial sector, we create a roadmap based on the amount of fuel that this industry has consumed. And we translate this into how much it is emitting in terms of CO2. Of course, this is guided by a protocol. And from there, we create an economic feasibility study that tells us to perform the transition and how to obtain the best results with this transition. And the management of this entire process that goes from the best design and engineering to the logistic of acquisition, acquiring the the devices, implementing the systems, and the energy that is going to keep the system moving, which is usually an electrified system. Of course, we're talking about decarbonization, so the energy we consider here is a renewable energy, a clean renewable energy. So we have a graphic representation here. It's pretty simple, where the electrification of these industrial processes, it can deliver these utilities, hot water, cold water, vapor, among others. This proposal that was launched in the market, it's fully aligned with the SDGs from the UN, and now we are mentioning some of them where we have number 7 in terms of obtaining of having a responsible attitude with the technological goals, solutions that allow a differentiated consumption standard, and the formation of alliances, because we understand that every chain has to be united in towards these goals. And we've been seeing that a lot here in this forum, where our focus theme is green hydrogen. So we need a mobilization by the chain so that this happens with speed. So the green industrial solutions that Neo Energy brings and Aegea brings are based exactly on these requirements that I just mentioned. We have a 99% renewable plant promoting solutions and not products, because our solutions are customized, so they are designed and idealized according to the needs of that specific industry. So the provision and management of this energy and everything is devised in a way so that our clients can remain focused on their core business, on their operations, so that they can go from a production within a environment that emits to one that doesn't. In terms of benefits, we can mention several. Cost reduction is one of them. As I said, and it has been emphasized at this forum, we need to promote a solution or solutions that are economically feasible. So this business proposes cost reduction and the predictability of those costs. So corrections have to be predictable from the beginning of the project and bring economic comfort to the industrial sector. Reduction of the emissions in themselves, increment of energy efficiency, providing more sustainability, and adding value to the brand, so we have a tangible asset there. This player will be able to communicate to its main stakeholders that this energy transition is that it's reducing emissions and promotes optimal controls of its processes. So what do we want? And what does society expect? What are these commitments? The ones being discussed globally, what do they seek? To leave an economy with high emissions to one with zero emissions. So to reduce dependence on fossil fuels, higher energy efficiency, electrify through clean and renewable energies, reaching ESG goals, SDG goals, and overcoming these challenges that are present. The projections in terms of climate temperatures have been altered and changed recently, so the economy and everything connected to it have to be highly committed to this energy transition and to it happening sustainably and shortly. All of this to make all of these goals feasible. So what I intended to say was short. I just wanted to bring about the need for the industrial sector and the commitment that our company has before the market, offering these solutions in a very transparent way. So I would like to thank the event's organizers once again, and we are available to talk with you a little bit more about this theme. Thank you very much. But those of you who are at home, seeing us in Virtuali, the virtual platform of this event, or FIEC's channel on YouTube, participate with us. Now we're going to have the pleasure of talking about Fortescue, the green hydrogen plant in Pecém that belongs to Fortescue. It was the first company to sign a production contract at the Pecém Hub complex. So I'm going to invite the planning leader of Fortescue. He's not here yet, so I'm going to ask you. Danilo is a little bit delayed. We're going to have a brief interval here, a 10-minute interval, and continue with the program.
This is the final panel at the technical auditorium here at FIEC Summit 2023. And I'm really talking about something that's very important because here you can see the first ever player to create such a great complex at Paysanne. I'm bringing here the leader, Danilo Campos, from first skill. A round of applause, please. Good afternoon everyone. Can you hear me? I'm Danilo Campos from Fort School, and I wanted to share with you the project that we are currently implementing in Pecém. And I wanted to thank FIEC and your presence here. I'm waiting for a shorter reunion, so please take take the QR code so you can ask and we can use the time that we have here. This is the last one of the day, so thank you very much for your presence here. Let's start. Well, for the beginning, I apologize for anyone that has already been to other talks. I'm going to present Fort School once again, and we are a company that is from Australia, is relatively new. So we are becoming a neutral zero emission company, and we don't want to just compensate. We really want to do the real net zero emission company. Mm. This is a company that wants to build its own plant of hydrogen. So we want to begin by making our own company a net zero company. The net zero is a need. We see it as a need. So once that being done, we will go after our second dream, that is turning the whole world a net zero emission world. So this is why we are leading a green industry revolution, and we are doing that here in Pecém and other places in the world. So how we do that is that we are recognized for our culture and innovation. We are also developing a global portfolio of hydrogen and ammonia in the renewable sources as a global company. And this is, I also want to share why are we here in Brazil. We also are developing technological solutions for industry with the commitment to decarbonize. So we are also committed with technology for the whole chain so that we can really have a net zero production. This is a somewhat emblematic slide, and this is the reality. The climate change is a reality. From our position, our perspective, we see it as a reality. So for those of you those who doesn't believe it, we believe it. And I don't want to get too deep into the Paris Agreement, but we already know about the average of temperature, and but this is a really important one. The net zero emission should be available at an industrial scale and globally the fastest as possible at a competitive price. And what I have to say to you is that the capitalist doesn't want to hear about sustainability. It has to have a competitive price. So it's not only about the sustainability. It has to be price derivative. We need subsidized investments as it happens with oil and coal, and but the market, the capitalist market, doesn't want to know about sustainability. It wants to know about price, and that's why we are working intertwined with the government so we can get there quickly. This next slide. The world we want. It it is born in a compromise to decarbonize the planet. It was What's hydrogen? Hydrogen is an not toxic material that can be stored uh, for long periods of time. It's- It doesn't have color, odor, or other characteristics, and is the lightest and smallest one, being even 14 times lighter than air. It's the lightest one of the universe. I will talk a little bit about FFI in Brazil. Why Brazil? We are in several countries, such as Africa, the United States. So why Brazil? Brazil has a giant potential in renewable energy that is already explored, but we see it as just the tip of the iceberg. And the fact is that Brazil is a continental country with an interconnected grid. So if you look at Brazil, if you look at Europe, the interconnection that we have here is way superior than the one they have at Europe. And Brazil has already solved the problem of interconnectivity between such long distances. So Brazil has the infrastructure and the amazing potential that only sums to make Brazil a great case. When we study international cases, we see McKinsey and other consultancy services that shows that Brazil already have a great price for hydrogen, but that's not enough. We have to address other parts of the equation, such as the government and the private sector. When you look at Europe and North America, there is a great connection with Brazil, and so that's why Brazil. But why Ceará? Ceará is the ideal state for us to begin the production of green hydrogen because it shows really as the most promising state in the most promising country. So that's perfect, really. So Ceará, as entrepreneurial as it is, you can see here at FIEC Summit there's a big fair and it has been really well set up. We know that there is an infrastructure. We know that we have in Ceará a HV hub at Pecém, that is SIP. You also have a great portuary infrastructure such as Pecém. You have great laws that were bills really that was developed here for new technologies. You have a lot of investment in renewable energy. The grid, the Ceará grid is already very renewable, and there is an interest of the government to invest in education for this area. So that's very good. The next topic, and talking about the power plant that we are building. This is happening in two phases. The first phase is what 1.2 gigawatts, and 900 megawatts. So we're talking about 2.2, 2.1 gigawatts of power. If you were to simplify the project, we have the transmission line that will bring this energy from the grid to us. And I will talk a little bit about this energy, where it's coming from. We have a desalination plant so that we could bring this unsalted water. We have the electrolysis plant that what turns water into hydrogen. We have a storage and compression plant that stores the product that we are generating, and also the corridor that's what takes the product to the ships. And Fortescue sees that the market is keen, really, to buy this hydrogen. So today, our product is 100% exported to Europe. But of course, with Brazil being developed with a green industry, really, and we don't want just to sell this hydrogen to Europe. We want to use it here. So we see a industry that needs to be developed here, and so that we can bring this hydrogen and the ammonia inside the country. So I will spend a little more time in this slide. The left one first. I will more narrate because online can't really see where I'm pointing at. The first slide, the left one that you are seeing in the YouTube video, you can see a partnership that we have with energy producers that are spread out across the Northeast. Are we going to generate 2.1? No, we are talking about 3 to 4 times that. So it's 6, 7 gigawatts of energy that is being generated there. I don't know if you saw yesterday the lecture that was made about certification of green hydrogen. And firstly, we need to prove that everything that we produce, we are consuming. So you have the sunlight and at the nighttime, you have the wind, no wind situation, but we need to actually consume 2 to 3 times more than we are generating. So we generate all of the energy, put that in the grid. There in Pecém, we get from the grid and consume that in the plant. So what we have to prove is that everything that we get from the grid, we are consuming in the plant. So we see everything being generated throughout the Northeast. They are throwing that in the grid. They are putting that through the grid. We are getting from the grid and using it. So that is on one point. The second point is that we have to have a desalination plant. So we get the water from Pecém, from the sea. We desalinize it so we can use that water in our electrolysis. So we have quality energy, good quality energy, and good quality water. But we don't stop there. That's one part of the puzzle. On the right side, you can see the best balance of what's needed, really. We are not going to transport hydrogen because it is very hard to transport. So to make it easier, we turn that into ammonia. We turn into a liquid by 33 degrees Celsius, and then we transport it. And then we take it to Europe, and there we decide if we're going to sell ammonia or if we process it to transform back again into hydrogen and then sell it. So let's see this. We have 3 great inputs to the system. First of all, we have seawater, the seawater comes in. This is 106,000 tons of water, of seawater, coming into our desalination plant. It goes through reverse osmosis, and half of it comes out with double the salt, and half of it enters the electrolyzer with no salt. So there is really a plant there. We are talking with companies that already are executing those kind of projects with desalination in the Arab world. And what we are doing is that we are processing that water. So what happens is that we get that pure water, some that with the energy that we are bringing from all over the northeast, and this is what happens in the electrolyzer. Can we do something with the oxygen that comes out of that equation? Yes, but right now we don't have anything to do with that. We are planning to see what we can do with that oxygen, but not today. So what do we do with the hydrogen? We grab nitrogen from the air, then we get hydrogen and nitrogen and create ammonia. And everything that I'm talking here is very old. It's been a long time since we began doing that. Ammonia is a process of over 100 years. Are there newer processes? Yes, of course. What changed? What changed really is that we are using now renewable energy. Renewable is really expensive, and it has been lowering its prices. And newer technologies really helped in lowering those prices. So what's happening that renewable energy is now substituting oil and coal. That's because of the price. And that's why we are talking about green fuel. So we have hydrogen, we combine it with nitrogen, and then we have ammonia. And damn, we put that to the port of Pecém. And right now we produce 4 and 725 tons per day. And to talk a little bit more about the project, here you can see at the south, 1 and 2, that's where we stand. This is our main plant. It's where we produce the hydrogen. At the one, you can see the H2 is where we really separate the hydrogen and combine it with nitrogen to get ammonia. The second one is the storage part. And I will talk later about storage and where we are at right now. But our basis project at the power plant that we are is the main one. But we have a project right now with the hydrogen hub, and we are empowering that project together with PECEM, is going closer, and you can see the other two is where we store it closer to the port. It's a shared infrastructure. And yes, it's better because it's closer, and it's cheaper because it's closer. But it's very good. See that we have that kind of infrastructure there available to us. And what we have at 5 is that you have the entry point of salt water and the exit point of ammonia. Number 4 is desalination plant that is at the beach. And there you have the 2 points where you have the entry point for seawater and the exit point for water that has double the salt. They also have the port where we can load the ships and that will be transported to Europe. We also have to take energy from the grid, and there you can see how it happens. We also have other studies and options for water and energy. Water, we are thinking about reuse with a public-private partnership to grab water that comes from caches, or so we are using sewage water to use the electrolysis. So that would be even greener, right? There's another option that we have for the water, not only desalination but also sewage reused water. I have already commented on this. We are closer to the port. We are at the port area, and the other parts about the ammonia. Where are we at right now? We went to the public hearing in August. We are in the phases of pre-viability. So we are choosing what's the project that we are doing. So we have to sit down and decide what are we going to do. We are in this phase right now. We did two reunions with two meetings really with Coema. I've just arrived actually from a meeting with Coema, and it was really good because we just been approved. It was really good. Applause from the audience because it was approved. Thank you very much. So I came from there to here. It was approved in the council. They will still announce that. I can't really spoil their announcement, but I already did that. And we are now going to the second stage, to the viability stage, where we choose the project, then we go through the licensing for installment, and then we go to the third phase, that is construction. This is 36 months for the phase one and another months for the operation. A little bit more about construction. There will be 48 months total. This is 36 months to installment of phase one, that is 1.2 gigawatts, and 24 months, that is taken from the 25th month of the first phase all the way to the 48th month in the end, so that we can get another 900 megawatts. So what we are talking is that the generation actually accounts for more than half the project. So it's a very challenging project. We need to understand certification, consumption, because it's a lot of investment, it's a lot of risk, and we need to mitigate those risks. We need to reduce those risks for our shareholders. So workforce, estimated workforce for this project is with an average of 3.3 thousand employees per month, with a peak of approximately 5.5 thousand employees by the 33rd month. So, and we are talking really about 5 work fronts that are simultaneous. One for the production of hydrogen storage, desalination, compression, and one for the transmission line. So there we have a overlapping of phases with that will have a peak of the workforce, as I mentioned earlier. Next slide. Okay. So, wrapping up, we can't do that alone. As I've said before, we are growing stronger bonds between a lot of the players. And here at FIEC Summit, we've talked with a lot of players. We've been working together, but we need to do that. For the size of this project, we can't do that alone. We will need help from everyone, from universities, from the academics side, the, from the politics, so that we can really achieve what we are doing here. And we see this project as the tip of the iceberg. It's just the tip of the iceberg. It's the tip of the spear. And what we are seeing is a whole movement of green industrialization. And Ceará can be the protagonist of that in the world. And that's not little. It's a really big opportunity for Ceará, and we need to seize it. We have the vocation for that. Brazil is very privileged in that. But we still have a lot to do. That's what I have to share. Thank you very much. I believe we have questions, right? But thank you, everyone. Questions? Just a minute. Okay, we were checking for questions. Let's go to the stage, Danilo. We have two questions. The first one, analyzing the potentials for foster care in the future. What are the profiles, job profile that you are looking for? And that's a good question. You are not only one company, you are 3 to 4 companies. And I will remind you that Fortescue was one of the first companies to sign the contract. So please address this question. Firstly, thank for the question, and this is fundamental really. And I will answer in 2 parts, 3 parts actually. Soon enough, when we get to the engineering phase, we will really have a body of work here in Ceará. When we really have a need for workforce is the construction phase. That's a lot of months for the construction side. And I'm not only talking about painting and hard work really, but also the management part of such an enterprise. We need planning, general services, and this is such a big project. When you haven't worked that with such a big project, you don't really grasp the amount of work that is needed for such a huge project. There's 5,000 workers at the peak. So to see them, when we need, what we need is a professional that is that has the knowledge in management. And so I've managed projects all my life, and I see potential for those that are seeking knowledge in that area. Really, I'm being very honest here. There, we don't know yet what is the profile of the operation workforce, but I have to say that we have a highly automated plant, but we will need a workforce. It's a very reduced when we get to the phase of operation, but for the first phase, if you light project, you also have great potential. And the next one is for and if you reduce workforce, of course, but it's still an opportunity. The second question is, how do you evaluate the environment for business? here in Ceará. Regarding the hydrogen area. And we know that there are a lot of opportunities, but please address this question. I have to address really thinking about all of the environment. We are located inside a environment, so we need to understand that there are a lot of cities around us that can be developed further. The local suppliers with services, safety, equipment, and everything that we consume from the region. But if we are talking as an industry that is Cearense and also Brazilian, we need to talk about the local industry. And it was very explored in the oil and gas industry. We still need to address that in this industry. It isn't very clear how we are going to address policies for local investment. But those are really important topics so that we can develop a Brazilian industry. And that's a great point. Thanks for the question. We have another one. In your presentation, you reinforced how it is a great sustainable project. So, how can we really maintain that profile? How is that work being done to maintain that project as a sustainable one? This question is a very hard one. You left it lastly. Can we read it again? In your presentation, you reinforced the sustainable part in such a green way. So, what's the challenge to do that in a green way? So, talking about the green part of the construction site, we know that there are several technologies that have been used in the construction site that are not really sustainable. So how do we do that? Actually, Brazil has a long history with great enterprises. We know that there are some building companies that had problems, but we know that there are companies that can really be a part of that growth. And we know that there are companies here that have that kind of expertise, the green expertise. And if you allow me, I would like to call someone else to help me. Please, let's call Paola. Paola was here yesterday, and Jean Paula, she's the environmental director. Even more because this is a very important day because they were just approved at Coema. And yes, we are very happy to share that with you. It really is a great step, a very important step in the project and for Ceará, really, so that we can be together in the enterprise. Talking a little bit about sustainability and maintaining that sustainability, the fact, yes, is that our industry is a clean industry. We are using water, grab air, and magic kitchen, and boom. But that's not really how it works. As any other enterprise, we know we have some impacts, and we are impacting socially, environmentally, and we need to mitigate that. So yesterday, I talked a little bit about EIA, and how we experience that by risk assessment, so we can have a concept that has been approved, and we will refine that. And in this refining, we also think about social and environmental impacts that come from such an enterprise. And there we will have the plans so that we can reduce, and we actually want to eliminate it. But if we can't do that, maybe we can reduce it, and that's what we are going to do. If we can't really eliminate, then yes, of course, we'll suppress some vegetation, and we need to take care of fauna and flora for such a project. The other point is, as Danilo talked about that, we are in the phase of developing really the model. We are going to look for a design that is safely, that is safe and sound for the environment, really, a better design. So, uh, what about the new technology that will be generating a better footprint, or maybe choose a tool that I can change and maybe take out a gas that was impacting the environment for one that doesn't. So you can see there that we are going forward with a more net zero production. And that is that what we are doing right now. We are working towards a net zero emission company. And we need to do that so that our production can be clean as well. Yes, we are going to generate residuals, but then and there we will work with the processing of those waste so that our plant can be sustainable. So right now, what we are doing is designing, is developing, and looking for the best alternative in a technological way that are possible right now and later on. So we are thinking about what's better for the enterprise, but also the selection and choosing the technology that will allow such a sustainable project. And obviously, we are trying to balance this matrix. If we can't zero it, if we can't really eliminate, if the technology doesn't allow it, then we will have programs so that we can balance that zero. How we will compensate that footprint? Then we will monitor it during the operation so that we can understand our footprint and then mitigate it. And then we buy it. What we are doing is going to a net zero emission company. So the trend is there. We want to get there as a main goal for FOTSQ. This is how we look at it. This is our strategy. A round of applause, please, for Jean Paola and Danilo. Danilo will just uh, talk a little further. I want to thank really for the questions. We are here. We have a stand there in the event. Please come there and we can talk a little further, change cards, remove doubts. And I wanted to really appreciate you coming here. This is the final presentation. We still have Peaches here so that we can watch the videos that will be exhibited here. Well, thank you everyone and good event. This is Danilo Campos, the leader of Fortescue. It is great seeing you here. A beautiful presentation. Um, as Danilo has talked, his share there will be available for further discussion. I would like also to add that Felipe Pinheiro Moraes is here. This is Felipe of Neoenergia Green Solution, and he was here for the last panel, and he's also available for doubts and conversation. He will be glad to answer all your questions. Everyone, I'm here inviting you right now that is here or remotely. Now we are very pleased to celebrate the conquest, the achievements of everyone at Ceará. By March, Senai SESI NL made public bidding, an announcement, a notice of works, of projects in the certification, distribution, and processes for green hydrogen and its derivatives. So everything we have been talking about for the last 2 days, the chain of the green hydrogen, the you could sign for that program by June, and that was great for research and works. They were evaluated in two categories, that is research and academic. In total, 7 projects were selected, and 3 actually were really elected as a tie, really. So they were presented and stand here, and they had the opportunity to share their projects here at FIEC Summit 2023. And right now, with a lot of joy, we are going to announce the 3 videos of each of those categories. And they are winners of this competition that show the excellence and innovation that the scientific community and academic can offer, and us that really organize this event are very happy with the results that were obtained with such projects. So the second place w- that was about biohydrogen and biomass. This project had Stefania, Maria, and Tiago. A round of applause for them. They were great in this project. And as a second place,
Biotecnológicos GPBio.
we
E
have the
hoje vou apresentar
paper
para
of
vocês o
tokenization.
trabalho acadêmico
It's
intitulado
the audio
Produção
is
de
already
biohidrogênio
playing,
usando biomassa do
is
céu.
leaking. Please stop. Okay, okay. Just a little. Okay, the second place, the paper, the role of tokenization for the complex of PECEM. That's Danilo, Roberto, and Paulo. A round of applause. The authors really of such a great project. And for the first place, the construction of photocatalytics production being obtained from glycerol. And this is of Mayara, Josiel, Antônio, Rinaldo dos Santos, and Bruno César Barroso Salgado. They all deserve a round of applause as they were the winners. And right now, yes, we are going to watch the videos, the 3 videos that represent those that won the prize. So let's watch it together, guys.
Biotecnológicos GPBio. E hoje vou apresentar para vocês
Today
o
I'm going to
trabalho
present
acadêmico
the
intitulado
academic
Produção
work
de
that
biohidrogênio
is
usando
titled
biomassa do Ceará.
Production of Hydrogen
Desenvolvimento
using
de processo
Biomass in
sustentável.
Ceará, the development of a sustainable process.
Esse
This
trabalho tem autoria de
project
Carla Reis, Gabriel
was authored
Simão,
by
Stefane
Tiago de
Moreira,
Albuquerque,
Tiago Albuquerque
Maria
e Maria
Valderez,
Valderez Rocha.
Gabriel Facundo, Estefânia, and
Primeiramente,
Carla.
queremos mostrar para
First of
vocês
all, I
por que
wanted to
considerar
share
uma rota biotecnológica
why
para a produção de
the
hidrogênio.
reason that we
Dentre os motivos, temos que estamos dando uma
consider
finalidade ao
a
resíduo agroindustrial.
technology that
Além
uses
do
such a
que,
route, such a
utilizamos
biotechnical route for the
micro-organismos que
production
podem
of
crescer em
hydrogen.
diferentes meios de
We
cultura e produzir,
wanted to
além do
address
hidrogênio
a
na
few
fração
topics such
gasosa,
as the microorganisms that can grow in different mediums, also technologies, and the co-products of such high aggregated value, and the use of renewable and residual biomass that are abundant. So what we are doing is that we are producing bio H2 using residual from the agro-industry. So that comes from the bacteria Enterobacter cloacae. So what we do is that we use the residual from caju, a fruit here in Brazil, and that can be converted into sugar and then used for the production of several other products of higher value. And that's our goal as a research team. between those products, we have ethanol, glucose, and other ones. What we did was get the caju to be liquefied and get that liquid part and have the pH adjusted, and the solid part being used to obtain a solid and celluloses and lignine and other processes that with temperature, where you can see right now that as a result we had 0.59 milliliters for every milliliter of hydrogen, and we have a median of almost 30% average, really. The value, the price of the hydrogen is just 60 cents for a dollar. This research reached great results and has the potential of production of clean hydrogen. We still, we identified even some additional steps for later on research. Concluding, summarizing it, what we presented today was something really good. And we want to thank our team and the supporters. Thank you very much for your attention. A round of applause. The second video right now. The role of tokenization to leverage new exportation of green hydrogen produced in the SIP. I'm a student at Uni4, and this research was also conducted with Rubens Oliveira and oriented by Roberto de Paula Aguiar. Looking further in the research, the tokenization of green hydrogen through blockchain can really revolutionize international commerce of such a resource because it guarantees the immutability of the data. In the introduction part, we approached the climate change that emerged really as a main challenge, and we see green hydrogen as a great medium for such a mitigation of gray and black energy. And we see renewable energy as a real resource here in Brazil for the production of green hydrogen. And that's what puts Brazil at the forefront of the exportation of green hydrogen. We predict a demand, a buy side of a rising aspect by 2050. And our work shows that tokenization can leverage such a commerce, the exportation of green hydrogen. So our goals were to show that tokenization can really be a catalyzer of exportations of that product, and also present how tokenization can reduce costs in that transaction. We move on to talk about the global market of hydrogen, and we know that there are countries in Europe that are buyers and countries that are producers, suppliers in Africa and Brazil. And certification is really a big part of that process because without certification, you can't prove 100% that that product is green. Is green. And so tokenization adds safety by putting together transparency and trackability of such a product. So what we did is we used what was available in the market in a qualitative and quantitative matter. And what we did was compare commodities such as soy, corn, and other commodities with the tokenization of green hydrogen. And by doing the tokenization of such an active as soy and corn and other commodities, we saw that it was possible to reduce managerial costs and taxes, and also the use of those tokens, even before export, also reduce the cost of supplier because it lowered and it was due to the intermediation of blockchain. It's something that is available 24/7. So the conclusion is that tokenization can bring a lot of benefits to that are highly competitive for the green hydrogen hub. Ceará has a privileged location when we talk about energy, and is also can also be benefited by all of those possibilities that blockchain can bring. So that's it, and good event. Round of applause. For the next video, my name is Mayara Mara Rocha of Oliveira. I'm a student for the post-graduation, and I'm being oriented right now by Dr. Bruno Cesar, and our work has the title of the construction of photocatalytic plaques for the production of hydrogen from glycerol. The production of green hydrogen is all about reducing the carbon footprint and reduce CO2 and other. And we see that if we don't do anything, the amount of CO2 that will go into the atmosphere will more than double the next coming years. So we see that Japan and Australia are already on the way of developing great deal of technologies. And electrolysis actually presents a lot of disadvantages with, and there is the need of high quality water. So when we see biomass and photocatalysis as a great technology that can be used to reduce that footprint. And we know that there are a few challenges still to work towards such a technology. And we see strategies such as using the visible light to help those uses due to the high cost involved. And maybe you can use some metals to sacrifice in that project and to make it better. So in doing that, it goes to a better place in the environmental and economic side. So what we apply is a catalyzer that can guarantee a more uniform distribution, but secondary applications really make a difficulty when we are talking about this problem, and it can solve such problems. Our work has already obtained some results, such as the recomposition of the photocatalyzer, and there is the performance of part really as well. And there is the isolation. Those our results where was obtained an average of 316 millimole per meter square. So considering the platinum, then we see the amount that we are using really helps the project. About the performance of our plaques, they were doped with zero point 0.1 and 0.3% with several processes, and to be recyclable, it's actually very important. And we see that separate and isolating. So a practical solution is really to use the thin film. In using it really simplified and cheapens the process so that we can do that in a higher scale. And to sum it up, the plaques were manufactured so that we could use that with high pieces of hydrogen, and they are efficient in superior values than what we are used to. But it was really fun to see how we needed to reduce cost, and this research has as an, uh, the high doses and low doses of platinum, the performance, and it was really nossa, cara. And I appreciate you. Thank you very much. A round of applause for our three nominees. And right now, let's go through the three nominees in the research project, really. The third place, we have the production of hydrogen using liquid manners. I ask you for a round of applause for the people that are part of that team. Second place, team that is very large one. Pedro, Daniel, Francisco, Carla, Fred de Andrade, Fernando Leite Lobo, André, Valente Bueno, Kelma Maria dos Santos, Pires Cavalcante e João Pedro Melo dos Santos Martins, além da... Merecem todos. They deserve a round of applause, really, for being in second place. And thank you for you all that are here in this auditorium. And for the first place, there is the project entitled Monitor and Detector in IoT for gases that come from the processing of green hydrogen. And we have the team here. A round of applause. And I invite you all, really, and who is here through the event, to watch with us the videos for such a great project. Hello, my name is Paulo Henrique Pereira Silva. I'm a teacher at University of Fortaleza, and I'm here together with Professor André Gadella, also a professor at Unifor. We are here to present our project at FIEC Summit. Beforehand, we would like to really appreciate the opportunity to be here and share our knowledge in this project that is being developed and somehow contribute with the production of green hydrogen in our state. I would like to appreciate and congratulate the organization of such a relevant team to be share in such a important area, for our state. Well, the title of our project is Production of Green Hydrogen in the Treatment of Sanitational Effluents through Electrolyzing, aiming for the reduction of costs in the supply of water that is adequate for green hydrogen power plants at industrial complex of Port of Picém. Talking about the decarbonization process that we need right now due to the exaggerated use of fossil fuel resources brought a lot of consequences in the last decade. Amongst them, we can see the climate change that, in a very bad way, promote several consequences on a global level, really, such as the melting of the polar ice and the increase in the amount of drought that we are facing are really global consequences of all of that. And the matrix for Brazil is mostly renewable, so within that we see green hydrogen growing as a matrix really in Brazil, but Ceará being at the forefront of such a development. And but now, right now, we need to address some challenges really, because we have a problem with water supply in our state, and it can't compete with the supply of water that is needed for such a project. And that's not a problem, and there are other problems such as access to sanitation and the amount of water that is wasted really in that process. So what we did was study the use of that water, the sewage water, that can be used also as the entry point for electrolyzing. And who knows, it can also provide water for the production of hydrogen and green hydrogen in your formation. So to look at it in a more holistic way, beyond really processing the water, the sewage water, and processing in a good way, you can also produce H2, and the value can be used to amortize really another projects such as photovoltaic production. And that's the water that is also going to be used to produce hydrogen and has a great potential to be even cheaper. And we are going to do a study on the financial viability so that we can test that hypothesis and see if that power plant can be financially viable financially. And this project really is justified by itself, knowing that it attends to three goals of the SDGs by UN. 6, 7, and 13 are within our scope and is within our context. On behalf of University of Fortaleza, we appreciate your attention. I share with you my contacts and also Andre Gadelia, and thank you very much for the attention. My name is Pedro Henrique. I'm a student for Federal University of Ceará, I was oriented by Professor Mona Lisa. What I wanted to share right now is the production of H2 wind solar energy. Nice. This project is closely related with the chain since we are talking about residual water, wastewater really, and they are using salt water. Here you can see the chronological flow of the project. In the second stage, we have the requirements that are being and the fourth is about installing and testing the system so we can evaluate the prototype for the production of green hydrogen. And of course, we have the realization of system and a technical analysis. And the sixth and last one, we have the production of technical documents, to share it scientifically. The distillation, the ionization, the material that is being treated, and the purification through reverse osmosis. And the last subsystem is destined to produce green hydrogen, and we have the electrolyzer pair type. It's important to notice that this project uses a wind tunnel as a tool to simulate different wind speeds so that we can understand distinct potentials of wind power. And we have a great technological experience for the creation of the technological chain here in Ceará. And we hope that this project can really gain interest from the industry and we can have the opportunity to internalize more technology of the green hydrogen chain so that we can draw more investment to the research and renewable energy sources, even though we still have an incentive for decarbonization and sustainability of cities and the adoption of a circular economy really that can proportionate a better benefits in a social and financial way, in the way that we can also train the human resources that are will be qualified for the green area and innovation. Thank you very much. Hello everyone, my name is Max Moran and I'm representing WES on the project for monitoring and detecting in IoT for inflammable gases for the habitation of green hydrogen. We are a student of WES. Today, none of the fuels, such as butane and GLP, are controlled in a specific way. In this example, just to illustrate, you see something weird. You see that a cat went to got into a restaurant and caused an accident. and that was what caused a flame, really, and it resulted in a fire that caused the building to burn to the ground. And it was due to a lot of other causes. And you can see that we have problems with hydrogen. You can see an explosion with hydrogen. And you can see that there are a lot of accidents when you talk about hydrogen. And the human factor is pointed as the main cause of those accidents. So what happens is that the global market of green hydrogen must get to a point where we have a $1.4 trillion market by 2050. And Brazil is at the forefront, really. And Ceará is heading that inside Brazil. And what we are aiming to provide is IoT, so that it can work with two techniques, the fusion technique and the fuzzy logical technique. In this illustration, you can see that we have sensors that are in the environment capturing signs, and this is what will work as the fuzzy logics. What happens is that we have a laboratory, for example, where it's being monitored second by second, and the algorithm identify those parameters and not having a binary response, then it crosses informations where we have 0 to 1 with various possibilities of answers. So the way that we will act is through a watch, a smartwatch or a phone, or even close a valve. If it has a solenoid, for example, if it's energized, then it will close. Benefits of such a device: that is very cheap to assemble such a device, such a sensor, and it can detect a lot of other inflammable gases. It is also ecologically sound, as the case of the device is produced using PET bottles, filament. The cost of the project involves acquisition of equipment, some resources, and the possibility of 6 months of dedication within UECE infrastructure. And this is the amount that we are talking about. I see a schedule of 14 weeks with the possibility of implementation in phases. You can see that the blue part is what has already been executed, with this being really done until the end of the year. And this is the team. Mona Lisa, that has a PhD in mechanical engineering, and Marcial Fernandes, has a PhD in chemical engineering. So let's go to seek a bigger safety in research of green hydrogen for a safe and sound future. Ladies and gentlemen, I would like to ask for a little more of your attention. For you is for everyone here present and you that is here remotely as well, that this is the moment to close our technical auditorium at FIEC Summit 2023, and is also a moment to really appraise the sponsors and supporters and everyone that came here to share their knowledge. And I really like a round of applause for every single one of our speakers. They share a lot of knowledge in those 2 days. I would also like to share the round of applause to our infrastructure, for everyone that is really involved in delivering this project, and the industry of Ceará that was here as well to provide such a great infrastructure. And a round of applause to you as well that was here and has been here, and to you as well that was following along remotely. We're all indispensable for our success, and it was a really great success here. We see the FIEC, the NCNI declare right now that this technical auditorium is closed. So this is when we invite you all to be in the next initiatives that are being promoted by FIEC, and already an invitation to be here in 2024. Good night, a good rest, and thank you very much to you that were here remotely. A round of applause. Good night, and see you next time. Thank you.